everyone gathered here. We are now on the day 2 of the National Seminar on Advancing UDA for India's MAHASAGAR's Vision and its Realization. Yesterday, we saw a number of thoughtful panels on the importance of UDA, and today we aim to delve deeper and hopefully provide rich insights that you may take away from today's meeting. With us today, we have a special guest. We have General Manoj Pandey with us today. I request him to join us on stage. General Manoj Pandey, PVSM, AVSM, VSM, ADC, who served as the 29th Chief of the Army Staff, commissioned into the Bombay Sappers in December of 19. He was the first of engineers to be appointed to the position of Army Chief. Over the course of his distinguished 4-decade career, General Pandey had several critical command and staff appointments. Prior to his tenure as the Chief of Army Staff, he served as the 43rd Vice Chief of the Army Staff, the General Officer Commanding-in-Chief of the Eastern Command, and the Commander-in-Chief of the Andaman and Nicobar Command. His extensive operational background includes commanding the 117 Engineer Regiment along the line of control, as well as serving internationally as the Chief Engineer for the United Nations Mission in Ethiopia and Eritrea. We are so delighted to have sir with us as a guest for today's gathering. And before I request him, I would also like to request Dr. Arnab Das to come and formally welcome the gathering for today's day.
Good morning, everybody. General Manoj Pandey, sir, former Chief of the Army Staff. Lieutenant General Ramesh, sir, Commandant CME. Vice Admiral DSP Verma, sir, former Director General of the Nuclear Submarine Project. Dr. Ajit Ranadev, former Vice Chancellor of Berkeley Institute and also now the Dean of Research at Pune International Center. Dr. Taleda Ajit, my mentor and also a very integral part of MRC, has been supporting us in many ways. Brigadier Deshmukh, sir, thank you very much for my former colleague at Millet. And we have spent good time together there. And friends from the media, Tusharji, thank you so much. And also friends from services, NDA, CME, and also young students. It's a great honor that MRC is hosting this. Yesterday, we had a very good opening. Probably it was more Navy heavy in the morning yesterday. We had the former Navy Chief, Admiral KV Singh, and we also had Commandant in India, Vice Admiral Anil Jaggi, sir. And we also had a couple of more naval officers along with Admiral DSP Verma, sir. The discussion centered around security, of course, with the valid reasons. But we also had a discussion on geopolitics. We had Ambassador Mudgal, who chaired a session along with my colleague Calistine. We talked about how UDA impacts global order. We covered various dimensions of politics, economics, demography, technology, environment. Then we had a very detailed discussion on the marine special planning tool that we have developed. And we also had Mr. Vishwanath, who works with the CDS now to develop. And in fact, he is focusing on maritime underwater domain awareness. And he had some very good insights to give us. And he has also kind of proposed that we could work with them and take this UDA forward. There was a very interesting, I won't say debate, but some of us, including Arudra, who has come from ICWA, some of us felt that the focus should be on UDA. But Admiral KV Singh sir said it to be integrated approach, which we definitely we cannot counter that. I mean, typically what happens is post 9/11, 26/11, the focus had gone to maritime domain awareness. Definitely became a very, very important term. But people fell short of just looking at the surface and could not penetrate deeper underwater. And so that's where some of us felt that there is definitely a focus required. But obviously, it cannot be completely isolated from MDA. And that's what we are now discussing, how to make it more comprehensive in the sense that it is able to drive policy in a more nuanced way. Today, we have a very special discussion. The first session, after General Manoj Pandey sir gives us a broader view, Then Ramesh sir will be heading. He's a practicing engineer, and Army has been involved in a lot of underwater work. One is bridging the sediment bearing pressure is a very important problem that they face. That is what I know. It also extends to Navy when we try to do amphibious operations. But there are many other. I mean, even Army is required to participate in disaster management in many other, and also they have to deal with. Uh, I mean, I want to make a special mention of Brahmaputra because I mean it's a very different river. But we had the fortune of working with two engineering officers who were doing the staff course. They did a 6 months project with us, and we got a first-hand insight into their specific operational difficulties. And 6 months was a good time that we could understand from them, and also we could work with them on how AI, how data analytics, how satellite remote sensing can help. So my colleague Romit will be making a more detailed presentation, and then we'll be seeking advice and guidance from General Ramesh sir on the sediment management, how we can make it. And there are many other aspects of sediment management he will cover to some extent on in terms of urban flooding, in terms of port management, in terms of coastal management. Coastal erosion has become a very serious problem for many of the coastal communities. And even big infrastructure that we build in the coastal waters, they are facing a lot of various other challenges. So the session after that is on blue accounting. We are very fortunate to have Dr. Ajit Ranade here. Blue accounting is a very important aspect, and particularly from a policy perspective, how to make it more comprehensive, looking at not the economic side, but looking at the social side, looking at the environmental side. So my colleague Kathleen will be making a detailed presentation. The third session is also very interesting on biofouling. Now, biofouling is a very serious problem, particularly in the tropical waters. We did a blue accounting kind of work on biofouling. A VLCC size ship in Vadhavan port, if it is not, the anti-fouling is not done well, it could cost up to 4.1 lakh rupees per hour. So that's the kind of, and blue accounting, if it is done well, I think it will give us a very comprehensive view. I think Dr. Ranade will talk on that. The last session is on fisheries and aquaculture. My colleague Ashwini is here, and that session will be chaired by Mr. Rakesh Kumar, General Manager from Bharat Electronics. So I think that's a broader, and at the end of the day, we will have a review of the entire thing. So that's the broader framework of, and this entire two-day workshop has been supported by ICWA, and we published a joint publication on the UDA framework covering various aspects. All the participants, we will share the, I think today people prefer online version, so we will definitely share a online version, and there are 11 articles which cover, and this entire two-day workshop has been kind of designed around that. So I think I will stop here and I will hand over to General one of the panelists.
Distinguished speakers for the day, dear guests, ladies and gentlemen, Jai Hind and a very good morning. It's an honor for me to be present at the seminar on the subject of advancing underwater domain awareness being conducted by the Maritime Research Center. And I thank the organizers for giving me this opportunity to be here and also to speak. The subject of today's deliberations, from what Dr. Das mentioned, is the significance and impact of UDA on blue economy, ecology, and sustainability. I believe is particularly relevant because our oceans are not only a strategic and security space, but also important foundation of India's economic growth, environmental security, and national development. While our dependence on the seas is increasing, at the same time, you would agree with me that the maritime domain is becoming more complex, contested, and environmentally vulnerable. Therefore, for us, awareness of the underwater domain cannot be viewed only through the lens of security or surveillance. It must encompass the health of the marine environment, the sustainability of resources, the safety of navigation, and the responsible use of our maritime spaces. And this is where the concept of underwater domain awareness acquires wider national significance. Traditionally, maritime awareness has focused substantially on what we can see, track, and identify on the surface. The underwater domain is different. It is largely invisible, dynamic, and also difficult to monitor. Yet, it contains critical infrastructure, ecosystems, natural resources, and activity that directly maritime security and economic. You cannot secure what you do not understand, and you cannot manage effectively what you cannot adequately observe or see. So UDA needs to be understood as a shared knowledge framework, bringing together information, technology, institutions, and expertise, so as to build a comprehensive understanding of what is happening beneath the surface. And this cannot be the responsibility of any single organization or agency. The underwater domain cuts across defense and security, shipping, ports, fisheries, environmental protection, scientific research, offshore infrastructure, and the wider blue economy. A meaningful UDA framework must therefore promote interagency coordination, information sharing, and a common operating picture. India's blue economy, of which Professor Anande will be talking later during the day, is not merely about extracting value from the seas. It is about creating economic value while preserving the ecological systems that make this value possible. There is consequently a need for the stakeholders to move from a purely sectoral approach to a more integrated understanding of the marine space. And UDA can provide this connective link between different perspectives. Better underwater awareness can support, say, for navigation, and you just heard of it, be it inland water transport, be it out in the seas. It will support more efficient use of marine resources, protection of critical infrastructure, and more informed environmental decision making. And in this sense, UDA is not only an enabler of maritime security, but can become an enabler of sustainable national development. We increasingly recognize that security, economic prosperity, and ecological sustainability cannot be treated as separate compartments. Environmental degradation can affect life. Resource depletion can create economic and social tensions. Damage to marine infrastructure can have cascading effects on trade and connectivity. Conversely, healthy marine ecosystems support fisheries, coastal communities, tourism, and other economic activity. This makes marine ecological security an important component of overall national resilience. The challenge before us is therefore to develop systems that responsibility, protect it effectively, and the underwater environment early enough to be able to act. Today, we will first the sediment management and navigational safety. Safe navigation is fundamental to maritime commerce and connectivity. Sediment movement, seabed changes, and underwater conditions directly influence the safety and efficiency of ports and shipping routes. This is also relevant to transportation projects, which I just alluded to, which have untapped potential, especially in our northeastern region. This is why underwater information needs to move from being a specialist data set to become actionable operational knowledge. In environmental economics, it should be remembered that what gets measured gets managed. If we are serious about sustainable use of the oceans, we need to have better ways of understanding and accounting for the economic value of marine ecosystems and the costs associated with their degradation. That you will discuss today is biofouling, anthropogenic noise, and ecological. Modern maritime activity inevitably creates an environmental footprint. Stop development, but to understand its consequences and build greater resilience into our activities. Here again, UDA can contribute by monitoring, fire detection, and evidence-based mitigation. First issue is about sustainable fisheries, aquaculture, and marine. The ocean is also a source of food, livelihoods, and economic opportunity for millions. Sustainable exploitation requires knowledge of marine ecosystems and resource availability. Technology, data, and scientific understanding must therefore support both economic activity and long-term resource conservation. If underwater domain awareness is to support India's MAHASAGARVision, we should focus on three key issues, that is integration, use of technology, and sustainability. We need to bring together capabilities of data sets of defense, government agencies, scientific institutions, industry, and the academia. The objective should be a more integrating of the underwater domain while respecting security and data requirements. Sensors, autonomous systems, AI, data analytics, seabed mapping, and other emerging technologies was possibilities. But technology should not become an end in itself. The real question, what decisions will this information enable us to take in a better and faster manner? Economic and strategic activity in the maritime domain must incorporate ecological considerations at the outset. Sustainability should and cannot be an afterthought, but be part of the planning process and the itself at the outset. I would say India is a maritime nation with a long coastline, island territories, and a vast EEZ with deep dependence on the oceans for its economic and strategic interest. Our maritime future will increasingly depend not only on what happens on the ocean, but also on what happens beneath it. MAHASAGARVision provides us an opportunity to look at the maritime domain in a holistic manner, combining security, development, sustainability, and cooperation. Underwater domain awareness can be an important enabler of this vision, provided we approach it as a national and multidisciplinary endeavor. This seminar offers an opportunity at a framework that connects science with policy, technology with operational development, with ecological responsibility. I wish to compliment the organizers for this important initiative and wish the Maritime Research Center all the very best in its future endeavors. Thank you, ladies and gentlemen, and Jai Hind.
We will begin the day with session 5, Sediment Management and Navigational Safety, presented by Mr. Rohit Kawale, who is a research fellow at the Maritime Research Center. And as session chair, we have Lieutenant General A.K. Ramesh SM, Commandant of the College of Military Engineering, Pune. India's tropical rivers, estuaries, and coastal zones face some of the highest siltation rates in the world. Driven by monsoon-fed systems that deposit heavy sediment loads at the coast and our rivers. Left unmanaged, this siltation reduces navigational drought, a problem set to intensify as port expansion adds capacity. I would like to call for this session Lieutenant General A.K. Ramesh SM, who is distinguished military leader currently serving as the 49th Commandant of the prestigious College of Military Engineering, Pune. Commissioner of Engineers of the Indian Army, he brings decades of extensive operational, instructional, and administrative experience to his leadership roles. Throughout his illustrious career, he has commanded critical engineering formations and held pivotal staff appointments across diverse operational terrains, earning the Sena Medal for his exceptional devotion to duty and gallantry. As the head of CME Pune, the premier tactical and technical training institution of the Indian Army, he spearheads advanced military education, research, and innovation in combat engineering, CBR in defense, and sustainable infrastructure development. The presentation will be done by Mr. Rohit Kawale, who is a graduate of the Indian Institute of Technology, Delhi, holding a bachelor's degree in civil engineering and currently pursuing his PhD in geotechnical engineering from IIT Delhi. He's a research fellow at MRC, and his primary focus is on sediment in the tropical waters of the Pacific. His work highlights the importance of sediment management in different domains like coastal zones, freshwater systems, watershed management, while discussing the impacts of sedimentation in the context of people, economy, nature. It gives the context of the unique tropical conditions and the socio-economic challenges faced by the different stakeholders in sediment management. His work also underlines how digital transformation and integration of artificial intelligence in the current system can lead to capacity and capability building in sediment monitoring. Rome applying his expertise in civil engineering, especially in the maritime sector, to foster sustainable development. I would like them to come on stage for this session. I would also like to take this moment to thank the Indian Council of World Affairs, who helped us bring this to fruition and was an integral partner to this national seminar. I'll hand over the mic to you.
Good morning, everyone. My work basically starts with the sediment management. We look into I'll give a context of why sediment management, why I'm generally looking into the sediment management, and especially within the Indian Ocean region itself. And when we talk about sediment management, what are the different nuances that we are talking about? What is our focus? And when we talk about those nuances, what are the challenges that we management, inland water management, or the watershed management? And then where are the practical scenarios, or what are some real life applications we can use digital technology, digital transformation to actually solve those challenges? Now, with the current geopolitical scenario, we have seen how the Indian Ocean region is a very strategic space, especially when we see that it carries over 50% of the global container traffic, 80% of the total world's shipping lanes as well. And it is of interest of almost every global power today. So we have seen news of the Chinese vessels serving within the Indian Ocean region. So there is a lot of geostrategic competition within the Indian Ocean itself. Even with its vast geostrategic importance, the Indian Ocean still remains one of the least studied regions of the world. So there are significant knowledge gaps of understanding of the sediment dynamics. What are the various natural or anthropogenic activities that affect the sediment flow and the sediment dynamics itself? Now, within the inland context itself, sediment is a very crucial challenge. Now, as we can see within in the topmost image, so you can see like the before monsoon, the pre-monsoon, and the post-monsoon, how much of the sediment influx has happened in the Gulf of Khambhat itself. Now, superficially, we believe that a lot of sediment has led to increased turbidity, and it might have effects on the shipping, on the fisheries itself. But again, we need to have proper nuanced understanding. So we need to go from a macro picture towards a more micro picture to understand what are the various challenges that might come up with such increased sedimentation or the deficit in sedimentation. Okay, this also has effect on the overall watershed management as well, where we see that increased sedimentation or increased siltation affect the storage capacity of our reservoirs, and then it affects the water quality, which is detrimental to the marine and aquatic habitat itself. Now, as you can see in this picture itself, the siltation which occurs within the Bay of Bengal or in the Indian Ocean region, it's one of the highest in the world. In fact, the Ganga Brahmaputra rivers, they carry across about 1 billion tons of sediment within the Bay of Bengal, which remains one of the highest in the world. So we require very unique understanding of what are the local conditions happening that give rise to such high loads of sediments within our region. So this is where we look into sediment management. So our basic understanding is to understand how the sediment gets accumulated, how does it move, settles, and then accumulates or deposits within our different riverine systems and the coastal systems itself. Especially looking into the unique conditions. So we have the monsoonal system, high rainfall, cyclones, and then other anthropogenic activities as well. So how these highly variable characteristics affect the sediment management within our Indian subcontinent and within the Indian Ocean itself. So we look into something which is called the UDA-driven sediment management. Here we talk about how data-driven decision support can help in understanding the different nuances of sediments, how we can look into or how can we tap into the data and look and apply various new technologies such as AI, machine learning, or use some data analytics to actually understand what challenges are there regarding the sediment, and how can we bring all of them together to actually solve sediment-related challenges, be it in the coastal systems, be it in freshwaters, and so on. Now, coming to understanding what are the unique characteristics of the sediment within our Indian conditions, we firstly need to understand that these Indian conditions, they support a high sediment load and high turbidity, especially from the Himalayan regions or from the peninsular regions. Afforestation, a lot of increased farming, it leads to an increased sediment load within the Indian rivers itself. When we combine it with the highly fluctuating monsoon, climate change, it leads to a lot of sediment loads with the intense rainfall and the increase in the catchment erosion as well. We also have a rich biodiversity. In fact, India is a mega biodiverse country itself. The Indian Ocean region also supports a lot of endemic species in itself. So how this biological activity, how those biological species are getting affected by the increased sediment loads or the decreased sediment loads, because these sediments carry the nutrients which are very much required for their healthy spawning and the species distribution in itself. And then we have excessive anthropogenic activities as well. So we have a lot of fishing, trawling, dredging itself, how shipping affects the sediment redistribution itself, how the propeller movement might lead to the redistribution of sediments, dredging can lead to the resuspension of the sediments itself. So ultimately, how all of these activities, with the natural activities, with the human activities, how this leads to the local sediment dynamics. And then we also need to consider the climatic conditions, the chemical properties of the Indian Ocean region as well. We also need to consider the strong temperature gradients. It remains one of the warm water bodies of the world. So how the temperature gradients affect the overall species distribution as well. And then to monitor the underwater, we have something called the acoustics. So these acoustics mostly are based on the principle of underwater communication itself. And the underwater communication based on the speed of sound. So how the temperature gradient, the salinity, the pressure, how those gradients affect the overall speed of sound, the underwater communication. That is a very crucial understanding that needs. Another major understanding is the depth of sound access or the SOFAR channel depth. Now, SOFAR channel is can be considered as a channel which is required for the long-range communication, long-range underwater communication without a lot of attenuation. Within the tropical Indian Ocean, this lies in the range of 2 to 3,000. At such depths, the normal sonars, the efficiency reduces to around 60 to 70%. So how that reduction in the overall efficiency of our sonar of our underwater communication channels, how that affects the our understanding itself. And again, we have a lot of complex reflection and multi-part acoustic propagation due to the biological noise, the shipping noise. So we need to understand what are the different noises that are coming for our underwater communication itself. So so as you can see here itself, that the sea surface temperature or the salinity profile as well, it varies a lot for the Indian Ocean region itself. Now, even when I consider the salinity profile, you can see the Bay of Bengal and the Arabian Sea. They are quite distinct in itself due to the freshwater, a lot of freshwater rivers draining within the Bay of Bengal. So we need to consider this local change itself to see how that affects the underwater communication or the acoustic communication itself. And then, as I mentioned, we have a lot of species distribution as well. So how the sediment load affects the spawning rate, how the species distribution are affected by the sediment movement, by the pollutants which are released within the sediments itself. Then the major consideration that we need to have is that the region itself, it hosts over 2.5 billion people, but these are mostly the lower to lower middle GDP income countries. So we can't just say, okay, we'll have expensive technological solutions developed within the advanced economies. We'll import them and then directly use them. We need to understand what our own conditions are. How can we leverage our human resources? Again, because of the young demographic, which is mostly below 30 years, how are we going to leverage that, come up with a new region-specific systems or to manage sediments, to monitor sediments and see how they're affecting the livelihoods and the overall socio-economics of the region itself. So this is where, again, when we use any kind of acoustic systems or sensors, most of them, they are affected by the propagation variability, which are affected by the ocean climatic condition, the waves, tides, currents, which are continuously fluctuating, especially within, as we are seeing now, the El Nino and the La Nina condition. There is a lot of background noise interference from the biological noise, the shipping noise itself. All of this make the overall deployment and the calibration of such equipment, which are mostly imported from the advanced economies, very difficult. And it leads to a reduction leads to an overall effective performance of just 60 to 70%. So technology for which we are spending more but are getting less efficiency. So that's why we need to really look into how our own region-specific systems might look. Now, coming to the segment management, we are mostly concerned by two nuances. One is the segment transport and another is the segment classification. So segment transport, we are mostly focused on what are the various factors or parameters that affect the movement of sediments. Now, this might be different in rivers, in oceans or reservoirs. So the freshwater and the coastal dynamics, they are quite distinct from each other, as we'll see in the next slide. And once these sediments are deposited, how they affect the other applications, like we have the segment bearing pressure, benthic ecosystem, abiotic elements that we'll look into this later on. So these are the two major domains that we are currently working on. Especially, I talked about how the coastal and the freshwater systems work. So when we talk about the coastal and the freshwater system, the major or the distinctions are between the transport mechanisms, where the coastal systems are affected by the tidals, by the waves, by the littoral drifts. While for the freshwater system, we are mostly concerned with how the river flow is happening, how the discharge rates or how the releases from the dams itself affect the overall sediment flow, the water discharge levels. We have different infrastructures to keep in mind, like the coastal systems might affect more of the ports, the navigation, the coastal infrastructure itself. While within the freshwater systems, we might look into our dams and reservoirs, how the structural stability is affected, the irrigation and the navigational channels in itself. So each of them, for the coastal system, for the freshwater system, we have different issues, different parameters to look into. So these are quite distinct. However, for the sake of the current discussion, we'll just go around a brief discussion of both of them. Now, as I mentioned that there are two most mechanisms that we are looking into. One is the segment transport and another is the segment classification. But why are we looking for like both of them? Why aren't we looking just one for segment transport and why we are looking to segment classification and so on? Because they both are coupled together. In fact, when we see that the sediment transport is actually dependent on the sediment characteristic, on what type of sediment it is. So if I say this, like the sediment type, the material properties affect the settling of the sediments. So if the sediments are less cohesive, say sand particles or larger size particles, they are more susceptible to get deposited. However, if they are more cohesive nature, they of say clay type and are more finer particles, they are supposed to get flocculated and they may give rise to the suspended sediment concentration, give rise to turbidity itself. So in fact, the sediment type affects what would be the sediment transport pathway, how the bed loads affect, what are the different stresses that lead to, or what are the forces that lead to the overall settling velocity. So the sediment classification and the sediment transport, they are correlated with each other. And that's why most of the sediment transport modeling can be done by using fundamental physics equations, using the Navier-Stokes equations. We can have what are the bed load and the suspended load itself. And then there are various softwares which use what are the flow conditions, the discharge rates, what are the sediment types, sediment properties, what is the topography either of the coastal system or the river system, and what are the boundary conditions. And then we can use the already existing softwares to actually model the sediment flow, or we can find what are the sediment hotspots within a particular region. In this way, we can might look into which are the regions which require a certain or immediate attention. Then, since the sediment transport is affected by what are the different kinds of sediments or what are the sediment classification, we have different ways of classifying sediment. Conventionally, what you do, you could have those grabbers where at particular location field sampling can be taken up, and then we could have laboratory experiments to consider what are the different type of sediments, be it sand, silt, or clay, or a mixture of them. However, these are time and time constraint is there, and then they also provide limited variability. So what we have the sediment classification using the satellite and the acoustic methods. So we could have a satellite imagery over large spatio-temporal ranges, which may range from years or sometimes decades as well, over a very large spatio-temporal range. And then we could apply some image processing techniques. Currently, we could have some artificial neural networks or AI-based methods as well, where we are able to relate the change in the turbidity or the to the actual sediment concentration, and also to look what kind of sediment it is. So we can get an understanding just through the satellite imagery, what would be the sediment type, what would be the sediment concentration in itself. Another way is using acoustics. So here what we can do is we could have sonars, which again could be of different types. We could either have the acoustic, the single beam echo sounder, the multi beam echo sounder, the side scan sonars. So again, depending on what is the frequency or what is the bandwidth of the sonar, we could deploy the sonar within a particular river, water body, and then we could see the data which is collected by that sonar. Because each and then using that we can understand what is the bathymetry of the riverbed or of the seabed itself, and then we can have some maps. Now we can see here these are kind of static maps. However, when we talk about acoustics and apply proper data analysis, we can get dynamic. We can try to combine the wave currents, the sediment type, the sediment transport dynamics itself, to see how the variation of sediments is happening, because sediments are not static, they are susceptible to changes due to wave currents itself. So how the combination of different parameters actually lead to the sediment transport and the sediment classification, that can be looked into. I'll speak more about it in the later part of the presentation. Now coming to the various sediment classification, but what are the various issues that are caused by this sedimentation? One of the challenging part is the shoreline erosion. Now, nearly 40% of India's coastline is affected by erosion, especially due to high waves, tides, currents, especially in Kerala, Tamil Nadu, in Gujarat as well. We see there is a lot of receding of the coastline itself. Now, most of this, these can be attributed to the wave currents, to the tides as well. But how does the sediment, which are influenced due to the nearby rivers, say the vessel movement, how the vessel movement leads to the redistribution and leads to the erosion or accretion? Now, if there is this shoreline erosion, how is it affecting the overall socio-economics? How is it affecting the marine biodiversity? All of this local sediment dynamics remains vastly studies. There are isolated studies, but over a large scale, the erosional studies seem to be lacking, where again, these might affect the overall offshore foundation. If there is a port nearby or a breakwater nearby, how that would affect the overall erosion rate or the shoreline erosion. So all that can be solved by modeling and simulation itself. Now, if we see in this animation, if sedimentation within a particular navigational channel or say a port, as well, if it goes unchecked over years, it may get accumulated, and then it affects the available draft for the particular navigation channel and can lead to delays, cost overruns, and the overall efficiency of the transport mechanism in itself. So, what are the solutions of solving such sedimentation? The one such solution comes to our mind is dredging. So what you do, you understand what is the amount of sediment that needs to be removed to maintain a particular drop, and then amount of we could have mechanical dredges. There are a lot of machines which need can suck up the sediment, and then that can be later transported to somewhere else. However, this dredging is not a long-term solution. It's a very reactive kind of solution, and the effects or the ill effects of dredging, it has a lot. It leads to redistribution of sediments. This redistribution leads to the effect on the fisheries as well. Also, say in a particular region, if dredging has happened, however, if no proper sediment dynamic study is done, due to the anthropogenic activities or due to the natural factors, if that dead sediments get redistributed again within the same space, again the dredging story goes on conducted the next year around. So it is a never-ending cycle. So what we need to look into is what are the other solutions. If we can look into what are the where actual dredging is required, and it will not lead to other overbearing effects on other cases. And this is where actually a sediment transport study comes into picture, where we could understand what are the various sediment sources, how the seasonal variability all affect the overall redistribution of the disposal of the dead sediment. Now, again, this dredging operations have construction of new ports as well. In fact, around 30% of the overall costs are required for setting up a new port goes into dredging. So we we do not have proper understanding of how much of this dredging volume needs to be, how much of the sediment actually needs to be dredged out. So we can see within the 12th five-year plan, actually the actual amount of dredging that was planned and which was carried out was around 47% less than the targeted volume. So there's a lot of lack of understanding in the what is the actual sediment volume that needs to be dredged. Also, if you look into such kind of seabed, if we need to carry out such kind of dredging, how that affects, how the trawling might affect the overall corals, coral reef, the benthic ecosystem itself. So again, dredging has a lot of effects, and we need to understand the higher costs and the inefficiencies associated with dredging. How can we use our digital transformation in understanding what would be the sediment volume that is required, or can we look into what are the actual, or we can identify what are the actual hotspots for sediment, or what type of sediment needs to be removed, so that we can actually use a targeted strategy for the scheduling of dredging itself. Now, in cases of say unchecked sedimentation or unchecked dredging itself, in many cases, these sediments also carry a lot of pollutants, a lot of nutrients itself, and these might give rise to algal blooms, affecting the overall water quality or degrading the dissolved oxygen or the dissolved oxygen which is available for the fisheries within a particular water body itself. And if the overall water quality affects, the species distribution is affected, it has effects on the say the fishing communities, the coastal communities in itself. So the sediment affects the overall benthic ecosystem, it affects the water quality, that has overbearing effects on the coastal communities, on the social economics as well. And then it again comes back to the how the nature is affected. So it's a loop where we need to understand how the sediments actually have overbearing effects on the people, on the economy, and on the nature itself. Now, again, coming to the inland water transport, the most of the Himalayan regions as well. When we talk about the Yamuna, we talk about the Ganga. These start from the Himalayan region, from the upper reaches, and then flow from the plain within the northern regions itself. So, how the various activities, the agriculture belt, how that affects the inundation, how that affects the overall influx of sedimentation that needs to be looked into. Because if the irregular sedimentation is happening, it might affect the overall navigational draft within that particular say inland waterway. And to maintain also the water which is influx from various dams, from various barrages itself, how that leads to a change in the sediment levels, that we need to understand. We need to understand how the data-driven river management. If you have proper discharge level data, we have understanding of the hydrodynamics of the real-time bathymetry, how that is affected with the changing water levels and the changing and the related marine health itself. We can maybe try to developing some sediment forecasting models to actually see, okay, in a particular time, which navigational channel would require our help, or which would be of a serious concern. Now, coming to the freshwater systems itself, the sedimentation is a crucial issue in our reservoirs itself. In fact, the Central Water Commission also talks about a lot of sedimentation within our reservoirs. Now, this has effect not only on the loss of the reservoir storage capacity, but it also has effects on the overall structural stability of the dam structure itself. And then we also need to look into how this entrapment of sediments affect the overall water quality, and then they also trap the nutrients. Now, these nutrients might be crucial for the benthic ecosystem or for the marine ecosystems that reside in the downstream. So, if we are entrapping the nutrients upstream, how the species distribution, how those benthic ecosystem within in the downstream region, they might be affected. Again, we are not quite sure of that. So again, there are a lot of environmental impacts as well, how the water quality degradation affects the turbidity, the pollutants, this water might be supplied to irrigation as well. So how that affects the overall food chain, how it affects the soil quality. Again, so it has overwhelming effects on the watershed management itself. Now, when we talk about a lot of challenges, be it inland water transport, the watershed management, be it port management itself, if proper sediment management is done, we are able to monitor what are the type of sediment, we are able to see what is the depositional rate. These can be of real use in many cases. The first one being sediment map, seabed mapping itself, or the riverbed mapping. Now, if we are able to utilize the acoustic sediment classification or the acoustic sediment transport mapping itself, we can use it in the planning of, say, undersea cable or the submarine routes itself, where we can actually able to see what are the seabed bathymetry, how that gets evolved with the changing climatic conditions, with the various anthropogenic activities that might come in help. Also, the a lot of mineral, the polymetallic nodules are within the Central Indian Ocean basin as well. So, such kind of sensing or such kind of equipment be of help within those particular domains as well. Another crucial application is within the sediment bearing capacity. So, sediment bearing capacity, it can be understood as the maximum strength that the soil can carry prior to filling. Now, this is mostly based on what is the sediment type, what is the cohesiveness, what is the friction angle of the sediments. Quantify what is the overall sediment bearing pressure. However, we have seen examples where improper sediment bearing pressure understanding have led to a lot of detriment to the infrastructure itself. So we have seen that due to lack of understanding of this covering, how the sediment transport patterns actually evolve, there is effect on the overall stability of the offshore foundations of these foundations, and it can lead to different settlements as well, and then it can lead to, say, the destruction of again a lot of infrastructure, and then how sedimentation it leads to a loss, or it can lead to scarring, it can lead to attrition. So how the changing sediment levels or the changing sediment types affect the bearing capacity, that needs to be looked into. And because it has a lot of applications, say in the offshore construction, where we talk about the bearing pressure and what is bearing capacity, in understanding what is the foundation design, or say for the oil rigs, for any offshore bridges, even in the cases of dams, where we find what is the overall bearing capacity or the strength using the type of sediments itself, and then the sour behavior, the sediment mobility, all of it affect this affects the foundational stabilities itself. Now, this sediment bearing pressure finds its application within the different operations as well. Now, where we can look into how the different sediment types, be it silt, clay, or the gravel, it affects what is the sediment bearing pressure, which might affect what is the type of equipment that can be deployed within that particular region. Now, there might be a sediment regime change due to the increased fluctuations of climate change or the change in geography. How that rapid inundation might affect the sediment, how it might affect what is the sediment type or what are the sediment levels, and then how it affects the overall structure. So if some reclamation needs to be, then this needs to be for even for say mine burial or say anchor holding as well. So what are the different, how does different type of sediments play a crucial role that needs to be looked into? Yeah. So especially when you talk about the bridging operations, or we have said the amphibious operations as well. So there is a prior understanding of what is the sediment, whether the current soil or the current sediment is able to capture that or take up that much load. And such prior studies might give us an estimate of which region is suitable for such heavy equipment deployment itself. And then we also can see that the Indian coastline, there are sediments of different types, ranging from clay, sand, silt. So again, this is a static map, but depending on what are the climatic conditions, the coastal conditions, these might vary a lot with the, say, the pre-monsoon, the monsoon, and the post-monsoon. These might indeed vary a lot. And again, we have different kind of sediments. Say from the runoff cuts, we could have mud flats, salt crusts, where we could also find coral sands or volcanic sands in the Andaman Nicobar Islands as well. So how that affects the overall bearing capacity, where the clay silt might have very low bearing, which is similar with the marshes of say the Sundarbans as well. While if we could have gravel kind of thing, which would have high bearing capacity. So how it has a different kind of application, different kind of bearings on each other, where the high bearing was might not be so much interest, but in cases of the critical bearing capacity, we need to look into what are the issues there, what are the actual parameters that affect the bearing capacity within the particular region itself. And then, as I mentioned, it is very much required for the temporary structures like bridges, docks, or defensive fortifications as well. We need to understand what for the heavy vehicle deployment or for amphibious operations as well, how much being a highly permeable kind of material in the submerged conditions, how that is affecting the overall strength of the particular soil medium or of the material. And even if we need to construct say trenches, bunkers, or barriers in those shallow water regions, how that sediment bearing came into picture. So again, we can look into some of the technological or digital transformation tools that might help in understanding the overall bearing pressure estimates. And then such kind of sediment monitoring can also help in the benthic ecosystem monitoring, where we can see that how the change in the turbidity, say using satellite imagery, we can see how if the change in say the turbidity, or if we are able to model what are the sediment influx, different kind of transport patterns, how that affects the change in the nutrients, change in the say the pollutants within the sediments, how does it affect the benthic ecosystem, or even due to dredging, which leads to the redistribution of the sediments, how does it lead to a change in the spawning rates or in the habitats of the already existing fisheries or aquaculture itself. So we need to sediment classification methods can be used here. And then again, there might the acoustic methods can also be used to find what are different abiotic elements within a particular region. So one of the most prominent uses is the are the polymetallic nodules, which are say globules of cobalt or nickel, which are very much crucial in the batteries as well. So Central Indian Ocean basin has a lot of these polymetallic nodules. So if we are able to use say the sonars or sediment classification techniques to see where the polymetallic nodules are located, or we can understand how the seabed is varying in that region, so that again we can come up with proper mining techniques or extraction techniques itself. We can also use it to find what are the various ship debris, and how the overall sedimentation of the sediment transport is affected by such ship debris. We can look into it. Now, once such kind of sediment transport equipment is into place, we can actually use it into different applications itself. So, say we have proper and acoustic surveys, which might lead us to understand the bathymetric and the sediment data. Now, once we have an idea of the bathymetric or the sediment data, we could get an understanding of what is the overall sediment volume. As the acoustic, so due to this, what are the different layers of sediments and what are the thickness of the sediments, we can get a quantified understanding of what is the amount of sediment particular stretch of water body. And with using the sediment classification techniques, we can see what is the actual type of sediment. What is the grain size distribution, what are the chemical composition, or what is the cohesiveness of the particular sediment type. And then that can be used in various applications, say for the dredging. We can understand if we know what is the actual dredging volume or what is the sediment type. We can say whether a hydraulic dredger is required, whether a mechanical dredger is required, or what kind of dredging is required, what is the frequency of dredging is required. If that particular dredge sediment can be reused again, if it satisfies proper engineering characteristics, can we use it for proper offshore disposal, or can be reused again within that particular region for land reclamation or for fertilizers or for even for brick construction as well. Again, such kind of use of the dredge sediment, it might lead to potential cost savings as the overall transport cost might be again gets reduced, and then it also leads to opportunities for carbon dioxide savings, because now the dredge sediments can be reused again within the land. So, for example, in a port, in a construction of a new port, the dredge sediments can be again reused for the land reclamation, creation of backwaters of jetties itself. So you see, it has effects not only on the nature itself, but on the overall cost savings and on the economics of the sediment management and the infrastructure development itself. Likewise, within the watershed, if we are able, say, using satellite imagery or using patterns, we are able to assess what are the different land use changes over time, what are the soil type changes, or what is the erosion that has happened. We can identify which are the particular hotspots that actually lead to the sediment influx, or where urgent requirement is urgent care is needed. And then we could have appropriate catchment area treatment. So we could have, let's say, trenching type, silt traps can be formed. We could have check dams or afforestation. So again, dredging is not the only solution that we can look into. And then such kind of proper sediment monitoring and understanding of what is the maximum level of sediment that can be reached within, say, high flood levels, extreme flood levels, or extreme drought levels. If we know what are, say, the pre-flood conditions, and using the simulation techniques, say, under different conditions, we are able to map what would be the maximum post-flood channel. We can actually come up with disaster management plan in the plans within the urban planning itself to see what would be the safe extent across which, say, infrastructure can be planned, or like livelihoods or housing can be planned. So all of this can be incorporated with the disaster risk management itself. It is in the current age we can call as the predictive planning, and instead of a more reactive kind of approach, we can move towards a more proactive approach where we have understanding of a local dynamics. We can actually use the actual evidence. We can understand what are the local realities, and that can be included within the different kind of frameworks and different kind of models to actually go towards a more data-driven kind of an approach. So the major challenge, however, lies, say, even if studies are conducted, say, for sediment transport, sediment classification, what are the wave currents, what are the different climatic conditions, the major issue is there is no single platform that connects all of the data together. So some studies might be conducted by some research institutions, some might be conducted by some other government organization, some data might be lying within the military itself. So how are we bringing the different data all together? Because again, such kind of data cannot be shared with all of the stakeholders, considering the strategic importance of that the bathymetric data or of the sediment type itself. So how can we actually look into the combination of data, correlation of the data sets between one another? So this is where our contribution lies, where we look into like how the data fusion can happen, where we have data-driven approach, and we can see how can we develop or understand a local region-specific sediment dynamic within the marine spatial framework, and that can be then used within the scalable and adaptive system, so that that can be again used for a wider audience. So I'll give us an example. So say we have the Brahmaputra region, which is inhabited by around 500 million people, and then we know that due to a lot of flooding, it is susceptible to a lot of flooding, to a lot of change in the morphology, a lot of rainfall happens, so it leads to a lot of flooding. There is a change. The riverbanks might be overflowed and leads to a lot of infrastructure damage as well. So what might be the solution? How the acoustic sensing techniques and the remote sensing can actually help us. So say we could have acoustic sensors or voice or the acoustic Doppler current profiler at certain locations, so that we are able to get real-time data, say for what are the suspended sediment concentration, what is the water level, the discharge levels, and then using that continuous data, we might load it into our different kind of models to understand what is the sediment flux, what are the hotspots which are prone to deposition and erosion, which might be useful for dredging, for understanding benthic ecosystem, to actually map the urban flood or the extent of the flooding that might happen within the particular region itself. So what our approach is, say for a particular body of water or region of a proper field validation, where we look into this, either say the satellite data or the acoustic field validation can happen to, or the understanding of the local conditions to actually understand what is happening. And once the field validation has been conducted, we have proper data analysis. So the thing is that the acoustic data or any kind of field experiments, they will give you a raw data. Now that might be prone to noise, the medium propagation due to biological noise or the variation due to some say shipping itself. So how are we determining or extracting actual information from the raw acoustic noise? So that requires proper pre and post processing algorithms, be it in the domain of AI, machine learning, or any other mathematical models. And then that analysis, they can be overlaid with each other over a marine spatial planning tool, where we could have different, say, the wave effects or the sediment type, the sediment transport, all of them can be laid together, and then using the AI and predictive modeling under different conditions, we can predict, say, under extreme drought condition, under different flooding conditions, under different hydrodynamic conditions, how the actual sedimentation is affected. One such study has been conducted by MRC for the Khadak Fasla, where the acoustics were used to actually classify the type of sediments. So we had different bottom profiler, this and that. These were mounted on ships, and over a span of 2 days and over 5 tracks, the acoustic survey was carried out. And once that acoustic data was carried out using the various sonars, we also had various CTD measurements, which is the understanding of the salinity, the water temperature, and the pressure with depth, so that an understanding of how is the speed of sound varying within that particular medium. As the speed of sound varies with the different salinity, temperature, and pressure, we are able to estimate what is the overall processing that is required for the raw acoustic data. Now, such kind of acoustic data, it might again have a lot of filtering. It might be required. Pre-processing, post-processing algorithms are required, and based on some mathematical formulation, and reflection coefficient was calculated for the data. So reflection coefficient is the ratio of the received to the transmitted energy of that particular sediment. Now, this kind of reflection coefficient, these were mapped for different for all of the survey tracks, and these reflection coefficient can be mapped to unique kinds of sediments. Now, this reflection coefficient tells that the most of the bed is formed from the clay silt kind of a mixture, and this was actually validated by using 5 to 6 field samples itself, where the laboratory experiments showed that the composition is actually silt to clay type. So this actually talks about the overall validity of the acoustic sediment classification itself. Then we also carried out the satellite-based sediment classification or the suspended sediment concentration understanding within the Ujjaini reservoir itself. So what we had, we took the satellite imagery of the overall Ujjaini reservoir, and for 3 different periods, for the pre-monsoon, during monsoon, and the post-monsoon, we were trying to estimate what is the change in the turbidity, or what is the change in the sediment concentration. Now, such kind of satellite data which can be derived, say, from the Copernicus websites, uh, uh, so such kind of data is actually extracted in terms of spectral bands. Now, if we are able to utilize proper relationship between the spectral bands, we are able to see, say, for example, here we have plotted the red to green ratio, which is nothing but the value of the red band to the green band for that particular satellite, and the red to another kind of ratio, where we can the pre-monsoon and the post-monsoon, there is a significant ratio rise is attributed to a higher sediment reflectance. So, a lot of empirical have been done where the actual sediment indexes or the spectral indexes have been correlated to the sediment concentration. And these have been leveraged to actually look into a change in the sediment regime and the sediment type itself. Another work that has been done is to understand how the extent of sediment flow or sediment concentration that happens. So we have the stretch of Brahmaputra River. We are using the digital elevation models, the hydrodynamic models. We are able to estimate, say, which would be the potentially flooded regions, which areas might be significantly affected, and which might be the affected urban regions. Also, we can estimate what is the suspended sediment concentration across different stretches and different time scales itself. So this is where satellite data can come into a picture to actually map what is the extent of, say, urban floods that might happen. Now, another issue is the navigation, as I mentioned. Now, say for a particular chosen stretch of the Brahmaputra River, due to changing of the water levels or change in the sediment concentration, stretches which might not be navigable. The overall draft which is required to maintain, draft is required, might not be maintained for year long. So, would we be able to actually model within particular, say, input condition, input sediment condition, or the water levels, which would be the most optimal path, or what would be the navigational channels which might actually have that prescribed draft. So what we did, we actually had the sediment, the satellite data from the monsoon and the post-monsoon within a particular stage of the Brahmaputra region, and then we did a 5 class segmentation map. So red on the green one is the land area, the blue one is the actual river and its tributaries, and the nearby areas are the which are in the orange color are the marshlands. So once we have the segmentation map, we give a cost map. So the land area might be 0, while the water and the tributaries they might be given say a cost of 1. So here we are trying to give a cost map of what might be the actual navigable stretches. Now then, based on some input conditions of what is the sediment type or what is the sediment distribution, we try to run for a given input condition what would be the optimal route for navigation. So here we can see within the blue bar, we are able to see what might be the optimal route, and then we are also able to identify, say, for a green kind of identification that might be safe for navigation. Orange talks about that it might have moderate risk associated with sedimentation, while red shows again it shows a lot of land area for now, but the nearby regions might show critical regions where excessive sedimentation is happening. Kind of sedimentation also affects the shoreline erosion. So what we have done, we have taken a particular stretch along the Konkan region itself and tried to see with changing wave conditions, hydrodynamic conditions, how the shoreline is varied. So again, by utilizing the satellite imagery, a particular stretch of the of the shoreline was discretized, and then such kind of discretized was done for different kind of years. So say for 2023, 2024, and 2025, these were overlaid with each other to actually see what is the change in the shoreline across the different regions, and then that can be attributed to what is the change in the wave conditions or the sediment bathymetry itself or the sediment transport in itself, so that the shoreline erosion can be monitored, and then we can see how the accretion or the erosion is happening, especially nearby the ports, nearby the tidal inlets. So again, a lot of mathematical modeling can also be used for this shoreline change modeling itself. Another project that we took up was to assess what is the dredging volume. So in this case, a case study within the Cochin port was taken up, and uh, uh, the maps of the Cochin port was imported in a software called the Hackras and the Telemap, where we tried to, based on the available data sets of say, the wave conditions on the discharge levels, we were able to get what is the depth of the navigation channel within a region, and what is the mean shear stress of where shear stress within that particular region itself. So now, once you know what is the shear stress, that can be used to identify what is the or how the sediment transport is, and then what is the current bathymetry. We were able to identify what would be the estimated raw gross sediment that might be need to be removed, and what would be the say, non-dense amount of sediments within that particular region itself. Sediment management has a lot of dimensions, be it from port management, inland waterways, benthic ecosystem, watershed management. But what we need to look into is how we are connecting the dots, how all of them are correlated with each other, be it the coastal communities, be it the coastal infrastructure, how the overall people, economy, and the nature, all of them are connected with each other. And again, this is where like the phrase that the nature whispers before it roars. So if we refuse to listen, the roar becomes the ruin. So it's very much crucial to understand what the nature is trying to say, to have the data with us to understand what might come, and again we can just prepare ourselves for the for any kind of changes to come. So I think thank you for enjoying.
Actually, am I dancing with the thoughts? My question is on the surface actually. So, though it is the effect of underwater domain, what cancer information or the problems which are there. So, in this modeling, I'm thinking about the Globe glacial lake outburst flood. So, this, in that, many researchers doing the flood analysis or river analysis with the water itself, but obviously the sediment transport is there and the impact of that is very much. So can we do the modeling, and which are the tools which are useful for that type of modeling?
So mostly for you're asking for the sediment related modeling, right?
Sediment and flood modeling related to GLOF, glacial lake outburst floods, which is many of the dams are in failure of that.
Again, for modeling such such sediment modeling, there are various softwares again, like we could have open source softwares like Hackras or Telemec. So these softwares can be used, but again, the limitation is the data. Now, when we talk about the Indian conditions itself, the challenge we face is to have proper input data sets for any kind of modeling. So when I talk about even for lake outbursts as well, we need to have proper understanding of what were the initial conditions, or what are the estimates of, say, in cases of any kind of outburst, what will be the maximum discharge that might be possible if we have any kind of existing data. So the major issue lies within the data sets itself, of what are the discharge rate, what are the sediment types within the particular regions, because we need what are the digital elevation models, what is the geography within that particular region, or what are the parameters that might affect the sediment influx within that particular region itself. So again, so all of that needs to be included within the way. You can either use the open source softwares, or right now with the use of machine, we could have various artificial neural networks as well that can be utilized, where we can give the initial input conditions, and all of these like even the sediment transport rates, these are solved using some underlying physical equations itself. So when I talk about sediment transport, there are the Navier-Stokes equations or the flow conditions that flow equations that needs to be solved. So if you have the proper understanding of those flow equations, these can be fed to a say a neural network or a particular empirical model, and then based on the varying input conditions we can have, or again based on different scenarios, we can model sediment transport, or see what would be the different conditions of outburst, what would be the reach of or the change in the water level that might happen. So some of the techniques.
Now the government is also providing a lot of material. I mean, there are some websites of Central Water Commission and various other organizations. But the problem is that unless many of us use that data, we will not know the deficiency of that data. So, I mean, we are doing a lot of modeling and simulation, and whenever we access some data, data is good, and only a government agency can provide that kind of data. There is no denying that. But till the time more and more people use that data and find difficulties in whatever Rohit is saying, then only, and probably there has to be a two-way process where, our voices are heard. And although there is now enough effort, there is a lot of websites also being created by the government. But I feel that many more people have to use that data, find the deficiencies. Because see, when you go, like we did Kharakpasla data collection, first time when you go, you will go with certain assumptions, but when you actually do the data collection, you will find that some of those assumptions were not right. So, I mean, there are many organizations or many, even government agencies, they just keep collecting data and dumping it. I think that's not the. We did Kharakpasla for 2 days, first day, whatever we could find, but it's not enough. And this time talking about almost 8 years back. So today probably AI can give you many more things, but you need to use that data, find out what went wrong, or whether your resolution was not right, and various other things. So then only so when more people use it, probably these data sets will also get more mature. So I think that's the answer to your question. I think we'll hand over to Sir.
For present here, ladies and gentlemen. At the outset, let me begin by thanking the organizers for getting me here to be a chair of this session. And let me also extend my compliments to Romit, who made a very comprehensive presentation, absolutely scholarly work, and my compliments to you, Romit, for having covered such a vast subject in a very succinct and short time that was given to you. Before I proceed further, I would just like to put a disclaimer here. Though I've been designated as the chair, I'm no expert. This is not intended a very deep subject, and nobody can claim to be an expert. The variables are far too many, and like each one of you sitting here, I'm also discovering new things, and as we go along, every day is a new learning. Before I go further, I just thought, let me add a few additional points to this discussion on sediment management and how it impacts us in various ways. A very interesting headline caught my attention a couple of days back. It was out in the Mint, which said that India is charting a 10,000 crore waterway plan to boost logistics. This came out in the newspaper just 2 days back. And the aim of this announcement by the government is to expand India's operational waterways network and achieve, or as a part of achieving, the Maritime Security of 2047. And the finer details said that the target is more than 50 national waterways were to be identified, along with the existing ones. So that set me thinking, I'm going to be coming here to talk about sediment management, and here the government is embarking on such a, grand objective. So what are the challenges? Primarily, it is to identify new corridors to make it commercially viable. There's no point. Everything comes with a cost-benefit analysis. If the government is to be spending crores of putting in very, very scarce resource into this project, it has to be commercially viable and sustainable over a long term. Only then investments will flow. And if investments are to flow, any good banker will say, what is the sustainability over a long term? What are the investment horizons? What is the return? So the problem moved from being merely a sediment problem to something which is very different in a larger context. Because if money was to be recovered, then you need year-round availability of these water channels. There has to be commitment of passenger traffic, tourism, and many other things. So that set me further into, trying to understand what else will go into this. So what I've led, to put it in a very, very short manner, that it was not just about availability of the rivers, but there's more of the variable physical hydrological character of our rivers. That needs a much deeper understanding. And there are conflicting requirements of water depth versus water availability versus water assurance for various activities that we plan to use our rivers for. So, for example, if the rivers were to be used in a particular manner, the irrigation requirements vary from the hydropower requirements to the ecological implications of these activities or the industrial requirements. Now, another dimension of sedimentation was something which Romit also talked about, was the excessive sedimentation of our reservoirs. Now, this has great implications on, we are in a region where there is excessive siltation that happens. I mean, the Himalayan region is notorious for this. So the constraints on effectiveness of the reservoirs is not just the dead storage which is referred to, but also the live storage, which is part of the irrigation channels and the other various activities that are associated with holding water at a certain place. The CWC report, which he also mentioned, brought out that they carried out an analysis of over 439 working reservoirs of this country, of which there is an annual decline of 0.74% of dead storage per year. This is a massive figure, which if you extrapolate will make most of these reservoirs, which he also mentioned, ineffective by 2050. So this is a problem and it requires vast amount of investment, and before that investment comes in, a lot of data to arrive at a plan to deal with it. So all of it brings us back, what is the subject matter today, which is sediment management, and which he also rightly mentioned will require a very holistic approach after understanding what are the hotspots and then lead to certain, we exploit our water systems so that we can bring about the efficient management of this in a way. So let me come back to the subject. I digressed a bit. So India's rivers and estuaries and coastal areas experience substantial and continuously changing sedimentation influence of weather, tidal effects, and the coastal processes. If this sediment accumulation is not adequately understood and managed, it can reduce navigational depth, increase the risk of grounding, cause delays, and restrict both commercial and strategic movement. So if I were to just switch gears and move on to some of the key inferences or something that we can carry from here, from today's subject and its deliberation. There are about 7, 8 which I listed, which I thought I can share with you. First is that, which Romit also made a very strong case about, is that sediment management has to become predictive rather than reactive. Why? You have to be able to anticipate issues and take corrective measures before they become a constraint on you. It brings down the costs. But herein lies the challenge. Everything that you want to do predictive depends on the credibility of the data that you put together, and which Commander Das also very briefly mentioned. There are various people generating data today. There is no single agency which is taking ownership and assuring the credibility of this data. Till such time this happens, this effort of predictive management will continue to remain in the realm of discussion and not a reality. Second is the acoustic technologies provide an important enabling capability, but like you also very rarely, there are far too many layers of challenges to this. How are we going to cut through it and put in place a very, very effective system which is cost effective is going to be the challenge which we'll have to deal with, and maybe that is an area of further research and collaboration that we'll have to look at. Third is dredging cannot be reactive. And it is not an answer. It is not a sustainable answer all through the year. So therefore, we'll have to look at aspects like sediment bypassing, trapping, channel trading, and various other things. And more importantly, usher in a behavioral change, which will help us manage with the sediment before it becomes a huge mass at a given particular area of interest. Fourth is that navigational requirements and environment stewardship has to go hand in hand. Dredging windows and methods will have to factor in the requirements of mangroves, wetlands, seabed habitats, And also, where do you deposit these contaminated sediments? Fifthly, and this is the data problem that you referred to, is that digital transformation can connect the entire decision cycle, which I also say, but then the credibility of this data will have to be established. We have to create a comprehensive, common picture. The answer could be in the identification of the hotspots and assistant optimization of our resources. General Manoj Pandey also in his talk in the morning had mentioned that if you don't understand the problem, you cannot manage it. Security comes from understanding the problem. So therefore, there needs to be an integrated approach, be it the port development requirements, the environment agencies, everybody have to work together, identify a problem at the planning stage. Second behavior should be considered right from the planning stage, be it ports, inland waterways, reservoirs, fishing harbors, or any other coastal infrastructure that is being put in place. So finally, and perhaps one of the more important aspects is that no single agency can collaborative approach and multiple users benefit from the same systems that are put in place. That will make it. So we'll have to look at dual use, multiple use opportunities for creating such an infrastructure. If I were to just lead you with where, since we are talking in the domain of underwater domain awareness, where it aligns with the 4 pillars, sediment management, I can say that there is a clear alignment of the operational necessity to deal with sediment management. Assured channel depth is a strategic requirement. We cannot wish it away. Data with various users can strengthen the operational awareness, not just for strategic, but also for commercial requirements. As far as the blue economy goes, effective sediment management can improve port efficiencies and reduce the dredging costs over long term. Predictive dredging is the way forward as far as I can see it. Disaster and environment, well, environment impact informed dredging windows can minimize the ecological disruptions. And of course, science and technology alignment requires the development of indigenous sediment profiling instrumentation and strengthen the national capability in this particular realm. They reinforce each other. To conclude, if I were to just distill this entire subject into one single message, I would say that we should move from merely dredging channel after channel to a paradigm of where we manage sediment before shoaling becomes an operational problem. And to be able to do that, we need an integrated sediment intelligence ecosystem, something which you had also mentioned, in which remote sensing, acoustic measurements, modeling, environment assessment, operational planning, and decision making. For India, this is particularly significant because our monsoon rivers and systems demand solutions that can be adapted to Indian conditions. The development of individual acoustic instrumentation, integrated data platforms, and locally relevant predictive models can create both operational resilience and a strong science and technology foundation for capacity building. So to conclude, if I believe that three broad priorities, the first would be to create an infrastructure which can help us continuously and reliably monitor the situation. Second is to invest in technological solutions that will help us get better acoustic measurements and create the infrastructure for modeling, etc. And thirdly, focus on the collaborative aspects, including wherever it is possible. So with that, ladies and gentlemen, I'm sanguine to cover this subject in some depth and bring it across in a manner that helps you all understand it better. And I thank Rohit once again for a very nicely presented paper. Thank you.
Thank you so much, Ramesh sir. I think you summed it up so beautifully, and I think it brought the whole session to a very good closing, I would say. I would also like to welcome Jaspreet Solanki, the CEO of Mahindra Defence Naval System. Thank you so much for being with us. And I want to just add, not that I want to speak after the chair, this one point. Yesterday, we did present the MSP platform. So that integrates sediment management as well. And in that, the predictive aspect is clearly brought out because, as you rightly said, that unless we can predict, we will not be able to manage. And I think the allowances have kind of shrunk significantly. I mean, whether allowances in terms of economic deployment of resources, whether it's allowances in terms of the sustainability aspect, and also in terms of the social aspect. I mean, now communities are getting stretched, and politically it is becoming unmanageable to kind of hold on to the aspirations of the local people or the community. So from that perspective, I think we have to be far more optimized in our ways in terms of using resources. So I think that will be a very significant tool. We will continue this discussion with you, sir, and so thank you so much. We'll wait for you.
Welcome back, everyone. We'll be starting with and marine environmental economics. As we said in the previous session, as you all saw, I was just thinking back to something that I said yesterday during my presentation, which was I used to think that we are very land-centric people. We only think about the land, but at the same time, we adore the Himalayas, that they are our mountains. But the moment those mountains are hit by the monsoon rains and glacial and become sand, and when that sand enters water, which is what becomes sediments, suddenly we forget about the importance of what that sediment is and sedimentation and everything that was explained in the last session. So it seems like our issue is not the water in itself, but once it crosses over the layer of going into a water body space, suddenly we don't give it the importance, or we're not able to see into that. So that is the primary thing. How do we govern what we cannot see? So that leads us to the next session, which is accounting and marine environmental economics. Our main presenter will be joining online, Ms. Catherine J., who is the head of research at the Maritime Research Center. Session chair will be Dr. Ajit Ranade. He's an economist and former vice chancellor of the Gokhale Institute of Politics and Economics. So, Ms. Catherine J. Has a strong interdisciplinary background with a master's in water science and policy from Shiv Nadar University. Her thesis explored socio-economic challenges in drought management and climate change. She also completed the Young India Fellowship at Ashoka University and holds a BSc in physics from. Professionally, she co-chaired the awareness ocean summit convention in 2024 and authored a position paper marine planning for UDA skilling handbook. Currently, using an MSP handbook designing e-learning modules on the blue economy and contributing to a monograph on the Indus and Brahmaputra transboundary basins. As head of research and publication at the Maritime Research Center, she oversees key projects and is also co-editor of the UDA Knowledge Center, demonstrating her commitment to knowledge dissemination, capacity building, and sustainable development. Along with us as session chair, we also have Dr. Ajit Ranade, who has served as Vice Chancellor of Gokhale Institute of Politics and Economics, a deemed university in Pune from 2022 to 2024. He earlier served as Chief Economist of the Birla Group and Chief Economist of the ABN AMRO Bank, India. His professional career has spanned academic and corporate assignments, including teaching in universities in India and the United States. He has served on many boards of companies, academic institutions, and trusts. He has also served on various committees of the Reserve Bank of India and most recently in the Committee for Fuller Capital Account Convertibility. Dr. Ranade is a trustee of the Pune International Center, board member of the MCCIA, and chairs the research advisory panel of the Indian Institute of Banking and Finance. We are grateful that Sir is able to join us for today's session. Ms. Catherine J., the floor is now all yours for your presentation.
Thank you, Callus. Good morning, everyone. My name is Catherine. I'm really thankful to the session chair, Ajit Ranade, sir. So I'll start my presentation. As already mentioned, the topic for my presentation is blue accounting. So in all the presentations that we've looked at now, one key factor that is kind of the dictating factor, which everybody is not sure of what exactly the value is what is the monetary advantage that a particular endeavor is going to give you, be it sediment management study, be it your underwater radiated noise management study, whichever endeavor that you undertake, if you are unsure about what is the advantage that it is going to give you, it will not lead you to a satisfactory decision making system. So in that context, what at MRC we have the next step that we are taking up after we started the research on various other different sectors in ocean is understanding what the blue accounting process should be. Because it's not an easy task, because you have, unlike terrestrial ecosystem, most of the ecosystem related to your oceans is underwater, and which is not clearly visible, and even the stock and the flow in your oceans are not clearly understood or defined at this point of time. So when you don't do that, you don't even have proper data to back it up. So in that context, how do you take this particular endeavor forward? So that is what we have been trying to do. And in this particular project, the unique contribution, the unique aspects are going to be that we are going to be using three major capabilities, which is the underwater domain awareness capability, the blue accounting methodology that we are developing, and the modeling and simulation based marine spatial planning. So under this background, with this background, I will like move on to the presentation. So starting off with why we are doing it, because we know that the ocean is productive. Because there have been exploratory research on what is available underwater. Even though we don't understand it completely, we know that there is a lot of potential for minerals, mining of minerals, or your livelihood development, for your food security. So yes, I just started off with the background. So we know that the ocean is productive but poorly accounted for. So within this context, we have a conventional account system which answers your key question about what kind of gain we are getting from different ecosystems, which is visible. For example, or the sector that is visible. For example, you have fisheries, you have tourism, you have shipping, you have aquaculture systems. So when you have what we have been doing till now in the conventional accounting system is to capture the economic flows only, without understanding the natural capital which is sustaining them. So what we are trying to do here, we are trying to make visible the degradation of the asset base or the exploitation of the asset base as such. And the blue accounting, what it makes is that it makes the ecological conditions and ecosystem services visible alongside your economic performance. Even if you're not able to bring out an additive image, but you're going to be accounting it, tracking it, and making it visible. So we are particularly why this is important for our system is that we have a lot of overlapping systems that are together in place, but in the tropical waters we have a high value system. One particular stock has a multiple range of ecosystem services and outputs which needs to be accounted for, and then at the same time it's a high velocity system, where the changes are there are extremities, there are dynamic changes which are the periodicity of changes is high. So in that scenario, our monsoon dynamics, our blue carbon ecosystem, our biodiversity, the livelihoods that are dependent, because we have a high population state. So the livelihood is going to be, the dependence is going to be high. The climate shocks, the governance issues with regards to different departments managing different aspects, and the lack of data. So all of this creates a very a complex system in our tropical waters, and to understand that, or to untangle the whole system to as much extent as possible, we have to make sure that we understand the tropical waters and then map it to the blue accounting system appropriately. So the three capabilities I've already talked about for this particular decision-making system is your blue accounting method itself, which talks about what assets exist, what are the services it provides, and what is the economic contribution. And then underwater domain awareness talks about what is happening underwater, your ecosystem, your ecological condition, what is happening now, and where it is happening, at what intensity, and the third capability is your modeling and simulation based marine spatial planning. So it gives you a predictive analysis, what is going to happen with the current state of affairs. So it helps you give you come arrive at a scenario based approach. So you're accounting, you're observing, you're simulating, and then using those simulations, you're deciding, you're monitoring, and then updating the system accordingly. What UDA is going to be doing is making sure that all the relevant data, whatever is available and whatever gaps are there, it also highlights the gap, the data gap, so that the transparency is increased. So we arrive at an integrated marine intelligence, which will support your other capabilities. So what marine spatial planning in itself is going to be doing is that apart from your predictive analysis, it is also going to make sure that your trade-offs are visible. For example, if you take one particular sector such as fisheries, you evaluate it against what are its different contributions, and then how that in that particular space, if an offshore energy sector is going to be developed, how is that going to impact all of these particular factors, and what are the conflict and the compatibility ratios that we can arrive at using the marine spatial planning tool. So blue accounting ultimately quantifies the value to some extent, and the UDA make sure that the value is current, the evidence is current, because it's going to be a near real time feeding system. And then your marine spatial planning will help you test alternatives. So with that background, I would like to start off with the basics of how we are taking up this accounting process. So we are going to be making sure that these 5 pillars that I have displayed here are going to be the backbone of the different methods that we are going to be taking up. The first is the natural capital. So your natural capital is basically your stock in the ocean. It could be biomass, it could be the habitat that it is providing, it is the biodiversity indices, and the ecosystem health itself in terms of coral bleaching, water quality, etc. And the second pillar is your ocean economy, which is basically what we have been calculating till now to some extent. For example, in India, at present, the value that we are considering as contributed through ocean-based industries is 4 to 5%. But grossly speaking, that seems to be like an underestimation, but we do not have the evidence to back it up or to support it or to contradict it. So in that scenario, what we have to do is we have to look at the other interconnected systems along with the ocean economy. So your third pillar is the ecosystem service. So this is basically the flow of the system, flow of your stock. What is actually being derived from your stock? And then the social and equity dimension. So how it's going to affect your social the society, the livelihood, even the security-based issues, and also the advantages that you gain from these systems are not going to be equally distributed. There is going to be equity issues also based on the power and power of the stakeholder, etc. And the final backbone, the final pillar is going to be your governance and sustainability issues. So all the norms of sustainability and also all the policies and vision that we are coming up, even the Mahasagar vision itself, all of these governance policies and visions, how are they mapping on to these existent systems? So the first 4 are what we have, and fifth is what we are going to be deciding. So in this interconnect, this is going to be our backbone of 5 pillars. And the approach that we are going to be taking up is the sectoral analysis strategy. So here we are going to be asking of picking up a few sectors. The sector could be the purely economic sector, or it could be a sector, an ecosystem itself, like a mangrove system or something, or a coral bleaching system, which has advantages, which could have value, which is adding value to the system. So we are going to be segregating it sectorally, and we are going to be asking a few questions. What activities use the marine space? Where and how intensely is the sector operating? What is its contribution? What are the pressures it's creating? Who is benefiting? Who is bearing the cost? And how is the sector regulated? So after asking these questions, what we are doing is we are starting narrow, and then we are trying to prove value of the system by collecting evidence, and then we are going to be standardizing it and then scaling it up. The method that we are, and once we pick out a sector, we are going to be seeing a certain number of value generating factors and a number of value degrading factors. For example, your value created will be your direct market value, your indirect values created, your avoided cost, your strategic cost, strategic value, your ecosystem services. And the value lost is going to be your environmental degradation, opportunity cost, restoration, and degradation cost. So your blue value is not revenue alone, but it is going to be the value of nature and the cost of environmental and social impact. So making sure that the ocean value of the development is visible. So starting off, I want to start to explain it better. Let's start with a case study. So what we did was we took Vadhavan Port and we analyzed how the biofouling management system that we are starting off in Vadhavan Port going to impact the environment around it, the ecosystem around it, what is the value getting generated, and what are the liabilities. So to start off, the purpose of a biofouling management system is to make sure that the ships so for those of you who do not know what biofouling is basically when the ship is transiting across the oceans, it kind of collects different algae and microorganisms and marine organisms in the hull and the underwater part of the ship, and these get hardwired into the skin of the ship, so making it very difficult for manual cleaning. So what happens is periodically you're supposed to clean it up. Otherwise, it is going to increase the inefficiency of the ship. It is going to increase your drag force, etc. So it's a periodic requirement, and when that is and not all ports have the facility to do it, and certain ports do set it up as a revenue generating system, and plus to make sure that the efficiency is increased. So the liabilities that were present because of biofouling are kind of addressed through a anti-fouling, the biofouling management system. So here, once we are setting that up, we are going to be asking a question. What conventional economics asks is that how much money does biofouling management save or generate? But what we are trying to ask is a broader question. What economic, ecological, strategic, and social value is created, and what losses or liabilities are avoided or generated because of biofouling management? And what is the best possible pathway, the technology, the social, the environmental pathway to execute that particular management? So what the results that we got was that as far as economic impact is concerned, about 4.5 lakh per hour rupees was getting expended because of persistent biofouling in ships per ship. So in that per hour, this was the economic liability that we are trying to overcome. And uh, once the biofouling management system is in place, we are also going to be facing another set of liabilities, the pressures that that particular system is going to put in on our oceans, which is invasive aquatic species transfer, paint particles and biomass and turbidity changes, risk to fisheries and coastal ecosystem around that area. And also, if there are other power plants or anything else in the same zone, what the invasive species, how they are going to be impacting them, and how soon they are going to be impacting them, etc. And then what the bio accounting response is, what is the best possible way to make sure that the whole system is put into place. So we are measuring the environmental and economic benefits and liabilities, and we are also suggesting which is the best possible pathway to take it up. So the list of assets and liabilities have been listed down. So using which we are going to study how advantages this is going to be, and we are going to be using this in the equation that I had already showed before. So basically what we have done here is that we have made a comparison between what is the liability we have avoided using the system and what are the liabilities we have created. So this is going to be the critical point of how this particular business is going to be judged. Once we have all the factors in place, we are going to be putting this into our system. And we are not going to be arbitrarily subtracting or adding environmental and social impacts from the value generated, but wherever it is defensible to be monetized, we are going to be mentioning that. And the non-monetizable and strategic indicators are going to be reported separately in such a way that it is not invisible, but the key components are properly visible. The priorities are going to be set up as to see how we are going to make the final decision. So that was our Bardhavan case study. And we tried to do another interesting case study, which is to bring together three different sectors. So three representative sectors from economy, social, and environment perspective. So you have your ports, which represents your economic gains, your fisheries, which is important for your social, your livelihood needs, and then the mangroves, which represents your environmental factor. So we first what did first was we study these three individually. We studied what are the different factors: the market value, the indirect cost, the indirect value, the avoided cost, strategic value, the ecosystem services, etc. Similarly, we studied the loss the same way. Now, after doing that, we try to see how, that we applied the blue accounting principles that we started off with to this three highly interconnected parts of the coastal economy, and try to connect the economic activity with the ocean assets, the ecosystem condition, and the benefits those assets provide to the society. So the objective here is to make the full development balance sheet visible. So this is only representative. The system is even more complex than this, but this is how we wanted to test the whole system. So for the ports, we generated the value, the environmental liability, the social liability, and we are trying to create a parallel accounting layer with the other sectors that we started off with. So for the fisheries also, we did a similar exercise. We saw what is the value created and what is the value lost. And for mangroves also, we did a similar exercise. So this is perhaps one of the most important part of this whole, because whole case study too, is because mangroves illustrate the difference between an ecosystem with a visible market price and as compared to something which is not visible, and one which has a large market value. It has a lot of ecosystem services value, but which is not properly visible. So bringing this into the forefront makes this exercise unique and challenging to some extent. Once we started off this, before I'm going so the core challenge that we faced while doing the second case study is to account for the double counting problem. So for example, 1 hectare of mangroves provide your nursery habitat, supports fish recruitment and increases fish availability, supports fish income and food security. But the accounting problem is that not there are the same stock and the service provider, there are intermediary outputs which gets accounted for double. For example, so to overcome that, what we are doing is to make sure that we represent the causal food chain, the chain of economic gains properly. For example, from the mangrove, you get the fish recruitment, and then you move on to fish catch, and then fish sales and fish income. So the potential double counting there is a potential double counting if every step is monetized and summed. So what we are doing now is to make sure that we put a certain set of rules. For example, we define the physical asset first, and then we separate the stocks from the flows, and then identify the final value and attribute impacts spatially as well, to see which community is impacted in that particular space, or which ecosystem is getting damaged in that particular space. So a spatial allocation is also done at this point, and then we maintain a double counting register. So what is a double counting register? is something of this sort. So what we did was we picked up the value item, and then what is the asset associated with it, and we try to segregate into different types, whether it's a stock, whether it's a ecosystem services, whether it's an intermediate benefit, or whether it's a final output, or the opportunity cost or a restoration cost. And we try to define its relationship and make sure that we are counting it once and not repeating it. So what we are doing here finally is to make sure that we observe the system, we account for it, and then we model it. So in the modeling simulation part, what we are trying to do is we are going to factor in the time and the space component into the equation, and making sure that a particular ecosystem, a particular stakeholder, or a particular ship is going to be defined in such a way for the time it is the time the period that an impact is the sector is working on it, or at what time of the year a particular work is being conducted, and for which season, which time, and which place, and how long. So these are different factors that we are going to factor it in the modeling and simulation part, and going to also come up with a scenario based analysis where if no, for example, you're in the Vadhavan biofouling example, if no intervention is applied, what is going to be the value, ocean value generated, the total ocean value in that particular sector? And if an intervention is applied, what is going to the total ocean value? And also, we are going to be comparing it with the different kinds of ways you are going to be doing the anti-fouling work. So in a way, you're going to get a delta ocean value, which can be used by the policymakers to arrive at a decision. So this particular the way the result is going to be displayed is in such a way that it benefits the stakeholders which we are going to be working with, the government, the investors, communities, and marine industries. So the value generated, even the externalities and the liabilities and assets that we are going to be listing, it's going to be a comprehensive data that is going to be generated for your stakeholders to make prudent decisions. So what we have done is we have created a common evidence base, and then we study the trade-offs, and which will give you a stronger legitimacy to for investors to invest, or for government to implement a certain policy, or to community to accept certain interventions by the government. So in this particular, what we are trying to achieve, and what we have partially achieved till now, is that we are trying to combine economic growth, ecological integrity, and social equity. And the question that we are asking no longer is how much does the ocean produce, but what ocean assets sustain that production, because we are defining the natural stock. And how do we keep them productive, equitable, and resilient? Through our study of blue accounting, through our study, through the modeling and simulation, we are going to be seeing how to make them, keep them productive, equitable, and resilient. So from evidence, so we are going to move from a reactive system to a planned system to create an adaptive and climate resilient ocean governance. Thank you so much for the opportunity. I'll end my presentation here.
Yeah, I have a very basic question. When you do this analysis, what you're producing and what benefits you think, what you're losing, on the specific thing, if the loss is going to be more than produced, are you going to give up the production? Did I get my question right? Did you hear me?
So I couldn't hear the last part of it. Can you repeat?
Yeah, I'll just say it again. Those a column where you're making the assets, which are say fish. On the right side, you're having what is the loss that's taking place to the environment, is that etc.
Yes, sir.
Suppose it comes out with a loss on a particular one. Suppose it comes out that the loss is going to be more than the produce. Do we give it up?
It's a very interesting question, sir.
No, I'm just thinking.
Yes, sir.
Logical person.
Yes,
You
yes.
know, because sometimes the loss could be more. but the requirement of that is essential. Then how do we, bring this out to the community? That's my question.
Right. So we have been, if we look at what we have been doing till now, we have been doing something similar. So it's not like it's something that we are doing for the first time, trying to understand what the ecological benefits are, so that, or the losses are, so that we can, demotivate an industry. We are not, there have been a lot of attempts to do that, and it has led to a lot of radicalism in the approach. What we are trying to do is make sure that it is backed by evidence. And sometimes, you are absolutely right in saying that if losses are high, a certain radical groups might arise saying that this particular, for example, in your dam building also, that's one of the classic examples where, the displacement of population, etc. But what the government finally did was to make sure that the hydropower requirements and the water requirements for the farming, etc., you took priority. So prioritization by the government is also something that is definitely going to be a key factor. So this is we had a discussion internally also. What our system is going to be providing is only a 60 to 70% of the weightage of what the final decision of the government or any stakeholder is going to be. So this is going to be providing a value to the decision makers on basing their decisions. Then rest of it is of course going to be what is the exact situation on ground. So there could be maybe there's a famine, and you definitely need to have some food security needs met. So you're going to prioritize that, and you're not going to be saying that the ship is going to be going that way, or we need the renewable energy at that point if the people are dying. So it is going to be different. And also the value that is going to be generated here is definitely, I'm assuming it's not going to be completely the loss is going to overpower the profit. But if we look at it, because even once you create a system, 10 years hence also the effect of the mangroves or something, the natural ecosystem that gets lost, to recover that, it is going to take a lot of time, and to replace it also. So in that scenario, you cannot absolutely account for the loss. So these are all going to be a subjective addition to what the results we are going to be presenting. So at the end of the day, as human beings with agency, we are going to have to look at the other condition. Economics can capture only up to a certain extent of, so that's why a margin of 50 to 60% of the decision making weightage is going to be given to this particular blue accounting process, and the rest is going to be from the perspectives, maybe cultural perspectives, because of traditional knowledge. Maybe we that is not all accounted here. So when you account for all of that, your decision could go in any direction. So but we are going to be providing a scenario based analysis. So whatever decision the government is going to be taking, it's going to go in with the surety of what result they should expect. Be it if they do it knowing that the externalities, the negative externalities are going to be more than the positive, they are going to face that repercussion. So there is no denying that. So yes, sir. I hope that answers the question. Yes, sir.
Present, yes, but 15 minutes later, I'll have the same question to. I just wanted to update because since we are working on biofouling, India is going to present a paper at MEPC on guidance on biofouling risk assessment following prolonged vessel inactivity. During the opening session, I think the sir had raised about the vessels which are laid up in the state of Hormuz. So, apart from that, I just want for general knowledge to all the participants. India is also working closely with IMO in the development of guidelines on the biofouling code. Due to the various dynamic aspects in shipping related to biofouling and relevant risks in transferring, pathogen from particular area to another area, it is decided that a separate code has to be developed which will address correspondence group, which is actually formulating the rules and relevant regulations. Few of them are like keeping a biofouling record book, the periodicity of the cleaning of the hull, and what will be the periodicity and how the cleaning will be done, and especially the discharge of that cleaning activity. That is the main aspect wherein all the countries are what you call we are not in the same frequencies. So developed countries are on a different direction. Developing countries are in a this different direction. So anyway, this is just for the general knowledge, and we will be sharing this paper to you or sir also, so you can have a view and just read the last date before we submit it to IMO. Thank you.
If we have the next session on biofouling post-action, Suchi will be presenting, so we'll discuss that also further. Thank you so much for your remarks.
So first of all, let me begin by congratulating for Dr. Arnav Das, his team for this what I call extreme like project of passion. I've been fortunate to witness his work and his journey for many years now. And every time I come for some of these sessions, it is really amazing and quite inspiring. So, of course, Katsin and Romit in the earlier session, you can see the amount of work they are doing. Romit is here, or is he here? Very here. Okay. So your presentation also was almost like a PhD Viva presentation. So it's a lot to Dr. Das, it's a lot to absorb in a short period. So I really must congratulate the effort. And I know this is almost they are doing it like in mission mode, And of course, Prabhu is helping them. It's, you have to keep at it because this is at one level seems like a very abstruse and complex. In fact, Kathleen also said in one of her comments that it is a very complex, even the exercise that she was trying to describe. And then to relate it to people, and you were saying in our private conversation, sometimes people have this wrong perception or their emotional response or not able to appreciate. So this is a very hard, you guys have taken the hardest possible projects, but there is no other way except to keep on persisting. And the most important thing about Dr. Das is incredible optimism. Karte raho, lage raho kind of a thing. And that too with a smile. Okay. So congratulations, and I'm happy to have it today. So actually, my comments are going to be generic, but I realized that what Kathy has done is focused on the case study. I mean, this subject is very. What is the session? The session is about blue account and environmental economics. It's an accounting concept incorporating something which is not in mainstream economics, which is the environmental consideration, so environmental calculations. But what she spoke about is much in-depth case study of the urban core. I'm just kind of guessing I just some I mean some of your thing, of course, and I don't know if any of people know that she's a physics graduate. So after physics, coming into this field is quite a journey for you. So let me just make a few generic remarks for the sake of, because I'm sure students and all people who have a general interest like to listen to these remarks. So in the earlier session and silt control, and one of the mentioned I think was floods, the urban floods. So here is one data point. I believe that the Pune Municipal Corporation, the local authorities, a couple of years ago, spent 900 crores on flood control. It was an episode in just 1 year or a few months. Of course, really the power areas, I don't know, some in this region. So it's a huge amount for a city to spend 900 crores is not a small number. Why? Because despite all kinds of regulations and control, you're not supposed to set up construction activity or not supposed to establish but the relentlessness of urban development, urbanization is such that they've come very close and is rain, and that you have this volatile rainfall situation. Then you have to do this disaster management. But in just 1 year, they ended up having to spend 900 crores. Now, if you had done this kind of accounting, that how much money, she said something about how much is saved and how much is not spent, something like that, right? Opportunity cost. So in your accounting, if you had factored that in, then you will be aware and you'll be prepared for such things. Otherwise, it's always spending post facto, and that too, then your fiscal deficit goes. So that's an example, very recent, I thought I should mention. It's very relevant. So while we talk about UDA, underwater domain awareness, and our person is from the Navy, so we think a bit of security, but actually, if you look at the topics that we are covering, they cover everything. We are talking about governance, we are talking about fiscal situation, we are talking about livelihoods, and we are talking about civilian issues. So it's no longer just restricted only to security or military. It's a very broad subject.
Security systems can take care of themselves. We have to look at it.
Yes, exactly. But it has a bearing on all aspects of our life. The second example, I'd like to give you is the fact why this accounting is important from in the economics framework. Of course, General Pandey in the morning, I think, mentioned, maybe indirectly referred to the fact that what does not get measured cannot be managed. This is a very big principle. It's like a cliche almost. So you have to measure it, which means you have to account for it. You have to have it in your accounting books, in your balance sheet. So if you don't measure it, so look at the way how it's measured. So if you cut a tree and then you sell it as timber, the value of that cutting becomes positive value to the economy, because you're cutting down a tree and you're making timber, and the timber is used. Is that all there is to it? Of course not. So that is one drawback of the conventional way we measure GDP. And this is the starting point of when she says blue accounting, let's forget the word blue for the timing. In general, accounting in environmental economics is that to account for everything. Now the only giving you a timber for your furniture. It's actually giving you many other services, carbon sequestration services, then holding the soil together in flood prevention services. Then of course in 44 degrees centigrade giving us shade. I can only use my imagination. I'm sure there are 100 other examples. How has that been factored in? I'm just giving you a very, very simple example. So that is why this accounting framework is important. And it's not easy, by the way. Just the deeper you think, there's so many things you have to, but we have to make a start somewhere. We have not made a start. To this day, the GDP concept as we know it today is probably 60, 70 years old, maybe 80 years old. It's a very modern thing. It wasn't there during the time of Adam Smith, who's considered to be father of modern economics. It wasn't there in the time of David Ricardo. And we simply have not come to grips with the fact that it needs to include many more things. Not because we don't know, but we are not agreeing on the methodology. So Dr. Das's and his team's effort is actually a push, more and more persuasion. Let's start finally incorporating these things. Every year you hear from the finance minister's budget that we need to have impute some value to the kind of work that women do at home. Typically women at work do unpaid work. Very fancy way of saying that you take care of the children, take care of the house, you do cooking, and you take care of the elderly parents, and you do social service, but you don't get none of this work is for pay. So therefore, it's absent in GDP. And women's participation in the workforce, labor force, because of this definition is very, very low. India is so low that it's actually lowest in G20, even lower than Saudi Arabia at one time. So this is something that is a big hard topic of debate nationally. But also one of the reasons is that because this doesn't reflect in GDP. Does that mean we should ignore it? Of course not. But how should we measure it? That's where the discussion comes in. So sorry, Catherine, I'm actually broadening the scope of your discussion to points perhaps which are not directly related to very specifics of the Baldwin case you made. But I thought it's important to emphasize the importance of this incorporate. Then similarly, the drawback of GDP. So this is the unaccounted for valuable services, whether it's the tree or whether she said mangroves, or whether it is the work of the housewife. Sorry, I'm saying housewife, it can be house husband also. There are the unaccounted for positive, but then negatives also. Just like this is the drawback that GDP fails to capture these services, but GDP also captures services which we don't want. Suppose there is an, the Pune police services, they run a service called Bharosa. Does anybody know about Bharosa? At least one person, elderly and women. Yeah, it's mainly for women. So, because if there's increase in crime, even in a safe city like Pune, women should feel safe going alone at night and so on. So there's a Bharosa cell. So now they have to open more Bharosa cells. They have to recruit more people. They have to install more CCTV cameras. And in the meantime, private societies, buildings, they have their own private security guards, gated communities, then all kinds of biometric entrance, entry, exit. All this is, by the way, increasing GDP. So जितना crime बढ़ेगा, जितना crime का chance बढ़ेगा, उतना GDP बढ़ेगा. So that I'm just giving you examples. So don't think that by missing out on the good things in GDP, we're missing out something. But we are also capturing something in GDP, which is something I'm not sure. उससे society का कल्याण बढ़ता है क्या? Welfare बढ़ता है? If there's more crime and more CCTV camera installation, do you think GDP will go up? We will become third largest GDP in the world. But is that what we want?
Somebody has to see the camera. That is a problem.
So that's a later problem. That is, even if you have all the CCTV coverage, nobody is watching those strategies. Maybe sometimes that it's a CR Agarwal case, somebody is watching. But that's one example. Another example is, if you go to Delhi today, almost every home which is somewhat upper class or slightly higher middle class, they have 1, 2, 3, 6 air purifiers. Every bedroom has one air purifier. Then other people who can't afford air purifier, they are coughing all the time, so they take some medicine. कोई antihistamine ले रहा है, कोई सब injection ले रहा है. Then so increase in medicines, increase in medical services, increase in air purifiers. All this is adding to GDP. So Delhi will become a very fast-growing GDP sector of the country. Is this what we want? So I can give you many examples. Third last example is that for the last 4.5 years, almost 5 years now, there's been a war in Ukraine. Okay, we thought the Russians said we'll go there in 1 week, 2 weeks, it'll be over. Now it's 5 years. We also have a war going on now in Iran. Every few days, not maybe few hours, we say abhi ho gaya ceasefire. But it's still going on. It's not over. Nobody's saying it's over. Then in Gaza, it's now what, 3 years, 2 years? There have been bombing. Now, all this situation is going to lead to, of course, there have been lots of lives lost and horrendous misery, but it's going to lead to a lot of demand for reconstruction. New house, again, those houses have to be rebuilt, roads have to be constructed, community centers, schools. All that is going to add to GDP. So then let's have more wars. GDP padega. So I'm just giving examples while on one hand, Catherine's presentation and this whole session is about how when you're trying to measure the blue economy, you're missing out. If you just count, she gave some examples in the context of if you just count the number of fish caught or something, but you're not taking into account service flow out of, but she also warned about the erosion of assets where that also gets counted as GDP, but that's actually negative in the ecological capital. So that is all unaccounted for services which are potentially positive. Here are services which we get accounted, but which may not be what we want. So the task, Dr. Das, is actually quite complex. So, I mean, with that in background, let me just quickly make some comments now. So it's of course excellent presentation, Catherine. We care, like you said, right now we only account for 4%. The blue economy is only 4% of GDP, but it is a highly big underestimate because of many marine ecosystems are like coastal protection due to mangroves, carbon sequestration, nutrient cycling. These are not captured. So therefore, the question is now how to the big question in this session is that how to close the gap, what is not counted. Secondly, when you calculate GDP, all these things which are not priced, which are not market transactions, you count it as free. So the ocean is free, ocean services. Only the fish catch shows up in GDP. But the other thing, the ocean services don't. So I think she has a word for it, total ocean services or something. Value, total ocean value. Yeah. So we need to. He mentioned that we need to account for this asset reduction, asset drawdown, as she call it. And mangroves, seagrass beds, salt marshes, they all sequester carbon. So in this now there's much more awareness among the Millennium Goals. I think climate change has found so carbon sequestration is now well acknowledged to be a very valuable service. I was surprised to know that mangroves per hectare or per square kilometer actually sequester carbon much more effectively than forests. This is, I mean, I didn't know, it's by a factor, very significant factor. So that has to be captured. That's another measurement gap. And then, of course, you mentioned the Mahasagar, but Sagarmala program also is also about the port-led development. This Vadwan port, which is coming up in northern Maharashtra, on the near Gujarat border, they all assume that this development study will assume that services will go, GDP will grow, but the blue accounting is the framework which will give you the gap between. I think she has presented it very validly. I mean, very in a very detailed manner. What is missed out and what is well. Of course, you know the chief minister and everybody is very happy because when this comes up, they only focus on how much investment will go up in port infrastructure, lakhs of crores, how much employment will be created, how much logistics and trucking business will come. But I have not seen this thing given as much prominence as perhaps is required. I didn't hear you, Catherine, mention about any financing, how this financing will be done. I think it's there in your write-up about these blue bonds, right?
Yes,
So
sir.
I don't know if you mentioned the blue bond scheme, because that has a huge potential, I think, because given our coastline, 7,000 kilometers, the idea of a blue bond, and I believe there's only one example internationally, which is from Seychelles, but whether there is scope for India. So that's about all that I have to say. The biofouling thing I'm not going to mention because that's a very important. The next session is about on that. I wonder where the word fouling came up because it's something that we foul means we degrade, right? It has nothing positive about it, no? Or I don't know whether it's both positive and negative. But biofouling is the economics linked to biofouling is that apparently an estimated $150 billion of increased fuel consumption globally and hull maintenance is because of biofouling. So we can save up to $150 billion if you focus on that. So this is a direct economic cost, and I'm sure there is a lot of indirect economic benefit from biofouling initiatives. So, so this also again the blue accounting framework will capture. And of course, then the fisheries valuation. We have, by the way, I just spent one last couple of minutes. There used to be a lot of debate on tobacco. So now, of course, the three stars have come into the limelight: Shah Rukh Khan and Ajay Devgan and that actually Tiger Shroff. Tiger. They are coming to the limelight thanks to Mr. Tukaram Munde. But you know, tobacco is a very interesting example because tobacco provides livelihood to 44 lakh farmers. I don't know what the number is now. There are regions of India like Guntur district, Nipani, northern Karnataka. They are tobacco growers, and those farms. Tobacco is a hardy crop. Unlike less rainfall, it grows in dry-fed region. Doesn't and has a good value because of course tobacco and worldwide, at least in developing countries, and I think in India also, and possibly in countries like Korea, Japan, tobacco consumption is increasing, cigarette consumption. Of course, in India, it's a very strange phenomenon, 80-20. 80% is consumed in the form of tobacco or gutka, only 20% in the form of cigarettes, which actually have huge amount of taxation, including GST. The reason I bring it up to you is that whenever there are anti-tobacco campaigns, you have to worry about the farmers. In fisheries, it's ulta. Fisheries is 7 million. There are estimated 7 million, right, Dr. Das? In 70 lakh fisher folk. So when we talk about Vadwan or we talk about the Sea Link bridge in Mumbai or the coastal road and all that, of course it affects. So it's a negative example of the sense that it's seen as a positive infrastructure development but it affects fisheries livelihoods, fisher folk livelihoods. So there also you have to weigh that, the trade-offs. I think Catherine also said that trade-offs are made sharper. So that's also in when it comes to fisheries valuation, the in capturing all the values. And so finally, I just want to say that this is something, this blue accounting framework is part of a wider initiative to include all kinds of accounting of ecological services and environmental aspects into mainstream GDP calculation, so that we get a more accurate value of increase in, when you say increase in GDP, it should really reflect increase in social welfare. If the GDP is increasing only by increasing CCTV cameras and police expenditure, that is not a genuine increase in aggregate consumer or citizens' welfare. So blue accounting aspects cover this marine aspect, but this is part of a wider framework called ecological services, and there also a lot of effort is going on. And finally, of course, what General Pandey said in the morning in his opening remarks, he said ultimately what you guys are doing has three major elements. So it has the security element in terms of national security or security aspects. Then it has the livelihood aspect, example is fisheries, water, port, and thirdly it has sustainability aspect, so environmental sustainability. That what you are taking away from nature, are you replenishing enough so that people, the unfortunate victims, you may call it, are the people who are not even born. They don't have a voice in this room. They don't have blogs. They don't have Instagram accounts. They don't even vote because they're not even born. Unko kya pata hai? So sustainability is basically taking care of those people. So thank you for the opportunity. Thank you very much.
If anybody has questions for Dr. Ranade, yes. Yes, sir.
But I have a couple of comments.
Yes.
That's it.
Yeah. And I'm from the financial. And I was hoping to learn a little bit more about blue accounting. Just two comments I have. One is you touched upon the blue bond. Right? And my view is that in the financial sector, there is always going to be a segment of people, and so am I, that who will always be keen to know where they can put their money, which gets accounted in the sustainability area. And we haven't got anything in the blue bond area at all. What this will require is to make one use case of what we call a structured obligation. May not be a bond, where a clear flow of cash from a deployment of money to the eventual investor over whatever period of time, whether what it was of various kinds. If somebody can go one project and make one use case happen, it will cause the attention of all the institutional investors to focus on that.
Like green bonds have happened.
Yeah, like it's happened in green bonds. And it looks, and I think people in this room and what I've seen in our presentation, you have the knowledge, but you probably need to work with somebody in the investments area. Another suggestion I have is a lot of what I heard is never been spoken outside of small, close discussions. One of the ways to get this popular support is to actually with people who are the ear of the decision makers of large ticket sizes. And typically those are, in our context, large investment bankers, large
consulting firms. And I would challenge any of the big four to make a presentation to us on the blue ocean or the blue economy. I'm sure they don't even understand. Which means we have to tell it to them. And if we tell it to them well, guess what? They will tell it to the world. And that's like sharing of knowledge. You may feel proprietary about it, which is find a way to protect it or not. Sometimes it's useful to give it away to people who will make the cause into reality. I've seen that happen in technology. I've seen that happen in other space. Just so these two observations, take it for the big side.
No, that's very true. That in fact, Praful, you can take note that if you can have a special session customized for an offsite or a half-day event or 2-hour event with one of those Big Four consulting, PwC or.
PIC can take the lead.
Yes, it's like passing the ball.
We will collaborate with PIC.
I'll be happy to help you make it.
PIC, and I'm very happy that Ashutosh has come. I especially invited him for this session. So I'm very happy if we can collaborate with this.
Basic message is.
Catherine is there and Commander is here to help us always.
So as I began by saying, I have seen Commander and this effort being persistently followed for some time. But his suggestion is very important that if we can get some kind of a big event where these stakeholders become aware of it. And of course, the messaging will have to be slightly different because I find that because you have done such in-depth work and some of it is very complex and technical, it may not resonate at first go. So you'll have to kind of customize it in a different way. So your question, he had a question.
Yes.
My question was simple, basically
Fair point.
similar question, but nothing to do with underwater. This is the emotional which I was saying. Now we all we are running out of power, we're running out of water in this country, and obviously no water, no food. That's what will happen.
So why are we reluctant about nuclear?
Yeah, I'm talking about nuclear. So the only sustainable power that probably what we can see, right, renewable or whatever it is the nuclear. We have big nuclear reactors which cause people to.
So the question is how to handle the.
So I say that the country and the world is going on for what is called small modular reactors. The reason being is it's less scary before besides anything else. Secondly, it is much easier and short durations to manufacture and put. That's the reason. But still that thing remains that suppose there are 5 together, then what will happen? So that emotional thing about nuclear, you can say we must educate, we keep educating, but we can't move forward because if I count the negatives, thing, one big negative is this only. People don't want it.
But let me just respond. Just this last 2-3 minutes and we'll wrap up.
Just sorry for this intervention. Before, just for the benefit of the audience here, the person who asked this question is Vice Admiral DSP Verma, and he is the person under whose charge the nuclear submarine was built, INS Aryan. So that's just to give you the context. Thank you. Sorry.
So I'll just respond in terms of some thoughts. I'm not saying that I have a solution to this. I'll just draw a parallel that yesterday. So by the way, in 1929 October, I think it was the month of October, the US had the worst crash in its history. I don't think even the 1987 crash or 2007 crash has overtaken that. So the worst crash in the last century was 1929. The Wall Street crash, it was so bad that many brokers just jumped out of buildings and committed and did suicide and all that. And then Mr. Wilson was the president. The 1932 elections, a brand new guy got elected. Actually, his name is FDR, Franklin Delano Roosevelt. He was so popular that he was likely to become president for 15 years. But the US Constitution, they modified it by saying no more than 2 terms. So 1932 se leke 1940, and then he had to retire. During the beginning of the World War, he was the president. Anyway, so as soon as he became president, he was so popular 1930 was a deep recession for the US. So one of the first decisions, it's presidential form of democracy. So the president has more power than our parliament or the way we function as cabinet. One of the first decisions he did was he outlawed the ownership of gold. आपके घर में अगर gold है, you have to submit it to the authorities. You will get 32 rupees, $32 per ounce of gold. 1 ounce is 30 grams. He cleaned out the household gold ownership overnight. And that, of course, created huge amount of liquidity and banking revival and so on. I refer to that because yesterday's Times of India had an article that India, which is consistently has a current account deficit, we're always shortage of dollars, and our rupee is sliding down. It creates inflation. The situation is bad. But here is a country which has 35,000 tons of gold in various households, in temples and trusts. Yet we import 1,000 tons of gold every year. And we spend precious foreign exchange of almost $100 billion every day, every year. So if we could just monetize the gold which is there in our country, we will actually become a current account surplus country. But that will not happen, sir, because of cultural habit or because of people's hanging on to their family gold. Even though we offer a very so-called trustworthy scheme, gold monetization scheme, or convert, pledge your gold into the banking system and you put the gold there, then they will release cash against it. वो सब करेंगे तो भी, but people don't trust. So I'm relating it to your SMA modular reactor. So this is such a big, when the solution is right there and there is no risk like your nuclear reactor. यहाँ पे the risk is that people fear कि अपना gold जाएगा तो government will just confiscate it. It's not that. So the thing is that this is so deep rooted. After the 3 Mile Island accident in 1979, the US did not build a single nuclear reactor for the next 40 years. After Fukushima, which was 2011, is it? 2011, right? Yeah. So it's been like 15 years. No nuclear in Japan or in Germany. Germany shut down because of Fukushima. Now they are repenting. So you cannot underestimate the impact on people's sentiment and mind and the fear. Chernobyl was 1986. Yeah. So you may say it is just one accident. But anyway, it's a long answer. But also I want to caution you, and this is, I've heard it from Mr. Kakodkar himself, so sorry to mention his name because he's not here. No. But basically SMR is only 100 megawatt. And our requirement is tens and thousands of megawatts. Exactly. So it is not going to move the needle much. No. In a big way.
So now you must.
Yeah.
I know you must. Because they will all add to the GDP. We are not stopping that.
So it's not sustainable because then you will have to have a battery system to put the power up there. So there's an issue. And Dr. Kapoor, I know him very well. I interact with him. Yes, anything up to 300 megawatts is called small. The issue is modular and it can be made faster. A. B. There are countries today because they require. Now, for example, you get your data centers. Right? Make the data centers independent. Have a thing, and that can produce hydrogen. The small moderator can produce excess thing, can produce hydrogen, and can also desalinate to give you water for the thing. We have to start thinking like that rather than the big one, which takes years to come. And because it takes up so much land, there's so much of other issues involved. Yeah. So here, recoaling, wherever there's a coal. Thermal this thing, and we want to take out coal, put this one. And they go in fleet. They go in 4 or 5 small modules. That's how it is being.
This offline. Thank you.
Thank you so much, Dr. Ranade and Kathleen. I think it was a good session, and I would like to give the floor to my friend from DG Shipping. He's come all the way from Bombay. Mr. Praveen would like to take about 5-10 minutes before we break.
Okay. Oh, PPT already.
Yeah.
Good afternoon, sir. We have a direction from our DG. I am Praveen Kumar Roy. I am Engineer and Ship Surveyor with the Directorate General of Maritime Administration, Ministry of Port Shipping and Waterways. So I'll just quickly familiarize people with some of the key aspects what we are dealing with related to decarbonization, and URN is a part of that, and especially the role what we are playing at the IMO with relation to URN and IMO glow noise, glow litter, red plastic, and some other aspects related to the National Maritime Decarbonization Policy Framework, which DGMA has developed, which will lay the pathways for India towards the decarbonization and sustainability initiatives. Initiatives wherein India is engaged with the International Maritime Organization. The first is the glow litter, which is reducing sea-based marine plastic litter. We are actively a part of glow litter, wherein the various rules and regulations are being developed, which will regulate the kind of plastic waste being carried out on ships and what is discarded. The second is your Green Voyage 2050, advancing IMO greenhouse gas reduction strategies. In this, IMO has done a study with TNB, which is a classification society, on the bunker and pricing demand of alternate fuels in India. So the alternate fuels, which you all must be knowing, that apart from HSFO, high sulfur fuel, we call it in shipping, and diesel oil, methanol, e-methanol, biofuels. So these alternate fuels which are going to be the future of shipping. This IMO has done a study on the port readiness level, the infrastructure existing, or new infrastructures which have to be developed at the ports, which can cater to the fuel, and the ships demand whatever it will develop, which will come in eventually once the IMO net zero framework is in place. So that study is now ready, and it will be released officially by September, which we will share with the MRC team also, so that it can be communicated to the other stakeholders. And glow noise, of course, which is the reducing underwater radiated noise pollution, wherein we had a few, we are the lead pilot country which is carrying out few workshops and especially a environment risk assessment study, which I'll just show in the next slide. Yeah, so this is the glow noise partnership related to the URN part, wherein of course the circulars MEPC 1 Circ 906 is as of now it's not mandatory, it's voluntary, wherein various type of regulatory measures are addressing URN has been there, and we are discussing it how to go about that. MRC is one of our key members, and we are actually going to present a paper also, I think, at this session. So I will not go into much, but just we had a workshop on in April 2026 on the URN toolkit, wherein it's similar software which MRC has it. It's called Raindrop, and we had stakeholders from NIU and NIOT, wherein the training to use the software regarding the mapping of URN was given. So yeah, so this is a more detailed part. Yeah, this is that study. This is the study for India, which IMO is funding, which IIT Guwahati has been awarded to carry out this 4-month environmental risk and impact assessment of underwater URN. But we are struggling to get the data, which yesterday I highlighted that still I am on phone with DGLL because they need some special kind of permission to release the AIS data. So that part is there. Yeah, so this is, I just want to, for general stakeholders, that DGMA under the leadership of MOPSC, of course, we have developed a national maritime decarbonization policy framework wherein we have 8 pillars: green shipbuilding, green ports, green ship recycling, green finance, green fuels, alternate fuels, green technology, and pollution prevention, wherein various pathways and a roadmap to achieve the targets defined in maritime, the mother policies, Maritime Vision 2047 and Maritime Vision 2030 is laid out. It is still with the ministry as of today. The policy has been already developed with various stakeholders consultations. The ministry is now circulating this document between other ministries, MNRE, MOPNG, Ministry of Finance, Commerce, and other ministries. Once the feedback is received, then this particular document will be released Yeah, that's it, sir. Thank you.
Thank you, Mr. Praveen. I think this is a platform for dissemination of information to everybody. Thank you so much. We'll break for lunch and then we will resume the next session. Thank you so much.
Welcome back, everyone. We will resume the seminar with our session 7, Biofouling Management in the Maritime Industry, Challenges, Solutions, and Innovation. The main presenter is Mr. Sujit Mamidala, Research Fellow at MRC, and the session chair will be Dr. Varsha Kelkar Mane, Professor and Head, Department of Biotechnology, Deputy Director, Center for Excellence in Marine Studies, University of Mumbai. Director, apologies. Dr. Harsha Kalkar Mane is a professor and director at the Department of Biotechnology at the University of Mumbai at the Center of Excellence in Marine Studies. A distinguished academic and researcher, she is a fellow of the Royal Society of Chemistry and holds extensive expertise spanning environmental microbiology, bio-nanotechnology, bioprospecting, and diagnostics. Dr. Kelkar Mane has been at the forefront of several high-impact national and international research initiatives, notably prestigious project backed by the Ministry of Earth Science under India's Deep Ocean Mission, focusing on bioprospecting marine microalgae for the cosmeceutical and pharmaceutical industries. Her diverse research portfolio also features innovative work in archival preservation using advanced biotechnological interventions. With numerous publications in high-impact peer-reviewed journals and a proven track record of institutional leadership, Dr. Kelkar Mane continues to drive critical advancements at the intersection of biotechnology, marine sciences, and sustainable development. The main presenter for this session, Mr. Suchir Mamidala, is a research fellow at MRC and a graduate of IIT Madras with a bachelor's degree in chemical engineering, and also proposes research interests in computational modeling, maritime sustainability, and data-driven decision support systems. His work is mainly focused on the simulation of marine biofouling process, integrating engineering principles with computational techniques to address the ever-growing challenges of biofouling in the maritime sector. He is particularly interested in interdisciplinary research at the intersection of engineering, technology, policy, and economic development, and looks forward to engaging in meaningful academic discussions and collaborative research initiatives. I hope you have a wonderful session ahead. And I welcome Suchir, who will be joining us online, and we will after that have the session chair speak with us. So over to you, Suchir.
Thank you, Calistine. Good afternoon, everyone. Let us start the session. So I will be mainly presenting on the topic biofouling management, more focusing on the Indian Ocean region and the maritime industry, and we'll discuss on what are the key challenges, the solutions which exist, and the innovation and the way forward as well. So let us begin by asking the first basic question. So what is biofouling actually? So biofouling usually refers to the progressive accumulation of many biological organisms on a submerged or water exposed surfaces, and this usually occurs particularly in the marine and freshwater environments. And this process almost begins very instantly right after the surface is immersed, and usually evolves through many multiple stages. It starts with the adsorption of organic molecules, then it is followed by microbial colonization, and eventually leads to the attachment of many larger organisms such as algae, barnacles, mussels, and tubeworms, as shown in the picture below. So the major impact of biofouling is very significant in the maritime industry, and we will be focusing on major aspects such as the emissions increase, the invasive species vector, the port vulnerability, and the infrastructure degradation. So the accumulation of these biological organisms on the ship hulls increases the surface roughness, which disrupts the hydrodynamic flow around the vessel. So even thin layers of slime can increase the hydrodynamic drag by around 10 to 15%, while severe macrofouling can raise the resistance by 30 to 60%, which forces the ships to consume more power to maintain the operational speeds. This increase in resistance caused by the biofouling also directly translates into a higher fuel consumption. Moderately fouled vessels often experience fuel penalties of around 15 to 20%. And in some extreme cases, fuel usage can rise well over 40%. So, for larger commercial vessels operating continuously on international routes, these penalties amount to millions of dollars annually, in addition to the fuel costs. The increased fuel burn also leads to proportionally higher emissions of carbon dioxide and other pollutants, with biofouling related inefficiencies usually contributing to around 35% increase in the CO2 emissions per voyage. This poses a significant challenge for compliance with increasingly stricter IMO regulations, including the Energy Efficiency Existing Ship Index, which is the EEXI, and the Carbon Intensity Indicator, which is the CII. So, beyond these fuels and emissions, biofouling also negatively affects the vessel speed and schedule reliability. So, what happens is these foul ship hulls can suffer speed losses of up to 1 to 2 knots, which disrupts the shipping and voyage planning, the port schedules, and the charter party agreements. And to compensate for this, operators may usually increase a significant amount of their engine loads, further accelerating the fuel consumption and mechanical wear and tear. Biofouling also drives up the maintenance and life cycle costs. So the presence of fouling organisms usually accelerates the coating degradation, and it promotes what is called as MIC, which is the microbiological influence corrosion. So they create somewhat like a localized corrosive environment on the hull surface. So, and this results in more frequent hull cleaning, earlier coating failure, and increased dry docking requirements, which usually raises the maintenance cost by up to 40% over a shipping vessel's operating life. In addition to this technical and whatever economical impacts biofouling has, it also plays a major role in the spread of invasive species and aquatic life. Foul shippers usually act as very good vectors for transporting organisms across biogeographical regions, which means leading to a overall ecological disruption and the introduction of stringent biofouling management regulations in most of the several countries. And non-compliance to these can result in port delays, mandatory cleaning and checks, or usually a lot of financial penalties. Critical underwater components such as the propellers, rudders, sea chests, and thrusters are also very vulnerable to the biofouling process. Fouling on these propellers alone can reduce the propulsion efficiency by 8 to 10%, while fouled sea chests can restrict the cooling water intake, increasing the risk of engine overheating and unplanned downtime. These factors collectively elevate the operational risk and reduce overall vessel reliability. So, overall, to summarize, biofouling has a very significant impact and many hidden inefficiencies in the maritime industry and maritime sector. And its combined effects on the fuel efficiency, fuel consumption, emissions, maintenance, and the regulatory compliance impose usually tens of billions of dollars in the global economic losses each year. Particularly, it is more significant for the vessels operating in warm and tropical waters. Coming to the parameters which influence tropical biofouling, there are majorly four subcategories of this, which is the environmental parameters, hydrodynamic parameters, the surface and material parameters, and the biological parameters. So the environmental parameters usually include water temperature, nutrient concentration, salinity, dissolved oxygen, solar radiation, which and all these factors combined directly control the biological growth rate and species composition. And among these, the temperature and the nutrient concentration is one of the most influential and the primary dictating factor in the speed and the extent of the fouling development. Then we come to the hydrodynamic parameter, which includes the flow velocity, the turbulence intensity, and the residence time. And they also play a very critical role in determining the attachment and detachment behavior of the following organisms. Usually, low to moderate flow conditions encourage organism settlement, while turbulence influences nutrient transport to the falling layers and affects falling system and morphology as well. So the next one is the surface and material properties, which usually include the surface roughness, the wettability, surface energy, and the material type. So these in combination govern the initial adhesion part of the microorganisms and the stability of subsequent biofouling layers. The rougher and more high-end surfaces generally exhibit a much larger or greater falling intensity and susceptibility. And finally, coming to the last one, which is the biological parameters. They include usually the microbial growth rates, the larval availability and settlement cycles, the species interaction, and the competition among the different fouling species. So the interaction of these parameters usually results in a faster initiation and the uh, initial stage of the biofouling, also the sustained growth and increased severity of the fouling in the temperate and the tropical waters. So the next major important discussion is about the significance of biofouling and its comparison between the tropical and the temperate waters. So as we can see from the figures below, the intensity, the accumulation and the colonization rates in the tropical regions is much more severe as compared to the temperate waters. And the major reason for tropical fouling to dominate and be more intense compared to temperate waters, the major factor is the temperature. The severity usually lies in the temperature as a primary driver. This happens because the typical temperature range in the tropical region is usually around 25 to 30 degrees Celsius compared to the 5 to 20 degrees Celsius in the temperate waters. And what happens is at these elevated temperatures, the microbial metabolic and reproduction rates can increase drastically up to 2 to 3 times for every 10 degrees Celsius rise, and which significantly shortens the time required for fouling initiation. And what happens is, as a result, the initial biofilm layer formation in tropical waters can occur within a day or two of the surface immersion, whereas for a similar layer to be formed in the temperate water, it usually takes around 1 to 2 weeks. And this rapid biofilm formation accelerates the transition from the microfouling to macrofouling, enabling a very early settlement of algae and many larvae to settle on the submerged surface. The next major important part is the consistent conditions and the biodiversity available in the tropical fouling. So nutrient availability further intensifies the fouling dominance and also can increase the microbial biomass density, usually up to 3 to 4 times compared to the temperate water region, which in turn strengthens the biofilm stability and enhances the macrofouling settlement. Biodiversity in the tropical region also plays a very crucial role. So the tropical marine environments host up to 40 to 50% of higher species diversity of fouling organisms than the temperate regions. And this increases the larval availability and reduces the colonization delays, which allow multiple fouling species to attach simultaneously. Also, studies have shown that the microfouling coverage on the unprotected surfaces, usually in the tropical waters, can almost reach up to 90% surface coverage within a span of 3 to 4 months or 3 to 6 months. Whereas for a similar type of coverage in the temperate waters, this might usually take a year or 2 years. And tropical waters also support something called as a year-round biological activity because there is no seasonal interruption compared to the temperate waters. So what happens is in the temperate region, the region and the geography usually experience winter temperatures that reduce the fouling organism activity by around 50%. and this provides a natural fouling reset in the temperate waters. And the absence of such a temperature-driven die-off or a reset in the tropical region allows for the falling layers to persist continuously, leading to a thicker and more complex falling structures over time. From an operational standpoint, the impact is very substantial. So for ship hulls which usually operate in the tropical waters, biofouling can increase the hydrodynamic drag by up to 40%, which results in the fuel penalties of around 30 to 40% eventually. So to deal with the biofouling process in the shipping industry, usually we rely on a mix of anti-fouling technology and combination of many chemical, physical, and operational strategies to control this process. So the most widely used approach right now is the application of anti-fouling coatings on ship hulls and submerged structures. Traditional biocidal coatings typically were based on copper or zinc compounds, and they function by continuously releasing many toxic agents that inhibit the settlement and growth of fouling organisms. More advanced self-polishing copolymer, known as SPC coatings, also gradually erode during the vessel operation, exposing the fresh biocide layers and maintaining anti-fouling performance over time. In addition to these, there is something called as foul release coatings, which are based on silicon and fluoropolymers, and they are being increasingly researched and used currently. These coatings do not kill the organism directly, but instead reduce the adhesion and cohesion strength, allowing for the fouling organisms to be removed through hydrodynamic forces when vessels operate at sufficiently higher speeds. Alongside the mentioned anti-fouling coatings, there is something called as mechanical and operational methods. So this usually covers what is called as in-water hull cleaning, periodic dry docking, and optimizing the sailing speeds to manage the fouling accumulation from time to time. The last one is physical and the emerging technologies. These usually include ultrasonic systems and electrochemical systems, UV-based treatments, and air lubrication technologies, which are being explored currently. So while some of these approaches show a lot of promise, their adoption remains still limited and they're often used as a supplementary measure rather than a standalone solution. So overall, the current anti-fouling practices are usually they focus largely on preventive measures and preventive ways and maintenance oriented. And their primary aim is to slow down the fouling rather than eliminate it entirely. So despite the widespread use of whatever I mentioned on the existing anti-fouling methods, they face a lot of several critical limitations. And one of the most significant challenges is the environmental impact. Usually what happens is the biocidal coatings release a lot of toxic substances into the marine environment, which affects the non-target organisms as well, and this contributes to a long-term ecological damage in and around the surrounding. So this has already led to the global ban of highly effective compounds such as tributyl tin and the increasing regularity restrictions on copper-based biocidal coatings as well. Then there is something called as the performance limitations. They also persist. The effectiveness of the anti-fouling coatings degrades over time and is highly dependent on the operational conditions such as the vessel speed, the international route which is taken, and the idle duration. So foul release coatings, for example, are very ineffective for slow moving or stationary vessels, which are common in offshore and port-based operations. The mechanical operations like the in-water cleaning, while necessary, can also damage the coatings to an extent and promote faster regrowth of fouling if not carefully managed. From an economic and operational perspective, anti-fouling strategies are largely reactive rather than predictive in nature. So the maintenance schedules are typically based on usually fixed intervals rather than actual fouling severity, leading to either a premature intervention or excessive fouling before action is taken. This results in a lot of increased operational expenditure, sometimes unplanned downtime, and uncertainty in the performances and optimization. And furthermore, the current methods also lack adaptability across varying climatic and environmental conditions, particularly more often than not in the highly aggressive tropical waters. Given the ever-changing ecosystem and the climatic environment, there is a much growing need to simulate the whole biofouling process to better understand, predict, and also sort of manage the biofouling behavior to a large extent. Biofouling is, as I mentioned, a very dynamic and covers a lot of stages. It's like a multi-stage phenomena, and it's usually influenced by many factors which I've mentioned, such as the environmental factors, hydrodynamic, material, and biological parameters. So the simulation of the biofouling process enables the integration of all these factors to predict when fouling initiates, how it evolves over time, and how severely it can impact a particular vessel's performance over time. By simulating the fouling growth and its interaction with the fluid flow, so it becomes very much possible to create a time-dependent change in the hull roughness, the drag coefficient, the fuel consumption, and emissions. This allows the ship operators to move from a very reactive-based maintenance to a condition-based and predictive maintenance strategy. Also, simulation enables the virtual testing of these anti-fouling coatings as well, and the materials which we can use for creating different anti-fouling coatings under changing operating and environmental conditions, which also helps us to minimize the cost of trial and error approaches. And from the sustainability and regulatory standpoint as well, the biofouling simulation supports compliance with the IMO efficiency and decarbonization regulations. So by quantifying the performance penalties and associated with the fouling process and evaluating the mitigation strategies. So importantly, to say the simulation process reduces reliance on environmentally harmful biocidal solutions by enabling the development of a more optimized, route specific and an eco-friendly anti-fouling strategies. Regarding the simulation one, previous research has been explored the simulation of a biofouling process, but this has occurred usually primarily in the temperate marine regions, where fouling development is strongly influenced by seasonal variation. So a notable example was a research paper which I read on the time-dependent biofouling growth model developed and conducted at the University of Strathclyde in the United Kingdom. So this study utilized the operational data from commercial shipping vessels, which were operating mainly in the temperate North Atlantic routes, with falling growth rates reflecting the seasonal characteristics of mid-latitude waters. And the model which they used represents biofouling as a time-evolving process, converting the fouling accumulation into equivalent surface roughness parameter to predict the increase in the ship resistance and the power demand needed for the particular vessel. However, the key part was the environmental conditions which were considered in this work are largely representative of the temperate and the subtropical region, whereas falling growth slows significantly because there is a offset and cooling period in the temperate region. So as a result, while such models demonstrate the feasibility of simulating the falling and the evolution of the falling process, they're not very directly transferable to the tropical region where the temperatures are usually very high and feasible and there is uninterrupted biological activity. So currently at MRC, we are trying to develop a 5-stage biofouling simulation framework. What we have done, we have understood that biofouling process is not just a very instantaneous event, and it comprises of many multiple stages, which are governed by the interaction of many of the surface chemistry and biological reactions, fluid flow, and biological activity. So many existing approaches simplify fouling by representing it just as a function of fixed roughness or resistance term, which limits the ability to predict how fouling evolves over time. and under different varying environmental conditions. So at MRC, our current work focuses on addressing this particular gap and by systematically trying to simulate the entire biofouling process in a much more detailed, staged and physics-based manner. So to achieve this, what we have done is we have split the entire fouling process into 5 different stages. And all these are sequential yet interconnected to one another. So the stages are the first stage is the condition. The first stage is the conditioning film formation. The second one is the biofilm initiation. Then we have the biofilm maturation, the microfouling development, and the macrofouling establishment. So each stage, what it does is modifies the surface properties and surface chemistry and the hydrodynamic environment, thereby directly influencing the progression into the next stage. This decomposition allows us to introduce complexity at each particular stage gradually and helps us to validate individual processes as well. So this is a representation of how we have decomposed the 5 stages. So first we have the film formation, then the bacterial and diatoms addition, then the further development of the biofilm. Then we go on to the micro and macrofouling. So the first stage is the conditioning film formation, which occurs almost immediately after a surface is submerged in seawater. So usually organic molecules such as proteins, lipids, and most of the polysaccharides submerged on present in the seawater are rapidly absorbed onto the bare substrate within seconds to minutes. And although this stage does not involve any living organism, it plays a very critical role by chemically and physically modifying the entire surface properties. So the conditioning film changes surface energy, the wettability and charge of the surface, creating a much favorable foundation for the microbial attachment and effectively preparing the surface for subsequent biological colonization. Then we have the second stage, which comprises of biofilm initiation, where the free swimming bacteria approach the conditioned surface. So bacterial transport toward the surface is governed by the hydrodynamic forces and chemostatic responses to nutrient gradients. And upon contact, these bacteria secrete adhesive proteins that allow a sort of irreversible attachment, and this is followed by a secretion of something called as EPS, which is the extracellular polymeric substances, which form the initial biofilm matrix. And at this stage, the surface transitions from a chemically conditioned layer to a more biologically active interface. And as the bacteria population grows over time, the process enter the stage called as the biofilm maturation stage. And bacterial cells multiply and organize into a multi-layered and a spatial heterogeneous structure. And nutrient and oxygen gradients develop across this biofilm thickness, with oxygen concentrations decreasing towards the interior part. And this leads to very something called as a metabolic specialization, where the interior bacteria shift towards it's called as an anaerobic metabolic pathway. And the EPS matrix, which was secreted before, becomes much more denser, providing a much more mechanical stability and protection against hydrodynamic shear stress, chemical exposure, and antimicrobial agents. The fourth stage is the microfouling development stage, and it is characterized by the settlement of microorganisms such as diatoms, microalgae into a more mature biofilm. So these photosynthetic organisms exploit the biofilm's nutrient-rich and adhesive environment. And as the microfouling progresses, the species composition evolves in response to the environmental conditions such as light, the temperature, and nutritional availability. And this stage significantly increases surface roughness and creates a sticky textured surface that enhances the likelihood of larger microbial and microorganism attachment. Then the final stage is the macrofouling establishment, where the larger organisms such as barnacles, bryozoans, mussels settle and grow on the fouled surface. So what happens is the larva detect the biochemical clues emitted by the biofilm and the microfouling layers, which trigger the subsequent settlement of these larger organisms. Mussels usually anchor themselves using their basal threads, while barnacles and bryozoans permanently cement to the surface structure. And in tropical environments, this stage can progress extremely rapidly, with hundreds of bryozoans and thousands of barnacles usually establishing within just 2 weeks. And over time, these organisms form a complex and interactive sort of following ecosystem, which is highly resistant to the removal and has a very severe hydrodynamic and operational consequences. So the simulation process, let's discuss about the progressiveness, complexity, and the integration strategy. So the initial plan is to begin the entire simulation with a very sort of simplified physics equations at stage 1, which will enable the validation against the experimental data. Then we will use each subsequent stage and their output parameters from the previous stages as an inputs. So because of that, we can increase the complexity gradually. We can go from smooth to rough fall conditions. We can go from a uniform to a very spatial varying falling distributions. We can go from a deterministic predetermined model to a more probabilistic biological behavior. And the modular structure too allows a very independent validation of each stage, easier incorporation of new biological or environmental parameters, and adaptation to different regions such as the temperate, subtropical, and the tropical regions. So this is a depiction of the stage to stage integration and feedback loops of the subsequent biofouling process, how we go from stage 1 to stage 3 to stage 2 to stage 2 and 3 to stage 4, then subsequently to the stage 5. So what happens is from stage 1 to stage 2 coupling, we usually have the conditioning film properties determine the bacterial attachment probability. As we go from the stage 2 to stage 3, the initial biofilm characteristics affect maturation rate and final density. Then as we move to the stage 4, the mature biofilm matrix provides a much more better substrate for the diatom colonization. And at last, when we go to the final stage, which is the macrofouling stage, the microfouling derived settlement clues trigger the macrofouling species such as the barnacles, bryozoans, or the mussels for further. So before we look at the equations which were used for the simulation process, we need to account for something called as the major important part, which is the Q10 thermal scaling, which usually focuses on how we account for the temperature. So biological reaction rates are very temperature dependent, and the model which we are using uses a Q10 coefficient as a relationship to adjust the biological rates according to the surrounding water temperature. So in this equation, the rate T, which is the biological rate at the current temperature, while rate at the reference temperature, T reference, represents the baseline rate. And the Q10 describes the sensitivity of the biological process to a 10-degree change in temperature. The important point is that the temperature correction does not create a separate fouling stage. Instead, it modifies the rates at which the biological process will occur. So this is particularly important in the tropical waters because warmer conditions can accelerate the biofouling growth and therefore accelerate the overall biofouling process depending on the region. So let's discuss the equations in much more detail. So for stage 1, which is the conditioning film, the first stage uses the equation as follow. So what happens is when a clean hull is immersed in the seawater, organic molecules begin to adsorb onto the surface. So the first sum, which is the KACB tau max minus tau, it represents the adsorption term, and the term tau max minus tau is important because this represents the remaining available surface. So initially, almost the entire surface is available, so adsorption can occur very rapidly. As the surface becomes increasingly covered, the available surface decreases over time and adsorption slows down. The second term, which is minus kd tau, it represents the desorption term, meaning that some of the molecules which were already attached to the surface leave subsequently over time. So therefore, the equation essentially represents a competition between the molecules arriving at the surface and molecules leaving the surface. And eventually the system approaches an equilibrium standpoint where the conditioning film becomes relatively stable. Then once the conditioning film is completely formed or is stable, then the bacteria start to attach to the surface. So the first part of this equation represents the bacterial attachment. It depends on the bacterial availability in the surrounding and on the presence of the conditioning film. The most important part of this equation from a maritime perspective is the exponential term, which is given by e power minus tau w by tau c. So this represents the effect of something called as wall shear stress. As wall shear stress increases over time, this exponential term decreases. Therefore, the bacterial attachment becomes less favorable under very high shear conditions. And in practical terms, a vessel traveling at a relatively higher speed can experience stronger hydrodynamic shear stress near the hull surface, which can make the initial attachment more difficult. Then we have the second term, which represents the detachment of bacteria that have been already attached. So overall, the complete equation balances the bacterial attachment against the bacterial removal rate. Then for the third stage, which is the biofilm maturation, what happens is at this point, bacteria is no longer simply attaching to the hull. They become developing into a much structured biofilm with extra EPS helping the community remain much more attached to the hull surface. So the first term of represents the contribution of the attached bacterial population to the formation of the biofilm, and the next major part is the monod kinetics, which is given by S by Ks plus S, and this majorly represents the nutritional limitation. What happens is when nutrient concentration is extremely low, the growth rate is strongly limited, and as a result, the nutrient concentration increases, the growth rate approaches to its maximum potential. Then we also have the logistic growth term, and which is given by 1 minus x by x max. So this prevents the unlimited growth of the biofouling stage. As the biofilm approaches its maximum capacity and capability, the growth slows down gradually. And finally, we have the Q10 factor, which incorporates the temperature dependence, while the final term represents a biofilm loss. So this complete equation captures what is the major idea that the biofilm growth depends on, which is the bacteria, the nutrients, the temperature, and available surface capacity. So the fourth stage is the microfouling stage. So to sum up this equation, it's nothing but nutrients plus the availability of sunlight plus temperature plus the carrying capacity and minus the loss. So the fourth stage usually represents the microfouling, particularly the colonization of much larger algae and diatoms. This stage is different from the bacterial growth because the photosynthetic organisms such as the algae and the diatoms require both nutrients and sunlight. And this is represented by the minimum function, which is given here. Minimum of the concentration by Kn plus concentration, and the I represents the intensity and Ki is the half saturation parameter of light. So this function implements the idea that the growth is limited by whichever resource is available and is more restrictive. So for example, if let's say nutrition is available in high amount, but light availability is extremely low, then the algal growth is still limited because one of the parameters which are necessary for the growth is not in the required quantity. Conversely, also, if let's say the sunlight is abundant and there is insufficient nutrients, then that also can restrict the growth. And this equation also again includes the Q10 temperature scaling, which is the main carrying capacity term. And also we have a loss term which is given by KSAM. So therefore, this stage connects the biological model to environmental variables such as nutrient concentration and solar irradiance. So the final stage represents macrofouling such as barnacle settlement, bryozoan settlement, and mussel settlement. The important biological assumption here is that macrofouling is much more dependent on previous biofilm stages. And this is represented by the following equation, exponential term 1 minus e power minus x by x reference. So what it does is as the biofilm biomass increases, this term increases, meaning that a mature biofilm creates a more favorable sort of environment for the macrofouling settlement. At the same time, the second exponential term, which is the e power minus tau w by tau c, it accounts for the hydrodynamic shear stress. High wall shear gradually makes settlement more difficult. Finally, the last term, which is negative of mu dn, represents the mortality or loss of the macrofouling organisms. Therefore, the final stage effectively converts the earlier biological development into a much large-scale fouling that has direct engineering consequences to the ship operations. So the problem which we faced while simulating the entire biofouling process is that solving this entire complete system repeatedly is very computationally expensive. If we incorporate using something called as computational fluid dynamics model, it will take a lot of time and it will be extremely expensive, because each simulation will require solving multiple coupled differential equations which span over a large period of time. And instead of doing this every time, we wanted to have a prediction which uses the physics model to generate a large synthetic data. So what we have done is we generated an 80,000 scenario data set using Latin hypercube sampling. So the advantage of using Latin hypercube sampling, also called as LHS, is that it provides a very broad coverage of the parameter space rather than randomly concentrating simulations in only a very small region. So the resulting simulations become the trading data set for multi-output random forest. So random forest is the machine learning model which we have used that learns the relationship between the environmental and biological inputs and the resulting fouling outputs. Once trained, the random forest can produce predictions in less than a millisecond, making it a much more suitable for a large scale or a real-time application of the fouling process. So coming to the results, one of the interesting factors to note is using the validation. In the validation one is that the R square value is not equally high at every stage of the simulation. As we notice here in the microfouling coverage percentage at around day 5 and days to 50% microfouling. So the R square value is relatively around 0.39 and 0.36, and the validation status reports as a fail. But this doesn't directly imply that the model is not working accurately. So what happens is at the early time points, usually around the day 3 or day 5, many of the simulations have already reached a very similar biological state. So what happens is this creates something called as a variance collapse. So I guess let me just give you an example. So let us imagine we have let's say around 80,000 simulations or around 50,000 simulations. But almost all of them produce approximately the same microfouling value. Then what happens is we are accounting for a case that is which has very little variation for the machine learning model to explain. So this can make the R square value appear relatively low even when the absolute prediction errors are very small. Therefore, what happens is for the lower early stage R square, therefore what we do is for the lower early stage R square values, we do not automatically interpret it as a failure of the random forest surrogate model. The most important result to look at is that the validation results which are obtained in the long term or the long run endpoint are pretty much accurate. For a drag increase, the random forest achieves an R square of approximately 0.9973. And for a macrofouler density, the reported R square is approximately close to 1. So this means that the surrogate is reproducing the long-term outputs of the physics-based model with extremely high agreement. And from an engineering perspective, these endpoint predictions are particularly important because the drag increase and macrofouling are the quantities that ultimately determine the operational impact of the fouling. So therefore, the results which are demonstrated that the computationally expensive ordinary differential equation model can be approximated very accurately by a much faster machine learning surrogate model. Currently, we have also been looking at a wide range of research topics to understand the biofouling process in detail and also to account for the increasing complexity from present in different biological and biogeographical regions. So the first topic which we are majorly looking at is how monsoons drive the marine biofouling in the Indian coastal region. So this project usually focuses on understanding the influence of the Indian monsoon on the marine biofouling in the coastal waters. And the study explains how seasonal changes caused by monsoon, including the variations in the salinity, temperature, turbidity, nutrient levels, dissolved oxygen, and rainfall impact the growth and success of the biofouling communities. So the ultimate goal of this research topic is to develop a sort of conceptual framework that can support a future predictive model for forecasting biofouling intensity, enabling better maintenance planning and more sustainable biofouling management. Then the next one, which focuses on the parameter sensitivity analysis of the simulation framework. So this project, what it does is it applies a global Sobal-Saltelli sensitivity analysis framework to evaluate how variations in different environmental parameters, including temperature, salinity, oxygen, and nutritional content, affect the model prediction. So in addition, a local one at a time sensitivity analysis is also being performed on the biological rate constant within each stage, which is used for the simulation of the biofouling process. Then the last and important topic is the biofilm maturation and the recruitment dynamics. So this project examines what is the relationship between the biofilm maturation and the recruitment of the macrofouling organisms in the tropical marine environments with a much deeper focus on the Indian Ocean region. Biofilms are usually very complex microbial communities and which form on the submerged surfaces, and they play a very critical role in determining whether the larger fouling organism, which is the macrofouling stage, such as the barnacles and mussels, successfully settle and establish. Although the biofilm age is often usually used as an indicator of maturity, what we notice that recent research suggests that the additional factors, including the extracellular polymeric substance, the production, the microbial diversity, the community composition, and quorum sensing activity may also have a very significant influence on the larval settlement and the recruitment success. That is it for the important topics which we're currently trying to discuss on how we can subsequently increase the complexity and create a much realistic simulation of the biofouling process. So moving forward, our main aim is to increase the fouling complexity by researching and incorporating different biological equations. Further, we want to develop a fully coupled multi-stage biofouling simulation model for the major ports in the Indian Ocean region. Then we also want to apply and calibrate the model for the Indian coastal regions according for the varying tropical environmental conditions, including the seasonal changes and monsoon rains. And at last, we want to enable the prediction of a time-dependent falling growth, drag penalties, hydrodynamic drag, and operational impacts using the surrogate model. Thank you, everyone.
Thank you, Sushil, for that presentation. To see the entire process of biofouling, I think just reminds us of how we can build ships as big as this building. But then what slows it down by 40% begins as a microbial small algae. And we kind of tend to glaze over that. So I think the sort of the way we how do we think about these techniques and processes and going over these issues, I think is something that needs to be paid more attention. Sushil magnificently covered the very complicated layers that remains to be seen. I would like to now invite Professor Varsha. Okay, any questions from the crowd? Yes, ma'am. Sushil, there's a question. Just confirm if you can hear the mic. Okay.
Yeah, I can hear the mic.
Wait, no, the second mic.
Hello, am I available? Sir, can you hear me?
Hi, yes, ma'am.
Yeah. Sir, I'm a chemical engineer myself. So your presentation is so informative. Thank you so much for that. I have
Thank you,
one
ma'am.
question. Yeah. Can you please elaborate on any kind of case studies where biofouling has impacted the maybe a shape or a boat or something? Can you elaborate on that?
Ma'am, could you once repeat the question? I missed the last part. Biofouling has impacted the
any ship or boat or any kind of case studies where you've come across impact of biofouling. I just want to.
Sure, you can talk of me, Mishra's work. And that could be a good case study to elaborate.
So ma'am, what we had done is we recently did a case study survey on the JNPT port to understand and create a sort of economic framework and a biological framework on how the whole fouling process affects the ship. So in that, more specifically, what we notice is it doesn't directly affect the shape of the ship. Like what it does majorly is that the entire fouling process makes sure that the metal on which it is being attached gets corroded. So it doesn't at first there's no visible changes or signs in the entire shape of the ship, but what it does is there is an increase in the weight of the ship that directly impacts the operational function of the ship or the vessel which is used for the trade systems. So as such, there is no direct impact on the shape of the ship, but the structure and the metal which is used to create the ship gets affected. So which in turn increases the corrosion part or the mechanical wear and tear of the components or the machinery used inside the ship, and also because of the increased in weight because of the attachment of the biofouling organisms that directly affects more on the fuel consumption or the operational speed.
Okay, so the structural strength will be affected, right? As you said, biofouling leading to corrosion. So corrosion will definitely impact the strength of the mechanical structure.
Yes. So what I wanted to clarify was there is no visible change in the shape, like whatever outline of the ship is there, like the shape of the ship, that is not affected very drastically. Like there is no visible change. Like if you go and look at a ship directly, there is not very visible change in the shape of the ship, but the material which is being used to create the ship, that is being affected. So the properties on the surface level get affected, which is very invisible to the naked eye.
But if not, it may lead to damage of the parts of the ship or something. This need to be taken care of, right? Sir, am I audible?
Yes, ma'am. Could you repeat, ma'am?
Yeah, I said if this has been ignored, then it leads
Yeah.
to the damage of the mechanical parts and physical damage may happen, which may lead to cracks or
Certainly.
entire, yes.
So, I mean, ma'am, what he's trying to say is that, yeah, as it progresses, if you don't continue to do the regular maintenance,
Yes.
which is, in case of a ship, it is expensive. Corrosion will, I mean, if it is not contained at the right time, definitely lead to, I mean, your maintenance costs will go up significantly. And obviously it will, so, I mean, as he said, first thing is, the fuel consumption, I mean, the weight of the ship gets impacted. I mean, it increases by about 30%. Then it obviously leads to carbon footprint also goes up. Fuel consumption goes up as such. And then obviously there is corrosion, which you mentioned. And the corrosion, if not taken care, will definitely deteriorate the hull the structure. And not the structure as such, but the hull outside. And the material, I mean, if it deteriorates further, then there can be more issues.
Yes.
Good afternoon, am I audible?
Yes, sir.
Okay, so my question is, what facilities are available in India for removing the barnacles and other biofouling substances? And what percentage of the shipping industry costs are spent on biofouling?
Sir, I just lost. Could you once repeat the question?
Okay, my question is, what facilities are available in India for removing barnacles and other biofouling substances?
Okay.
I also want to know what percentage of the shipping industry costs are spent on biofouling.
Yes, sir. So coming to the part regarding the biofouling removal facility. So let me just go about in general first, then I'll come to India. So what happens is, in general, the biofouling techniques, anti-fouling techniques, which are majorly used, cover three things. One is the mechanical operations, one is the use of anti-fouling coatings, and the other one is the emerging technologies using ultrasonic or UV based systems. So in India specifically, we usually follow the same methodology of using anti-fouling coatings on different shippers, then in compliance with the IMO regulations as well. And coming to the percentage of budget, sir, do you want me to mention the budget which is spent on these anti-fouling coatings or the operation maintenance, or how do we treat the biofouling process, like the cleaning budget?
You can mention some numbers to give him a sense because he wants to understand, you know, what is the.
Okay. So sir, I think if we look at the overall budget which is used in the shipping industry, majorly in the biofouling. So one we can categorize into the anti-fouling coatings and paints which are used, and the other one which we can categorize is into the mechanical thing, like the mechanical operations. So what I can say is approximately the underwater hull cleaning usually operates around, let's say, it usually operates from, based on the ship vessel and the ship hull, it usually operates around roughly from $5,000 to $50,000 based on the type of ship which is used, the vessel size, the amount of fouling which has occurred, and also what is the fouling intensity which has become. So if you look at a standpoint of how much India, the shipping budget use, it accounts for around 40 to 60%.
Thank you so much.
Thank you, sir.
Hello, I'm audible.
Yes, sir.
So regarding the anti-fouling methods, I just lost track on performance and durability limitations. Could you just kindly explain a bit about it?
Should I share my screen, sir? I think I'll share my screen once. Yeah. So is it this one, the performance and durability limitations?
Yeah.
Make it full screen.
Okay, sir, one second. So, what I was trying to imply is because of the changing environmental and climatic conditions and the type of coatings which we are used, so the performance and durability limitations of the anti-fouling methods changes. Like what I mentioned is the effectiveness of the coating degrades over time and it varies a lot with the operating conditions, and most of the time whatever value which we assume, like let's say suppose we apply a coating to a new vessel and we have an written statement that this will last for this particular operation for so and so X number of months, let's say 2 months or 3 months. But because of the changing environmental conditions and climatic changes and the type of routes which we are using, we are unable to predict the effectiveness of the coating. And also what happens is the foul release coatings require very high vessel speeds to be effective, and when we account for high vessel speeds, then again we are indirectly using a lot of fuel to eliminate the biofouling thing. And when we do the mechanical part, which is the in-water hull cleaning, that also damages the coatings which are already existing or applied, and this can also increase the risk for long-term fouling. So what I think to sum up is that coming to the performance part, whatever anti-fouling techniques or methods which we are using, and if we have a set boundary that for this particular route that this anti-fouling coating will work for this amount of time, that more often than not for 90% of the cases it doesn't work. Like let's say suppose a ship has been cleaned today and then its due date for next shipping cycle for the cleaning cycle based on the particular route which it follows is maybe around 4 months or 6 months based on the type of vessel which we are using or based on the type of international or the national route which is taking. But the problem is because there is so much variation going on in the climatic changes and the environmental changes, that what is happening is whatever we are thinking that okay, so after 6 months we will be easily able to uh, uh, clean or dry dock the ship, that is not happening. There is sometimes you may notice just after 3 months the micro fouling and the macro fouling stages is completed very rapidly. Then you have to dry dock the ship immediately, or else then it may lead to further damage to the ship or further more operational costs. So because of that, because of this, what is happening is the whole ship planning or the voyage planning is being disrupted. So that is what I meant, because the existing anti-fouling coatings aren't being very efficient because they're still hampering the voyage planning or the ship operational planning or the facility, because what we are assuming the particular methodology to work in a certain way, it isn't happening because of the ever-changing environment.
Thank you.
Sir, is it clear?
Yeah, that's fine.
Thank you, sir.
Actually, very good. It reminded me of my younger days when I was in the dockyard trying to get the hull cleaned, right? Okay, when you did your first biofuel forms, you said it adheres to the bare substrate. What is the bare substrate?
Yes, sir.
What is the bare substrate?
Okay, so let me just show the image, sir. I think it will be clear.
No, my question is it after the anti-fouling has been put?
Sir? Okay,
No,
so yes,
I
yes.
understand bare substrate is with no paint, nothing. Is that a correct assumption? Okay.
So, sir, let me just complete it. So the explanation of the fouling process was taken what I meant was with bare substrate is just the shipping structure without the anti-fouling coating, because then it is much more easier for the proteins, lipids and polysaccharides to attach to the surface. Yes.
So, first of all, I mean, since whatever you've done as a chemistry student or chemistry professor, you've done very well. I have understood now why I had all the problems. So you achieved your objective of convincing me how these things are formed. So just for your information, if there were a couple of questions, does it rust and things like that. So I would like to just say that the anti-fouling paints that have come into the market are very, very good over the years. I can only tell you from the Navy's point of view, because we buy these paints. Earlier, we used to make the paints and we found that within 2-3 years, you got to come back to the dry dock. Now we don't dock for 5 to 6 years, right? That is the thing. For a merchant ship, because it doesn't go fast, it goes at a steady pace, etc. In fact, I'm using the anti-fouling paint, which was with good ship owners use, because they don't want to don't want to get spend extra money in docking and things like that. So if it is a bare substrate, then it will not form unless the anti-fouling paint leaches, as you rightly said. Over time it leaches and becomes thinner and thinner, and then yes, at one day, that's why there's a life to that. Unless there is damage to the paint, because all these tubes have got that bulbous ball in the front. So when they come in, they scratch somewhere. So that's where it stops. Because once you have paint, anywhere, if there is a thing, then it is as good as having no paint anywhere, because the whole thing starts, coming off because of the barnacles. So the first thing is, yes, barnacles cause corrosion, cause everything fine, but not the time frame which you are talking of, would be when the anti-fouling paint is put, which all ships in dry dock, they do that, and more so the merchant ships, because they know the value of, they lose money, they can't afford to lose it in one day, so they do it. So for your study, what I would recommend, can you, go to any of the JNPT or anything, get a practical this thing for a ship which after anti-fouling went through these things, then we will be more, thing. My this thing is to put a real case, to get a real case situation. Yours definitely works in the theoretical format, provided there is no anti-fouling paint. Suppose anti-fouling paint is on, what is the time frame they are getting between voyages or whatever it is? That is one. Second is, as far as the cleaning is concerned, the cleaning. You know the cleaning in dry dock. So the first type of cleaning is, I think you brought out somewhere, use a heavy jet, water jet to clean the thing. And then also you use something like an ultrasound cleaning, so that you don't damage the rest of the paint. Okay. So because the barnacles are under the waterline. Above is more or less hardly anything. But that place, when you do and you use anything, mechanical tools, there's a possibility of damaging the other paint also. So you use ultrasound thing for cleaning. They use small metal balls to this thing, and then the paint is scraped off. So that way the barnacles, etc., are clean. Good old days, you used to scrape it with thing and damage thing, but today you got many more. Lately, even in the Navy, we started using robos, so that you have a robo which goes up and down, and since it's a steady, with a steady pressure, steady this thing, etc. So there are many methods of cleaning the underwater surface. Whoever asked the question, I just want to tell you, and all of them are being used in India, because robots for ship cleaning, underwater ship cleaning, are being made in the country. So there is no problem on that. It's a very simple thing, anybody can make it. So I just wanted to add to whatever your
yes, sir.
The other thing is, barnacles adding weight to a merchant ship. A merchant ship carries so much weight. So these barnacles will not add weight. What they will definitely add is drag. Because more the barnacles, more the drag, less the speed. He has to make up for the speed, and therefore this thing. weight, will not be much compared to the weight that they actually carry. So they're all so heavy ships. It's not like a small boat that this will make a difference. So that is the other thing. This is my observation as a practical, ship repair person. I don't know if I could be wrong. This is what I normally do. Okay.
Thank you. No, completely align with you, your point, sir. And just wanted to, we also involved some of our constructor officers in this discussion, and but definitely what you said aligns with what they have been saying. So the model is going to be deployed and then fine-tuned based on the real. And so the model validation is going to be extremely important part, sir. But having a model will be very important to benchmark.
There's no doubt. You have gone through the whole physics, chemistry, now you know, and then you have a model.
Absolutely.
Right, but try the model out.
Correct.
How the actual try the model out and how the actual ship goes to sea, which means after anti-fouling, after this, that, etc. Don't use bare metal and all and then say, no, yes, certainly. Well, anti-fouling is the most important thing is to prevent the first film forming. That's why you put the anti-fouling. Yeah.
I think its equation also addresses that, but that those numbers have to be rightly put.
I only thing is he said bare metal.
No, yes, no, fully agree with what you said. Okay, I think we had a good session, and now the most important part, we would turn to Varsha ma'am for her comments. Varsha ma'am, you may also probably answer some of the questions that were raised or put your views on that, and obviously you have been working on biofouling and modeling for a very long time. So, ma'am, over to you, please.
Thank you so much, Dr. Das, and a very good afternoon to all of you. Suchir, the presentation was very nice and crisp, and I think you covered right from the biology of fouling to the use of AI ML in containing the biofouling process. Now, the way that I have been working on biofouling is quite different. Let me put it in the context. I'm a biochemist by training, so the way I look at biofouling is the mechanism by which biofouling actually occurs. In order to understand, I think Suchir has already told us the way in which biofouling occurs. But I will just put it into 3-4 steps. One is the conditioning of the film, that is whatever the surface is existent. So it is kind of conditioned so that a biofilm is formed. Then you have a bacterial biofilm which is formed and established due to the production of extracellular polysaccharides. Then you have microfouling, and then you have what is called as macrofouling. Now, whenever we are talking, or from a biotechnologist perspective, whenever you are talking about biofouling, I can categorize it into soft fouling, hard fouling. I can also categorize it into temporal or seasonal fouling or persistent fouling. So it is essential for us to understand when we have to address the problem. It is essential for us to understand the conditions in which this biofouling is actually taking place. And for that, we need to understand the physiology of the ocean or the water body in which the ship or the surface has been immersed and the duration for which it has been immersed. Now, if I have to talk about the physicochemical characteristics of the water body, of course, as Suchir also mentioned, you have temperature, salinity, nutrients, presence of eutrophication, the light, the depth, the current velocity, water motion, DO, pH. All of these parameters play a very crucial role in the type of biofilm that is formed, and we need to understand that and then try to find out a solution. What has been happening is, when we are talking about containing biofouling, anti-fouling is probably one of the most used strategies for taking care of fouling. There are experts in the audience and they can correct me if I'm wrong. But as far as my reading goes, anti-fouling agents have had the largest share of the market for your taking care of biofouling. Now, if I have to understand, let me throw a little bit light on the biochemistry of fouling. And for the sake of convenience of this August gathering, let me just correlate it that these are nothing but just biological molecules. Example is that of proteins, which are allowing the organisms to stick onto the surface. And these are amino acids which all of us are aware of. And if I have to give you a context, these are similar to amyloid plaques. Now, all of us know of Alzheimer's, the disease which is, causing an havoc. And in that case also you have amyloid plaque formation, in which these proteins agglomerate together to form such stiff structures that it is difficult to take care or destroy these structures. And similar structures are formed when you're in the biochemistry of fouling. Now, you have also different adhesive proteins also, and they have some amino acids which are in common, and one of them is DOPA. Now, we must have heard of DOPA. It is a neurotransmitter also. So there is a similarity between what is happening and what we are trying to eradicate and what we are actually trying to study. So besides this, I think this fouling organisms is once again a three-dimensional habitat that we need to take care of. Are there any advantages of biofouling? And people in the audience may react to this, but there are definitely advantages of biofouling. I'm not talking from obviously the economics, but from the science perspective. Remember that they are creating a habitat and increasing local biodiversity. Please don't connect it to the drag on the ships and the increase in fuel burden when I'm making this statement. It is purely from a scientific perspective as to what are the different ways in which we can look at biofouling. So there are various algae, sponges, mussels, barnacles, and these structures, they provide shelter, attachment surfaces, and feeding areas for smaller organisms. So if you're looking at the biodiversity in a particular area which has immense biofouling, you will find higher biodiversity as compared to the rest of the areas. They also support food webs, which is also crucial for sustainability in an ocean. They also enable water filtration because they are used. So filter feeding organisms, you have filter feeding organisms like mussels, you have oysters, you have sponges, which kind of remove suspended particles, planktons, and organic matter from water, and that is how they can act in clearing or improvising the local water body quality, water quality of the local water body, and water quality regulation also. Biofouling, or the organisms that are involved in biofouling, they contribute immensely to nutrient and carbon cycling, and this is also something that we need to take care of. They can serve as indicators of bioindicators, as we call them, or you can call them ecosystem engineers, so that we understand the physicochemical characteristics, the change in the physicochemical characteristics that is happening in the local environment, and we need to understand that if we have to contain biofouling. So instead of using, or of course the need for anti-fouling agents is must, but it is essential to see the way in which we can control the physicochemical parameters of the water body, so that the first adhesion or the first colonization of the microorganisms or the microscopic organisms or the organic molecules on the surface is reduced. Another way of looking at it is, for once again from a biotechnologist perspective, is these are potential areas of finding bioactive molecules, since when we are talking about adhesion, for adhesion onto a surface in water, it's just, so if I have to give an example to my students, it is like sticking two rulers or two scales inside water using Fevicol. We cannot. But the barnacles, the mussels are effectively enabling it with the use of organic glues or organic gums, and these find immense application in surgical processes. These are being explored in various surgical processes because in physiology you have similar surfaces, and that is where, from once again our perspective, we are looking at agents of fouling. Now, as Suchir also mentioned, there are various preventive and design based measures to take care of biofouling, and I think he has covered quite in details. And you have physical mechanical control, you have anti-fouling agents, you have design of biomimetic surfaces, And this is also where we are working on, and where you have the lotus leaf or super hydrophobic surfaces, which will not allow the organic molecules to colonize, which will probably decrease the water contact angle. You can have micro or nanostructured patterns. You can have mucus-like hydrated polymer layers, which will not allow the first colonization to take place. Besides that, all of us are aware that there are copper and copper-based agents that have been used for anti-fouling. I believe that the most effective approach is an integrated one, and that involves, I think, the smooth design, use of appropriate coating, the need for regular inspection, controlled cleaning, safe disposal, and regulatory compliances. Whenever we are talking about the use of anti-fouling agents or scraping it physically also, remember all of that is getting dislodged in the water body, which is in which the ship or the surface is housed. So they are going to come back probably, and they are going to cause biofouling once again. So a holistic approach is required, which will take care of the environment also, as well as prevent biofouling onto the surfaces that we desire. So I think that is it from my end, and if there are any questions, I will be happy to answer, or any discussion point that if the audience would like to make, I'll be happy to hear.
Anybody have any questions?
Yeah, please. I think I was very surprised, ma'am, by your explanation, because from Suchin, we got anti-fouling method, shipping industry, the concerns of the shipping industry, how do we do the coating methods, and from you, we got a more molecular biotechnological perspective of the biodiversity that's created in these spaces, the molecule, what can be learned from these. And I was just thinking, it's not a question or a comment, but it's just like of this entire thing, like it's also a type of globalization. Like we have sent ships across the world and we are connected our countries, but we don't realize that the bottom of those ships are also emerging through the waters. And as you said, it's going through different ecosystems, it's creating new biodiversities. It's like they're creating entire new metropolis cities for underwater creatures to create new, and we don't know the effects. We don't know what happens when one creature and one species of organism goes to the other. And since your interest was also in these molecules that are created, these and there's so much more we can learn, which was something interesting. If our focus is only on, okay, this is a problem that reduces traction and we have to find the best way to stop it. And if it only reaches there, then you're not looking at the larger systems of what we've created. Because ultimately, all of these are the effects of our, as a human species, these are the effects of that progress. And I think the way that the organisms also are, they're also hitching a ride basically. So every ship that we send across, they're also passengers in a way. And, and these passengers are also creating their own structures and polymers and organisms. And we can learn so much from that. And we can also this sort of coexistence is something that definitely needs a lot of study. So I just wanted to note, it was very interesting to get two distinct perspectives from the same thing that we were talking about. And then even I was just thinking about the whole globalization aspect of how we're in an interconnected world, but we're not realizing that we are also allowing the microorganisms to be a part of this interconnected world. And we have so much more to study about what sort of new habitats and ecosystems and transcontinental highways and pipelines of microorganisms that we are creating, and what could we gain from it, what could be the impacts, and there's just so much more left to learn. So it's just a comment, but I think it was really nice to hear from you, ma'am, and from you, Sushil, as well.
I just want to add to what Calcine brought out, ma'am. There is what is called the ballast water treaty, and the ships, when they travel from one place to another. Can you hear me, ma'am? Can you hear me? Vashama, can you hear me? Can you hear me, ma'am?
Yes, but not very well. Yeah, I can hear you.
Can you hear me now, ma'am?
Yes, like yeah, I can hear you now. Yeah.
I was referring to the ballast water treaty that came about I think 20 years back. I mean, these big ships, when they offload, they take about, equivalent of their weight, which is about 30,000 tons or 40,000 tons, depending on the ship. And when they have to empty that to again reload cargo, they have to use those chemicals to make them neutral to any biodiversity that they may release in the new place. So, even for fouling, there is an equivalent, I think, to be thought of. because that also is carrying different biodiversity to another location. And if the cleaning is done in a certain place, it may have its own impact from a biodiversity standpoint. Any comments you would like to make on that?
So Dr. Das just wanted to add that there have been reports on resistance to anti-fouling agents that are now being used. So that's getting a little bit more difficult to kind of take care of these, remove these biofouling agents, because they also want to survive. So they are finding their own ways to get over the anti-fouling agents, which we are kind of designing again and again.
There are these, I work with the customs, Indian Customs Department. So there are these phytosanitary regulations, since you mentioned, which at every custom border across the world, they check for phytosanitary certificates and plants, seeds, fruits, and you are not allowed to carry across nations because there could be invasive species or seeds could be planted in a place where there's no balance in the ecosystem. So I'm just thinking of it from that point of view.
Yeah, every developed airport definitely checks your luggage for.
The seaports.
Yes, also seaports. Yeah.
I was the person who was talking about anti-fouling paints, Dr. Vashaji. So I'm from the Navy, so I was just basically telling
I'm not able to hear, so I have switched off my video because I'm putting my ear to the laptop. But that's okay. I can hear.
Yeah, no. Can you hear me now?
Yes, there is an echo. I can hear you. You can go ahead. I'm here. I can hear you.
Yeah, I hope you can hear me because now I'm using Arnab's Dr. Arnab Das's saying she's still because she can't hear. Okay, ma'am, can you hear me now?
Yes, sir. Yes, sir. Go ahead, please.
I'll speak at this volume so that you'll get it right. You see, it depends on what you're looking for. Now, the whole today's talk was basically underwater, awareness and how, and his thing was how these foulings affect the ship's movement and things like that and cost to the ship because of having barnacles. What you talked about is equally exciting, and I think I should suggest that every port they can have a place where a steel bare metal can be lowered and allow barnacles to grow and then have a good party with the rest of the biodiversity there. So that could be one way of taking care of the which is there. What you said is absolutely right, because if it helps the biodiversity, we don't have only think of one, we think of the other thing also and have thing. That's not a problem. But on a moving ship, on a ship that is got a specific thing, you're right. Anything that is good, like anti-fouling, the present state of anti-fouling paints, etc., came after a lot of this thing, both from the shipping industry and from the water body, whoever manages the water bodies. So today you have anti-fouling which is pretty good, and it should not leach. It doesn't leach so much as it used to before, and it remains till unless it's damaged. So while what you said is interesting, and you had a follower in Palestine who wants to take it to around the ocean, it's good. But today's thing was about that, so that is what we were talking about. But there's one important point which Dr. Das mentioned, that when we clean this thing along with the paint, etc., how do we dispose that? That also should be part, because we're doing it just next to the water, maybe in the dry dock, and putting it back all in the water. That needs to be definitely looked at. That's all I can say as a practicing engineer.
Yes, sir. So I definitely got your point. The only reason that I made this argument, if I may say, or this statement is to look at the other side so that we can control fouling. If we understand the biochemistry of a disease, then we can think of the drug. So it's like understanding a pathway so that we can put blocks or design drugs so that we can stop that pathway. That is the only way that we look at it. But I completely agree with your point, and it's well taken, sir.
Actually, anti-fouling paints improved. Anti-fouling paints improved over time only because of this kind of feedback which came into the industry, and they started making it better so that the paints, first the film doesn't form, it takes a long time to form, you're already moving by then, and if it does form, because it's in port for a while, then it doesn't stick, it just moves away. Nothing is permanent in life, things can always be better. So I'm sure.
There have been, sir, if we have time and if I can just add, there have been, sir, very interesting studies wherein when copper and copper compounds were used to take care of biofouling, they found that there were bacteria which produced pumps which could throw out copper. The bacteria also came up with a strategy of neutralizing the copper. So copper sulfate was converted into Cu0, that is copper zero, that is copper ion, so that it is rendered non-toxic. So as we are evolving, so are these microorganisms which have been considered very, trivial probably. So it's quite interesting to look at it from that perspective.
Thank you, everybody, and we'll break for tea. Varshaman, thank you so much. Suchir, thank you very much. It was a good presentation. Varshaman, thank you very much for
everyone.
sharing the session and giving
Thank you,
value. So we break for tea, and then we are in the last session after that. Thank you.
Thank you, sir.
Hello everyone, I'm Mr. Sunny Singh, and today I'm presenting ocean intelligence for the Indian coast. So in this, I'll be covering different aspects. Firstly, I'll be covering the biological, geological, and chemical aspects of Indian Ocean and ocean water to relate it with the fishes and modeling fisheries. Then second, we'll be covering the dark fleet detection and vast aspects of it and how it relates with maritime security and different fisheries domain. And then we'll also be covering the seaweed farms, fisheries farms, and fish farms, and how and what the need to map it. And we have a huge seaweed farms and aquaculture, but that is currently being unmapped. So what's the need of it and how we can do it? And eventually we'll be considering how marine heat wave is being affecting all of this together and what can be done in this aspect. On the first page, we have these 4 critical blind spots that I have figured out during my research, which I will cover today. The first problem that I faced was where the fish are. So, there have been, currently there are days in which the fisheries is being forecasted, but I found out there are some limitations and they're not sufficient. So the first thing was, it covers only surface and doesn't dig deep into the ocean to figure out where fisheries are. And sometimes it's inconsistent. And then the next question comes, who is fishing? This is a vast part of Indian Ocean and Indian maritime, which is being not covered properly. This is usually done using AIS, and majority of fishing and these activities are done by small fisher folks who don't have this big fleets to have an AIS system. This all major fishing part goes unnoticed. So, and the third part is what is being farmed. Here I will be talking about the aquaculture, seaweed farms, fishing farms, and why India doesn't have any mapping of these seaweed farms and what can be improved. How can we map this thing? And the fourth thing, how these things are being affected by the changing temperature and various climatic phenomena that have been happening throughout the decade. So, as I will come again to the same principle that we have been coming again and again throughout this session today, that we cannot manage what we cannot see. All these gaps cover what we cannot manage, and once we get all this data, we can manage these things. We get to better policy making and better managing of these critical aspects of Indian Ocean. So, covering first, most of these gaps I have figured it out for the Konkan Coast region. Why I have done so? Konkan Coast is one of the most important Indian coast. It contributes around 41% of Maharashtra's total GSDP, and it has more important ports like Mumbai and JNPA. Along with this, only Ratnagiri and Sindhudurg and Raigad, like coastal areas in the Konkan coast, supports around 4 lakh falls. And along with this, it has been observed like throughout the decades, the fisheries collection has been declined by 42% due to different climatic actions and climatic reasons. And there is a need to study these changes that is currently being happening in the Konkan region. So I have focused my research on these different aspects on the Konkan region only for start. Let's come to the problem. What the problem here currently is? The first challenge that we are currently facing is there is very less amount of data which we can study and derive some results out of it. So firstly, there is need to cover the ocean deeply, and there is no data out of it which can be used later by these few stakeholders. The first one are the research polls. If there are more data, then a better understanding of ocean can be done, and these information can be conveyed to the research folks in such a way that can be useful for them. For example, like vast amount of research falls go on daily basis in the vast ocean, and without any proper guidance where they need to go to find the fisheries. So once we have a proper data, we have proper map, then they have the proper guidance. They know where to exactly go. They can save fuel, they can save their time, and they can increase their profit in the same amount of time and effort. And then the coastal policy makers. These are people who make policy for the ocean. But what happens if they don't have data? They hallucinate. They can't make proper decisions. They can't take proper decisions because they don't know what is actually happening deep down in the ocean. So it helps them. And then maritime researchers. We as a researcher can't go to the oceans, get the sensor data, get data, and always we can't. Most of the aspects, like even I personally faced also, like while covering this aspect, at multiple phases in my research, I faced that there was a data gap. I don't have data. I don't have data to validate my findings. So there is it helps them also. And overall, this all covers together to come to help in the economic sector. And why this is necessary? Through past few decades, we have been seeing decline in fisheries collection and other big problems, climatic problems such as floods and other aspects that is being seen more often than before, which creates a need. This creates a need. Like now, this is a time when we need to expand our knowledge of the ocean and the data collection in the ocean. So, what are the critical gaps I will be addressing here? I will be covering the illegal fishing. Like there has been a lot of illegal fishing that is being currently happening in the Indian coastal regions due to different reasons. And one of the main reasons is not proper monitoring. So I will cover that aspect also. And then this whole thing will also can help the government and policy makers. As I covered earlier, they will have more data. They can take decisions with data which are backed by data and which are logical. And in the third aspect, I am trying to take all this maritime domain search and everything from a reactive basis to proactive basis. Currently, what happens when something happens, government knows things, get the data on it, and then they take action. But what happens if we have a data previously? We have data even before the things happen. Now we know what is going to happen. Now we can make policies, we can take decisions beforehand and stop calamities from happening or stop things that are not meant to be. The first aspect of this is the potential fishing zone. So in this, I have tried to make a model that can measure the potential fishing zones throughout the Indian Ocean region based on different climatic factors, biological factors, and geological factors. It is based on an equation in which we have to put multiple parameters, and it gives us a probability score, which eventually tells us like if we go out in if we have a map of Indian Ocean, then by the score we can tell which is going to have how much fisheries and which species are there. So this it also covers few of the major aspects like oxygen minimum zones and about the food web and forecasting aspects also, which is currently being covered and has several limitations currently. So how this is being done? Let's cover the limitation first. So currently, the current systems only measure the surface data using satellite, which covers only 1 to 2 meters of the surface data, and they take only few parameters into account for the fisheries procrastination. That's the surface temperature and chlorophyll, which I will just explain why it's not enough to cover the whole fisheries region, and there is a need of more in-depth analysis with more parameters to cover these things. So while solving this limitation, the first thing that came into my mind, like how can we solve this problem? So the first thing that I noticed was there's a lack of parameters. The first thing I got to do, I looked for more parameters, and I found some parameter which strongly affects the food availability, the biomass, or the fisheries biomass in an ocean region. And I try to take those parameters. Along with this, I even try to find ways in which we can go deep into the ocean, not just level surface. We can go deep into the ocean. I have taken a for our this modeling, we have taken a depth of depth of 100 meters, and we have done it for 100 meters of depth, which tells a lot about then the steep setting surface. So what we have done, we have taken 5 parameters from Copernicus satellite data, which is a very good source of data because they have the data. Along with this, they will have sensors, and they mix both of the data and give a single data which is the complete score of those readings, mixing both satellite data and the actual sensors. So I've taken data like NPP, NO3, chlorophyll, temperature. I will give details on it more. And I've taken it for the 100 meter of depth, and I've used temperature group because what happens in ocean, things don't vary linearly with depth. They change drastically, and there's no particular order. For that, I've used trapezoidal rule for using the column. So these are so what I've done, I have made a single equation which has multiple terms, particularly 4 terms, and they have different weightages. Firstly, I will cover the terms. The first one is thermal suitability index, suitability curve. It tells about how fisheries depend on the temperature of ocean. Like if for of ocean, if there is some temperature that is particularly good for a species, then I have normalized between a score of 0 to 1, and I've given a score 1 means that is highly suitable for the species, and that indicates if that region has those species. And similarly, I have done another parameter which is oxygen suitability, which indicates the availability of oxygen in those regions. These, and this also indicates if it's, the score is 1, then the oxygen is suitable, and if the score is 0, then they are the oxygen minimum zones, and we can even call them those zones hypoxia. And then these are the 2 other parameters. Net parametric production. What is this? Net parametric production indicates the amount of nutrients available, nutrients, or you can say the food available for fishes in the ocean. This directly indicates how much fish can be there in a particular region. If a particular region has more amount of phytoplanktons, food, then that indicates that more fishes will be there. It's not always true. There are some cases which I will cover where this is wrong, but this is one of the most important factor here, which indicates the amount of fisheries in ocean. Then we have nutrient gradients. Nutrient gradients indicate the amount of nutrient difference and nutrients present in an ocean region, and it helps to forecast because if there are more nutrients in a region, that indicates in future there will be more NPP, net food for the fisheries. So we can forecast if a region has more nutrients now, then in a week or 2 weeks there will be more food and there will be more fishes. And these are the 4 parameters: temperature, oxygen, net parameter production, and nutrient gradients. And I've mixed 4 of them together in this equation. I have first normalized them using these formulas so that I get a score from 0 to 1 for all of these 4 parameters because they have different dimensions. So we can just directly add them or make equation of them. So first I normalized them to get a single score between 0 to 1, and then I've used this. I have called it the physics composite suitability index. It tells, it gives a score between 0 to 1, and it exactly tells how much probability of finding fishes are there in the ocean in a particular place. It integrates, I have those all 4 parameters in this form. I have given NPP the highest weightage because where there are food, there will be fishes. Then there is O2. This O2 is currently not present in the current ways which are being used for current forecasting, and which creates significant problems which I will be covering later. And then NO3 is also not there in current system. So I have integrated these 2 also based on their weightage. Currently the weightage is static, but with time they plan to upgrade the system to move it to more dynamic equation, which will be varying throughout the region of oceans based on the specific location and geography. And this is again the why I've used the trapezoidal rule, because in ocean this the value of this parameter doesn't change linearly with the depth. So we have to do a trapezoidal integration to get the changes at every depth properly. And using this, we have got a similar structure of species. Like we can just predict now at which level what species will be available in what quantity approximately, and in which time of the year. It helps in forecasting which species can be found in which season and at which time of the day or year. I have done it. I have taken a data of 1 year for 2025 and I plotted it throughout the year, and which shows this result. It shows that the amount of fisheries in ocean in the coastal region was at peak in the winter and was at low position compared to winter in summer, which is even validated by the CMFRA report, which says the same thing. So we have even validated this using this CMFRA report. And these are some other readings also. It also indicates like how oxygen starts improving as soon as the monsoon arrives, as more water fall inside the oceans, and it increases the oxygen values. From these results, we can explain even some of the natural phenomena that are currently being happening in the oceans. We have seen there is this long curve. Let me explain why there is a high curve of fisheries in winter. So the reason behind this, it is the winter bloom, convecting mixing. So what happens in winters? In winters, the water on the top of the ocean becomes cool and it sinks. And usually, what happens? Fishes are mostly on the top level of the surface of the water. They eat the nutrients and plant and everything, and it becomes less in nutrients. In winter, those less nutrient water become dense and cold, and they start sinking deep down in the ocean. And the nutrient-rich ocean water from the downside start coming upwards, which replaces the nutrients in the ocean at that time. You can see here, I have shown this into diagram also, how these nutrients less water is coming down and the nutrient-rich water is coming upwards, which replaces the overall nutrient concentration in the ocean and which increases and keep the flow of fisheries there. But if we come to the summer, this thing doesn't happen. In summer, what happens? The weather is mostly warm. So the top surface water is mostly warm. It is light and warm. So it doesn't go down in mixes. So the nutrient can't come upside on the surface, and those regions becomes nutrient-less zones. So if there are no nutrients, there are no food, then there won't be any fishes. This creates the problem, and this is the reason why we are getting this graph, high in winter bloom and low in fall. And one more thing. Why I have taken oxygen into account in my equation, and why it is helpful, because the current measures don't have oxygen in their equation. What happens? There is an example of a case where there are regions which have nutrients, but there are cases when for some time if fishes don't come to those regions, what happens? The bacteria present in those regions start decomposing those nutrients using aerobic respiration. And in aerobic respiration, they consume all the oxygen in those regions, and that region becomes oxygen minimum zones or hypoxia. If we see on the surface using temperature and chlorophyll readings only, we will see that this region has the good temperature and the good nutrient, but there won't be any fishes because there is no oxygen for them. And if they can't breathe, there is no oxygen, then fishes won't come. So the earlier system fails in these specific cases where there are oxygen minimum zones, which is created due to aerobic respiration of decomposing the food by bacteria. But our model also measures the oxygen values, so it also tells the places or regions where these conditions are being happening, so that we can ignore those regions. And then in our research, we also found out that there was a sharp relationship between the temperature and the net primary production, which indicates as soon as temperature increases, the primary production decreases, and the whole fisheries, which also explains why there is winter bloom and there is a fall, less amount of nutrients in fall, as there are high temperature, which indicates less food and then less fisheries. So to explain the whole structure of my model now, firstly, for this what I have done, I have taken data from the Copernicus website, and then I processed it, normalized the data to give me a single score, and then I have merged the single score using my equation to get the primary fishing suitability index, which eventually tells the probability of fisheries in a particular location. Then I have done it for a long reason, like for this. This is a Colgan coast region. I've done this for small reason. For every point of hexagon, I have taken the PHN score and have plotted it here. This indicates the availability of fishes in those regions. This kind of plotted for all these regions with the same data from the same Copernicus website also. Using the SC grid, and the final output was a single map which just tells in a single look where we can get the fisheries, and we have done it on a daily basis. It gets data daily basis and plot this map on daily basis. So coming again to this, like how it is different from the current existing paved approach. It covers depth analysis of 100 meter, which is improved version of the earlier surface approach. Then it also explains the habitat stability. Different parameters also indicates the different amount of species which can be found in a particular region based on the values of temperature and oxygen. Then again, I have given the map. We have given the map of this region, which directly indicates and helps. And then we can even forecast this as we have taken the nutrients into account. So we can even tell like how the nutrients will be there, how the fishes will be there from 1 week from today or 2 weeks from today also. Okay, so this was all of the PFZ. Then now the second thing was the maritime security aspect, especially related with the AIS. This is one of the very important aspect of maritime. Like India has around 2.5 million kilometers square of vast maritime region. In this, most of the fleets that are there don't have AIS. There is no proper monitoring system for them, and they usually go unnoticed. They don't forecast. They don't give any signals, so we don't know about them. And due to which there is large amount of IU fishing, fisheries mismanagement, risk of maritime security, as any foreign fleets from other countries can visit our country without AIS, and which creates the maritime security aspect. And then there is also a risk to resource sustainability, as there is no control on this dark fleet. They can do any amount of fisheries in any region, and we can't monitor it. So there is a need to have a system which don't completely depend on AIS, which goes far beyond AIS to measure these dark fleet. So this is just illustrative numbers, not in exact numbers, which proportionally indicates that if the fisheries indicates like there are nearly 5,000 fisheries fleets, then only 500 of them are having AIS, and that only amounts to 70% of total fleet, which indicates the majority of the fleets are going unnoticed, unmonitored, and can't be we can't take data from them, we can't monitor them, we can't control them, which creates a lot of uncertainty and things which can't be controlled and some real aspects. So what we plan to do for it, we are using a method that is being previously done by North Korea also, and they have validated it in their region, and which results are from there only. They are able to track 900 plus using IS, and there are more than 700 dark fleet signatures which they use to detect using SAR and VRS. And totally mixing all these solutions, they were able to get around 3,000 fleets, which was at 99.8% precision, which is quite a good number. So what was the solution? AIS is a basic technology where the fleets have to broadcast using radio signals at their location, about their details. But for those fleets which don't have AIS, we plan to use SAR. What SAR is? SAR are the satellites which send microwave signals or microwave signals or sonar signals, which directly comes down in the ocean region, and they get reflected back by the ocean back to the satellite, and they measure using that only. And what happens if there is any fleet or something, then that will be metallic or that will be a hard surface, and it will reflect more microwave readings, microwaves than the normal ocean water, which will actually help us to know like there is something metallic, something hard in the ocean at a level. And then we are using VIRS. It is a visible infrared imaging radiometer suit. What it does is in night it measures the dark lights. Because usually what these dark fleets do, they use bright lights to detect to attract species. And it's the same thing. We can use these satellites to to see these bright lights in the oceans, which confirms that there are fleets which are trying to capture fisheries, and there are fleets. And then the third is the optical imaging. We can use the satellite data, the visual data, to figure out if there are fleets or not. Any one of them alone is not enough for this purpose. We need a combination of all these three methodology, SAR, VRS, and optical. So we will be using SAR and then validating it using the VIRS and then confirming it again with optical to confirm that there is a dark fleet in the ocean region. This is the idea. And these are the benefits and availability and the data diet with the AI. So this complete system of using multiple technologies like SAR, VIRS, and optical, we plan to monitor all the dark fleets that are being operating in the Indian Ocean region. And then this is the second problem. India ranks second globally for the world's largest aquaculture producer. But even after this, there is zero recorded area of aquaculture, seaweed farms, and anything like this. And this creates a large data gap and blindness for the policymakers, government, people who are doing these farms. So what are the aspects of this? Firstly, this creates a problem in marine navigation as the big fleets don't know where these farms are. So there are usual cases where they tend to destroy those farms. Then there is no proper monitoring and policy making. And then there are security concerns of operating these fish farms and that is currently there. Why they are being unmanned? Why they are not being measured? Firstly, how foreign like countries like China have done this. They have used monsoon. They have used satellite imagery to measure those things. But for us, it is quite difficult. We can't just do it directly because in our Indian Ocean region, there are a lot of time when there are clouds. There's monsoon time, so there is no proper visuals from satellite, and then there is very high variability in ocean sometimes. So, like if we use satellite data, and if the water is too turbid, there are too much amount of sediments in the water, then if we see from the satellite, it looks like a seaweed farm, and which creates cases of false positives and false negatives. Sometimes they get measured as seaweed farms, and sometimes the actual seaweed farms can't be measured due to this reason. And then the third part is India has mostly straight coastal lines. So these seaweed farms are fishing direct ocean currents, ocean waves directly, which eventually destroys them and makes it harder to monitor on a daily basis. And the main problem of of this is like most of the seaweed farms that India has are very small in size, so they can't be we can't figure out from optical imagery. It's become difficult to know from an image only that if this is a farm or not. So coming to the solution of it, we are trying to study the special geographical aspects of the Indian coastal regions apart from the foreign region. We are studying geography, how it affects these things, and then we are trying to use multiple years of data. We will be taking the images from multiple years and analyzing it over and over again to find out the patches that were consistently there in those regions, which eventually proves like, yeah, this thing was there from large amount of time. For this also, we are trying to use SAR and optical. SAR use microwave readings, which have no effect of clouds on it. So it can measure even in monsoon times. And then we will also use optical imagery. Together, while mixing both of these, we will be getting an overall image how this seaweed farms look. And SR depends on wind speed, wave height, tide, and polarization. And these are the one aspect of things. And optical is independent of these things. They are not independent. They get their readings differently, which is easy to, which makes it easier for us to mix them together and get to a confirmation, like if the result is actually a seaweed farm, fish farm or not. So this is still in progress. We are finalizing details of it. So what was the main thing, principle behind doing all this? It is to make the whole ocean intelligence from reactive to predictive. Currently, what happens Okay. Currently, what happens? All the decisions, all the policies are being made once the things have been done, once the problem is being there. But using our forecasting, our technology, our modeling, we can forecast thing or to estimate the railings and how the marine ecosystem will change in future and can make policies for it beforehand. Thank you.
Have you validated your, thesis or your prognosis with some actual data?
Yeah, I have done it for the PFZ, present fishing zones.
Sorry?
For present fishing zone.
Okay.
For it, I have used CMFRA reports of 23 year, which shows the same curve that I have shown earlier of fisheries, as they have also shown the peak in fisheries collection in winter and the decline in summer. And it also explains the various natural phenomena, which eventually validates our findings.
No, basically I was talking about where you're doing the buck, like where the
Dark, it's still in development phase. We started it, so it's in development phase.
What these things goes by, you can verify your data with that and actually make a good picture for.
That's actually a very important critical problem for agency which has that.
So in this, basically,
The agency will be the guy who gets the vote out for the day. उसका book by ICWA because the only chap knows how many are living at sea.
So, sir, in this, basically, this is all the data which is based on the historical data which is available in the intermittent sources and stuff like that. The result at the TRL level 3 and 4 has been proven by MRC. We are now looking forward to take it that if some prediction has come, let us go and see that whether that amount of SIP is available, this is available in that area or not. That will basically take it to the level of where by predictions we are finding out where the SIPs are available, these are available. And then we will take it to the deployment level where we will give these services to the fishermen over their app so that they can plan the fishing trips according to that. So that is the entire idea to take it forward. PL9, where we will be making the entire mapping on the GIS map. And then the fishermen's boats and then owners, they can plan their fishing trip based on this data available at a particular time because see, they are taking the fuel, taking a long loan from the government and different agencies to fuel their boats to the deep into the seas and then come back with half of the things catchment which are not even meeting the loads that they have taken.
We should know who's going out because the basic thing was that they don't have AIS. I know that the government has distributed AIS to all the chaps, they just threw it away because they didn't want to.
Right, sir. That is another story, sir. I should have covered it.
So that's what I'm saying. Therefore, thing. So now we can validate it, just go to that site and.
Right, sir. That is what is work, sir.
Sorry, I had one point. Yesterday, all of you saw the MSP tool that was presented by Sridhar. So the idea is that every aspect, like what Rakesh said, will be validated in a particular region. And so that we will work with some agencies like Bell and others. And then licenses will be issued so that everybody, and because a lot of data is common, whether you're working on fisheries or biofouling or various other things. So that tool kind of takes care of all of it. And once you have one box, it becomes far more efficient. I mean, the data sources get consolidated and even the processing gets consolidated, the compute infrastructure gets consolidated. And then it can kind of serve many customers. And as Rakesh, you had mentioned to me that, these bigger programs and when you deal with fishing fleets and all that, the numbers are huge. So in that, we also need to focus on the compute infrastructure so that if so many people, I mean, we're talking few lakhs. So if so many people access this system simultaneously, then the system able to. So those things are also being looked at by us, and that's why we wanted to consolidate. So that's what Sridhar presented yesterday.
It's in this, basically, we need the help of the Navy also because we are building one solution for the Navy called smart ship operations. So we are putting the cameras, radars, and other things. So within our range around the ship, we are trying to detect and identify what all ships are there. Using that data, we can identify the fisherman's boat also. And using some channel, if this data can be given it back, we can fuse the data of the SAR image. We can fuse the data with the electro-optics based on a satellite this one. As on date, the accuracy is not that much because it's all geosats, but hopefully 2-3 down the line, year down the line, then the WPC will be for running the low orbit LEO satellites and then payloads having the SAR and other things will give a lot of data which will be more and more accurate as far as this kind of applications are required. So it's basically getting a data from the different sources and then using AIML, using them and then make out the intelligence, and those intelligence we need to distribute to the different stakeholders, in which the fisherman is the one part of it, because the entire story of this monitoring of the fisherman boats started way back when the 2008 the Mumbai attack has happened, and after that this entire concept has built up. So government is giving the money to put the gadget into the set. They are giving the bandwidth, whatever the small bandwidth is available with the IRS services, through which all the ships are sending their GPS locations to one central locations, and the command and control center is built by us, which is giving the data to ICG also, which are giving the data to the all 10 monitoring stations at the district headquarters of the coastal states which we have. So the stuff like that we have already built. We are now thinking that by doing this digital twinning based on this imaging and other aspects, if we can pull in data into that platform, ultimately we can give one more service to them. Because one service already we are running where the fisherman can send the amount of catchment to their owner, and then they sell before their boats reach to the shore. Before that, they sold it to the market, and then they dump it, and then straight away it's going to the market. Earlier, it was a challenge because once the boat lands at the shore, then the buyer comes and then they take it. So now this all we are providing through that software application that we have provided. So these other things are required to be coupled with themselves. So not many things are required to be done. The LEO satellites things will come. Probably the things will be much better for this kind of underwater domain awareness space that we are looking at. So green navigation. No, it's for the all objects on the surface up to 20 kilometers surrounding that any ships and any carrier. So kind of threat analysis, because what is there? No, what we are doing it for the Navy. It is for their warships in which they will deploy this cameras, and then the radars that they have, take the data, fuse it, and identify which ship or which class of ship it is. Respected esteemed leader, Admiral Bhamasar, the leadership team which is there on the front line, the different practitioners, and the young leaders who are going to lead the futures. Ladies and gentlemen, very good afternoon to all of you. I thank MRC and in particular Commander Das for giving us this opportunity to work for 2 days, having a different kind of knowledge sharing onto the domain awareness. So with this point, basically, I am from the industry, and the maritime stuffs is not new to us, but we were only involved in the defense and security and stuffs like that as far as the ocean interaction is concerned. Now, if you look the vision of Government of India, the Vision 2047, blue economy is identified as one of the biggest economy in the future. And there are 2 domain awareness on which we are working. One is the under domain awareness, another is the space. These 2 segments are very important. Space from the security and defense perspective, because We need to do lot many ISR functionalities to be done from the space for our defense of our country, strengthening our country defense capability, and underwater domain awareness specifically for the economic activity. So as far as the economic activities are concerned, so far in India, we are working only 4-5 different areas where we are actually exploiting the ocean from the economic growth perspective. One is the shipping, which is there for the ages. In that, we have added the fishery, which is again in a traditional way. We are doing it from the, I mean, since the Homo sapiens comes into the world, and from that time onwards, we are doing it. Coming to that, that means the international border formed, and then defense and security, and then regulation has been built for country to country interaction and other things. The defense and security are the other segment where we are using the oceans and doing as an economic activity. Now, as discussed in last 2 days, in the global south has got the most populous base, and the economic activity which is there, again the opportunity are biggest in the global south. Even if it is on the land itself, the trend, if you see it, the maximum market for the entire GDP of the world is coming from the global south, and the global south is falling into a basically near to the equator, and where the sea characteristic is entirely different from the others. And if you see the coastal lines which India has, it has got a huge coastal line, although many countries have got, but the length of that coastal line is not that much. So to sustain the economic growth, that's why the government of India has come up with the missions. The very first statement in the Vision 2047 says global leadership in the ocean development, and that is the sustainable development. It says not many things about this. I'm just reiterating all these points because why, as an industry, we are interested into it, right? So, and then the strategy of this global leadership is based on the technology, like marine science, coupled with the AI/ML, autonomous system, and biotechnology. These are the 4 technology pillars which has been identified to make this vision 2. And the aim is to have a exclusive growth of the entire population, including the sustainable environmental protections and then stuff like ESG. So these are the things which are basically coupled with the Vision 2047 when they talk about the blue economy. So now a new sector as a big potential is coming up in future, and not many things are required to be done where we need to invest on the technology development, and making the use of this as an economy activity. The cost need to be reduced so that the operation in this domain could be very, economical and the cost effective and profitable. So this is the thing which we are looking at. And if you see in the R&D, we have got a strategy called Blue Sky Research. And in marketing, we have Blue Ocean Strategy. So I'll just give couple of minutes to explain what is the Blue Sky Research. Any research which we are doing it for a longer term, say about a timeline of 5 years and above. 5 years and above, where we do the experimentation. The effort and the expenditure on the R&D is not linked to the immediate gain of some business or market. That falls under the Blue Sky Research. Means something which is coming in the future, and then it always happens that the disruptions doesn't come from within the sector. Like we are on the defense, but the disruption has not come from the defense market. It has come from the other places. Like AI is another disruption which is coming here. The ISR functionality using the satellite space and other stuffs, it is not done into the defense domain. It's a technology development which was undertaken some 5 years back under the blue sky research. Now it has been proven and technology are getting adapted. So this kind of research comes into the blue sky research, like the industrials and MRCs and then R&D community of Bell and then entire India is working, is a kind of a blue sky research which we are looking at that in 3 to 4 years or up to 5 years timeline. The stuffs will come at a cost which can be deployable, which will be at a TRL level of 7 and 8 and giving the benefit to us. Now coming to the blue strategy, when we talk about the blue strategy, it's a blue strategy, blue ocean strategy. Blue ocean strategy is that you are the creator of the market. There is no competitor. You are the king because you have invested into the blue sky research, come up with the product and services, and there is no competitor, and you are the king defining the rule. On the contrary, there is a red ocean strategy where there is a lot of competitions. One product and services are limited. You are fighting for those through competitive bidding. You are trying to reduce the cost by making some cost cutting measure, which is transactional in nature. So that blue ocean strategy is related to the marketing, and we as Bharat Electronics looking this the intersection of blue economy, blue sky research, and blue strategy. That is where this particular area and domain fits in our strategies, and that's why we are working on to it. And to achieve our objective in this domain, we are open to collaborate with industry, academia, startups, and stuff like that. And being the government, the moment government mandates some vision, that visions basically as a part of commitment come to us also, because we are also governed by the corporate governance, which needs to get into the, as a mechanism into the government's thought process and vision to make this enable. So we have got a clear-cut directions from our ministries to work on this kind of problem. So, and then we don't look the private players and startups as our competitor. We are looking them as a collaboration. Yes, it's true. At certain place we may be competitor, we're competing to each other, but there are not many space where there is a common agenda of growth where we need to collaborate. So we are working on a strategy where it's not a competition, it's a co-optition. So where co-optition is that wherever there is a market where you are competing, but try to find out the major area which is much more than the area where we are competing. If you take a complete pie chart of it, probably 10%, 15% places where I am in a competition with one of the company, maybe Tata, L&T, TCS, and stuff like that. But there are the places where there is a common area where we need to cooperate with this one. And the major challenge is that the competition is not within among ourselves, the Indian companies, whether public sector or the private sector or the startup. The competition is from the import. The competition is from the foreign players, because if we don't do it, they will come in the name of funding from the World Bank, saying that I am here to help you out. But there is a cost to help. The help that is spending, there is a cost for that help. And that cost is very, very high. Very, very high. You cannot just imagine and then put a matrix to that, what they are going to take out of you, right? And they are also, even in the maritime domain and then underwater domain awareness, they know that the ocean has got the treasures. And this is what they are doing into all African countries. In African countries, not into the water, on their land. The rich source of mineral which is there in the south of African countries, whether it's the countries on the north side or the south side or Central America, all the people who are there into mining of this are the Britishers. The way they do with us till 1947 for 200 years, they are still doing there. And then all profit they are taking it. And those people from the Africa, the local people, are still into a kind of conditions which we never imagined. So same thing is applicable for the underwater also. So if you don't prepare ourselves to do all kind of exploration by ourselves, probably we are going to give them on platter where they will do all kind of excavations, explorations, and take the major profit out of it, and we'll be left with only to stop them.
No, issues for us.
Right. So that is the thing that I want to convey. And from the industry to all startups and to all research, we are there with you. We'll join hands and go forward with this. And all practitioners, my request is that any kind of problem statements that you are facing into your operations, kindly forward it to us, be at a research level, be at a tech development level. We'll try to address them and give you the services which will be much better than what a foreign OEM product will give. That is, with this, I'm closing my talk. Thank you very much.
Thank you so much, Rakeshji, and it is indeed very encouraging to get the entire spectrum from all the people, and you closed it very well. I mean, the last session was worth that because getting an assurance from the industry and getting an assurance of support for researchers, research institutes, think tanks, startups is extremely important, and I really thank you for that. We move to the last session in the sense of the closing session. I would request comments from the audience. I mean, the way we'll follow it is we'll have comments, very quick comments, not very long comments. And the youngest will be the first target of mine. So you can decide who's the youngest. And we would reach out to a diverse set of people, students, faculties, practitioners, armed forces people are also here. A very quick comment of you, so that that's also a mandate given to us by our support agency, which is ICWA, and they would also like to know because they are looking at it on an entire national level, and they also support. In fact, they wanted us to do a international summit, but we thought that let us start with the national one. So that those comments are very important. Then I would request Mr. Arudra to give his concluding remarks, and then obviously Verma sir to give the last final word.
Where's the fish?
The last row, please. Volunteer, one of you, and maybe a couple of you. The mic has already reached you. Whatever be your comment, don't feel embarrassed. Please speak. You can, yeah, please go ahead. Please let your name, please tell us your name and then your institute also.
Yes.
Yeah.
My name is Siddhika Sheikh and I'm from MIT Academy of Engineering, Chemical Engineering branch. And being a chemical engineering student, this is the whole new approach for us and a new way to explore the underwater awareness. We were not aware of it from the initially, and both the days we have attained this seminar, it was just like a new experience for us and to look into it more. So thank you so much for giving us this opportunity.
Thank you. I must compliment you for staying there for both the days from morning till evening.
Thank you so much, sir.
Yeah. One of you, one more, somebody else.
Good evening, and we all are from MIT Academy of Engineering, same chemical engineering branch. As she mentioned that it was really a great opportunity that we, like before this, we didn't know about this domain. So it was really new experience and we got to know more about the underwater domain. So it was really nice opportunity for us. Thank you.
Thank you. Ma'am, would you like to say something? One of you here first. Yeah. Ma'am can speak and then pass on the other mic.
Good evening, everyone. I'm Commander Hema. I'm posted at National Defense Academy. I'm an instructor there. I've done my MTech in Telecommunication System Engineering, and most of the topics which was discussed today was very relevant because I come from a radar background and I've worked on ISAC basically, which is on PA types. So it was very refreshing when the data analytics came into picture along with the congruence of the strategies till the tacticians level, because I work in a very tactician level. So that was very refreshing, and I would take the opportunity to thank you for inviting us for this lecture. Thank you so much.
Thank you. Really appreciate. Any one of you would like to say something?
Good evening, everyone. I'm Lieutenant Charles Kalla. I'm posted in National Defense Academy. I'm Division Officer of Quebec Sport. So basically, this domain was not very far cry to me. I'm a submariner by profession, so my domain is underwater. So few of the topics which were discussed over here, they were new to me, like sedimentation and all. I didn't know that so much research study can be done into something so minuscule things which we see in everyday life. Other than that, there were few subjects which I had already studied when I was in academy in my 7th term. So getting more insights in those subjects was a very fruitful experience. Apart from that, this domain is what I'm into. So it was very nice to be attending a conference in such this conference, which is in such a topic. This is to just convey my thanks to MRC to invite us to attend this conference. And that's all. Thank you.
Thank you so much. Yep. Yes, sir.
Myself, Shantanu Karode from GH Raisuri College of Engineering and Management, and I'm in academics. So I think this is the best lecture for the field academics, as the awareness is get to what can they be spread in that domain. And I personally working in the water resources engineering. So I'm just having the literature on the glacier lakes outburst flood, and somehow from the yesterday's session by the country, that is the link with the subsurface flow and effects of what is going on in under the water. So somehow, before that session, I was completely unknown about the underwater phenomena, but somehow I am aware of it, and I can link those processes with the subsurface also. That is the effect of that, obviously. So thank you for giving this opportunity, all the speakers, and thank you.
Thank you.
Good evening, everyone. I'm Lieutenant Dipesh Chadha. A very enlightening seminar which has covered a wide array of topics about the underwater domain. We would just like to convey our sincere thanks to MRC and ICWA for maintaining the tempo for both the days and conducting the seminar in such a successful manner. Thank you.
Hello everyone, I'm Abdeep Samant, currently doing masters in IR, and especially when it comes to MRC, special thanks to Dr. Arnav for inviting me for this wonderful 2-day seminar, and also to ICWA, who is really to know more about the topic. And also, once again, thank you for having a wonderful event. Thank you.
Yeah, good evening, Shukma from Bharat Electronics. And on this subject and 2 days of conference, really wonderful because it's a very unique, and the amount of information is first of its kind. So I enjoyed these 2 days and the depth of the in the underwater domain, expertise in the technical papers, whatever the research going on. Splendid, sir. Thank you.
I'm Brigadier Sandeep Deshmukh, retired from the Indian Army. I have been CSO Tech, Chief Staff Officer Technical, Andaman and Nicobar Command. So I had some exposure with the maritime domain awareness. But underwater domain awareness is absolutely a new subject, and except for my scuba diving at Andamans, I didn't have any knowledge about it. The kind of series since yesterday, the speakers, they were experienced ex-naval chief, ex-army chief, commandant NDA, commandant CME, other ambassador Mauritius, ex-ambassador Mauritius, then the youngsters from IITs. But an eye-opener, as we said, some of the presentations were really the PhD thesis presentations. And another thing I learned from him, science and social science, engineering and social engineering, and that another nice idea which you gave, this biodiversity traveling from continent to continent with this biofouling. So thank you so much. It was very, very wonderful conducted. And Dr. Arnav Das is an old friend. We served together in Millet, Virinagar. Thank you so much for giving this opportunity.
for me, the underwater exposure for the last 2 days has been really great. And where our country is going today to take out the wealth from the ocean, I think we should take this wealth to ourselves instead of letting the Western countries take it from our area. And grateful to Dr. Arnab Das, Commander Arnab Das, for having extended the invitation to me for a dinner party at one of my postmates' residence. And I'm grateful to you. And on behalf of my faculties and students of Raisoni College, also I would like to thank you. Thanks a lot.
Thank you so much, sir. Very appreciate you spending time. Again, your comment.
So most of the things I've already covered into this. And really, I was eagerly waiting for this 2 days session over here. Although we have got a couple of meetings also with the startups and then universities. In this, I've missed 2 things. I hope, sir, you will be able to hand over those courses, whatever the materials has been discussed over. Please forward it to us so that we can go and deep dive into the subjects and find out the opportunity to interact with this one. The challenge ahead is too big because the main thing that we need to do is to basically build the autonomous systems. Because to explore underwater where the human cannot go, we need to build the autonomous systems with the payloads, which can go take the probes deep into the ocean bed, take out the samples, and then bring in those samples so we can study that what the soil bed beneath the seabed soil characteristic is telling about that. Because those are the big signals that we need to listen. Those are like, sir, your team has presented that every drop of the ocean is having the DNA characteristic of what is underlying thing. So similarly, the seabed, how to take the samples, those are the autonomous systems, and then taking those big data to the place where the analytic engine, AI-based AI engine will operate. That is another big issue because you need to have a kind of broadband connectivity between those autonomous systems which goes underwater, then buoys which will be floating into the water, the autonomous R&D and research vehicles because it will be keep on floating. The design of those kind of autonomous vehicle, surface vehicle, propelling onto the energy of the sea wave itself so that not much of the energy is required. All electronic systems to be powered with the solar power, which is built on the USB also. Those are the technologies which are challenging to explore it until unless we work on to those kind of things. Because ultimately we need the data. We need to data analyze the complete seabed and mapping those seabed and categorize them in a different kind of resources which we have possible, and then go and dig and then see that what kind of mineral, oil and natural gases and then hydrogen fuel things which are there in the pockets because we need to take it out for the sustainable energy. So one side for the green energy we are leveraging and we have done good into tapping the tidal wave for converting into the energy, but much more than what is there inside the sea. So for that purpose, the challenges are there, and then as a youngsters who are there in the college, who are going to take the country to next level in next 20, 30, 40 years, we have to work together. And one heartening thing that I found that the previous leader, the current generation, and then the next generation, there was a fusion of all three kind of people who has participated into them. And it's the experience of the seniors, the leaders who has led us to this place, the one who is now currently leading it, and the one who is going to lead the country. If all three together works, probably we will reach to the destination what we are aiming for. Thank you very much.
Thank you. Previous speakers, officers, researchers, and ladies and gentlemen. As we approach this 2-day seminar on advancing UDA framework for India's MAHASAGARVision and its realization, I would just like to quickly
touch upon sort of a framework of the seminar and the key ideas that emerged during the discussion, and maybe briefly add my own suggestions briefly at the end. So one of the things that's needed in any discussion on UDA, as we all know, is not just to look at the siloed prism, just military or tech, but include all the relevant facets of UDA that are critical to our interest and objective, right? So, for instance, if we, like we saw during the session today, Romit's presentation on sedimentation management, that was quite insightful for me. I didn't know many of the nuances and how the processes work. So, including how we showed that higher siltation load affects the shore erosion, port operations, etc. And how sedimentation management needs to be predictive rather than reactive, right? And for instance, it was Suchi's presentation on biofouling techniques, which suggested the need to have alternative anti-biofouling techniques. And that third one was which I found perhaps more interesting in a way was Ashwini's presentation on fisheries and aquaculture, wherein basically, essentially, he showed how conventional fishing zone advisories are just relying on data like chlorophyll and sea surface temperatures are all sort of the requirements that current underwater shifting operating data parameters that are included, and how things like, of course, MRC is working on developing the multi-parameter fishing suitability index that includes all the relevant parameters forming into a single operational advisory layer. So, like, I think from the two, one of the things, common themes that for me was not just mentioned, but could anyways be directly inferred, was sometimes, or often at times, a bigger challenge is more of an institutional in nature rather than technological, right? On the technology front, as organizations again like MRC axiomatically show, is that the need is being future ready essentially means what? It essentially means that we need to move from a product or system centric approach to a solution driven architecture involving AI, ML, and something that was very, needed to be discussed, which was done yesterday, was maritime spatial planning, right? On maritime spatial planning, I think it was Cal's time yesterday, wherein for me, one of his key points was the need to resolve spatial conflicts on the MSP front across different underwater activities like offshore energy, mining, etc. Right? On the data point, which I think was mentioned by you, Commander Dasher, that we need to declassify data to the extent we can. I mean, when you gave the example of how US did during the World War era, I think so. The question then becomes on this: that how do we reconcile sort of dual imperatives of operational security with imperatives for us researchers and tech innovation industry, right? So, and then comes into play that what sort of organizations, NIOT, NPO, or others need to be involved in considering this exercise. On institutions, again, I think, again, you made certain points that need to be reiterated. In fact, I think this seminar could be a solid foundation for which one can write a very interesting paper on what are the institutional challenges that we face right now in the UDA space. The first was, which you mentioned again, that how waste-driven IMO regulations are inadequate. You use the word catastrophic, which sort of I agree with, because of course the conditions of the tropical waters of Iowa are quite different compared to temperate waters, and how frameworks like IDEX, of course, innovation framework, how initiatives like that need to take into account the current tropical water realities. And that one thing that I was really surprised by was that, which I didn't know again, was that how certain UDA aspects, elements of assets, whatever you want to call, are over-regulated, and how certain aspects are not even looked at, like the Ministry of Earth Sciences example that you gave on MSP front. That was quite striking to me. I never imagined that Ministry of Environment wouldn't be aware of it. Yes, but one of the things that Admiral Karambir also suggested, which caught my attention, was the need to have seabed warfare strategy. He gave a data example of the fact that 80 to 90% of our undersea cables are currently utilized, and the utilization rate will increase in the near future, right? So, in a future contingency, like which just happened right now, is the fact that if push comes to shove, India won't be able to reroute it, the data in a contingency, let's say 10 years down the line, right? So I think, and of course, the vulnerability, I'm not sure if it was mentioned in particular yesterday. The main, one of the clear signs of vulnerability to our undersea cables was highlighted in 2023 when this Houthi attacks in Red Sea. Their attacks actually increased our national data traffic latency since two of the cable networks connecting India to West Asia and Europe were cut, right? And one of the things on undersea cables, it's again very surprising. I was just discussing about this with Karis team. If you look at our national cybersecurity policy of 2030, if you look at National Critical Information Infrastructure Protection Center, the mandate of it, there's somehow no mention of, not even a single mention of undersea cables in cybersecurity threats and terrorism. So what this again basically means is that there's no official plan, policy, or designated entity to protect our undersea cables, right? So I think one practical need is, of course, then besides on the institutional front, we need to have seabed sensor network to protect all the cables at their landing zones, right? And just quickly to tell some of my own inputs, because previously before ICWA, I was part of one New Delhi based organization, so I was quite involved in different UDA projects. So I'll just give you some of my inputs if I can. Some of them which are I think relevant to this very much seminar. One thing on the institutional front, which I've argued in my paper, which is not yet out right now, is the fact that I think we need to have a national UDA authority which has the representatives of Ministry of Defense, Ministry of Earth, Indian Navy, of course, DRDO, with not just the budget, of course, annual budget, but also one of the mandates should be, of course, to direct all the R&D priorities, both on the civilian side of the UDA and the defense side, across all relevant agencies, right? Second institutional suggestions that I make in my paper is that if you look at the different agencies under different ministries that are involved in the UDA space, I think MOD and MOES need to consider sort of a joint program under a formal MOU, if possible, between NPOL and NIOT, National Institute of Ocean Technology, to sort of work on acoustic data, to maybe even work on the deep sea and work on sensor placement, since NPOL is involved in that kind of work, and to maybe perhaps even take a shot at cable noise measurement and analysis system technologies, right? Quickly on the policy side, one point, I think we all know it's a reality, which I think Sir Vish hinted in his presentation or not, is the fact that if you talk to any startup head working on UDA space or otherwise on defense side, it's what's a very bitter reality is that for very promising startups, the small ones, if they want to apply for any IDEX challenge, they don't have the the capital to develop a prototype, right? And IDEX only gives you funds once you win the IDEX challenge. And if a startup goes to a bank or a venture capitalist, generally the answer is the same, that you show the order first and then we give you the capital, right? So in that scenario, what I've argued in my paper is that MOD perhaps needs to consider sort of provision, whether in, I don't know, DAP or IDEX or in any other TDF or in any other scheme, that you compensate at least a certain percentage of NCNC trial cost for startups, for R&D firms, right? Needed for prototype development, right? And quickly, thirdly, on the last point on the sonar front, I don't know if this was mentioned today or yesterday. I think I heard side scan sonar multiple times, but I'm not sure if anyone mentioned multiple aperture sonars. So if you look at the West, if you look at the US in particular, and if you look at the current undersea surveillance constraints that India faces, basically, is if you talk about institutes like NPOL, NSTL, I think we need to, because private sector is not much, it's not involved in sonar development at best at negligible level, right? So I think institutes like, for now, institutes like NPOL and NSTL, we need to go beyond forward-looking sonars towards multiple aperture sonars, which basically relatively multiple aperture sonars have much higher resolution range. They have much higher signal to noise ratio. They have much wider swath coverage of the ocean, right? So that's that. And to conclude, I mean, I want to thank Commander Das sir, MRC for, of course, organizing this very much needed and brilliant seminar. And I think in that sense, it's your organization's solid and again, much needed approach of multidisciplinarity, which is actually the need of the hour for our country in this UDA space, to basically essentially, I mean, develop an ecosystem that helps connect ideas with application, right? Through research, advocacy, industrial consulting, through tech innovation, through modeling, which your organization does. So yes, I really enjoyed the 2 days, and I'm thankful to MRC for organizing this seminar. I wish you, thank you, sir.
You talk about publishing, so I think you have a task at hand. Sir. Let me introduce formally DSP Verma. Sir was Chief of Material in the Indian Navy, which is the highest technical position, I think, for the young people, they may not know. And post retirement from the Indian Navy, he took over as the Director General of the Nuclear Submarine Project, where India has built an indigenous nuclear submarine. And it was under his leadership in 2009 when the submarine was launched. And Sir has worked tirelessly to make that happen, and he continues to support a whole lot of people like us. And he's been my mentor since 2000. Sir, over to you.
Yeah, I don't want to, put you through a lot of things, except that I really enjoyed being here for 2 days, complete before time and leaving after time, like a good student. I learned a lot, and being basically a practical engineer, you relate to, certain things which you have not seen. Of course, MRC, fortunately, these youngsters, they do call me for, going through some of their workshop, whatever they call it. I would like to just tell enough since you started. I think your quality has become better and better and better. So that's excellent thing. As somebody said, your papers are excellent. And nobody smiles, everybody's serious. Serious chap, that's been also. So, which means they're all working very hard. Okay, I think as far as what happened in the last 2 days, everybody's spoken, and so I don't have to add anything to it. They have not said anything wrong, so it's okay. I'm very happy to see young people from the NDA, especially naval officers. So you all know there's something below the ship also, right? And there's a submariner, so he knows it anyway. but below the submarine also there is something. And MIT, I was very happy that you learned so many things. I have one question what are you going to do with it? The question, you learned, you're going to do something with it. Yeah. So be in touch with MRC, right? Learn more. If it's fascinating, interesting, please take it up because we need people to get into the underwater region. It's a big thing. It is not just, whatever you've heard. There is a lot more. Okay. It is pretty exciting space. Dark, can't see. You have to go down there to feel, not even see. Right? I am also very happy to see from our sister services very strongly represented because, of course, since we were all talking on the land and down below, I didn't find it. The morning I saw an Air Force Wing Commander.
That's a come of India.
Oh, okay. So I was going to say it's good that we got this space also with us, but I don't see him today now. It did cause a lot of interest and it got me to sit here both days listening. There is a lot to be done. He brought out the issue of what was that 27. You brought out a thing about some vision.
Okay.
Vision 2047. Yeah. So it's important because we all have to fit into the national thing because all of us work in thing. I'm glad I'm out of uniform because now I'm able to work beyond the uniform and lots happening because I am also working with small groups of excellent researchers and thing and their ideas are sometimes so fantastic. The only problem we have is I don't know how to. We can do a lot on paper, but to bring it to a project level, the one thing is the basic thing is the money. But yesterday, Vish, he said there is no problem money, there's etc. So I'm more excited that money is not an issue. So we have to continue working to bring it to a project. Thank you very much for being more than even today at 5:30 after 2 days, more than 60% of the hall is still full. So that is a good sign. And we have one old man and a lot of young people still there. Thank you very much for being here. And I must again acknowledge that's Arnab. He said he knows me from 2000. So you know why he's so disciplined now. And he has been one who's been always wanting to do something new and glad he took it up as something after he left. And also the researchers, you chaps are doing good work. And what I would like to say is I can see the convergence now. If you remember my first two, I said, when are we going to converge? I can see the convergence now.